Okay, hello Cloud Gurus, and welcome to the Certified Solutions Architect Associate course for 2019. My name's Ryan Cronenberg. I'm going to be your instructor, and in this lecture we're going to talk about why you should learn AWS and why you should get certified with AWS. Now, if you already know that you want to learn AWS and you want to get certified, you can go ahead and skip this lecture. It's really an intro, but we will also discuss the different certifications that are available and the different levels of difficulty for each certification. So before we begin, I'll just tell you a little bit about me. Believe it or not, I'm an ex-immigration lawyer and I had no background in tech. I only got into tech after the global financial crisis, or as we call it in the UK, the credit crunch. And basically, I was a highly skilled immigration lawyer. I was helping people get visas to Australia, New Zealand, Canada, and into the United Kingdom. And then the GFC, or global financial crisis, hit, and suddenly all the work dried up, basically because people couldn't sell their houses, because there were no mortgages. People were no longer wanting to get visas to move countries. And so I was very highly qualified in an industry that had almost no demand. So I decided to retrain and get into tech. I was always interested in tech. So I went to night school. And I got my Microsoft and Cisco certifications, so my MCSE and my CCNA. And off the back of that, I landed a job at Rackspace in 2010. And working at Rackspace in 2010 was amazing because Rackspace was at war with Amazon. There was a huge war to dominate the public cloud. Amazon went on and won that war, but it was really, really fascinating to be in that space at that time. So while I was at Rackspace, I was quickly promoted to become a solutions architect. I stayed with Rackspace for another 12 months, and then I started moving around in the managed service provider space. And eventually I tried to get a job at AWS. So this was in late 2014, and I was trying to get as many AWS certs as I possibly could in order to get that job. But I found that there was just no good online training available, or at least I didn't think there was any good training available at that time. And I thought to myself, if I don't get this job at Amazon, I'm going to go on and create some courses. And that's exactly what I did. I didn't get the job. Turned out to be the best thing that ever happened to me. And so I founded A Cloud Guru. And we've taught AWS to 750,000 people and counting. And the way we do our courses is the best way to learn AWS is to get your hands dirty. So we're not going to do death by PowerPoint. We're only going to use PowerPoint where we have to cover the theory. But most of what you're going to learn is going to be going into the AWS console and building things yourself. And the reason I tell you my story is I want you to understand, if you don't have a background in tech, if you've never even logged into the AWS console before, don't worry. I've been there. I've done it. I know exactly how you feel. And by doing this course, not only will you learn how to use Amazon Web Services, but you also know everything that you need in order to pass your AWS Certified Solutions Architect Associate exam for 2019. So why should you get AWS certified? Well, it's extremely valuable. The certifications are required in order for AWS partners, such as consulting partners, to maintain certain levels of partner status. So, for example, a standard partner must have an employee with at least 2 associate certificates. A premier partner needs an employee with at least 20 associate certificates amongst its employees, as well as 8 professional certificates. So Amazon themselves drive value through the certification program by requiring their partners to have AWS certifications. So what AWS certs can you do? Well, let's start with the easiest one, which is the practitioner tier. So this is called Certified Cloud Practitioner. Now, by doing this course, you'll actually be able to pass the Certified Solutions Architect Associate exam, as well as the Certified Cloud Practitioner. So don't worry if you want to go ahead and start on the Cloud Practitioner. We do have another course on A Cloud Guru for that. It is quite a bit shorter, but we're going to cover everything that you need to know in order to pass your Certified Solutions Architect Associate exam. There's also the Certified Developer Associate and Certified SysOps Administrator Associate. Certified Developer Associate, of course, is aimed at developers, and SysOps Administrator Associate is aimed at system administrators, so Windows system admins or Linux system admins. Then we have the professional tier. So we've got the Certified Solutions Architect Professional and the Certified DevOps Professional. It used to be that you had to get an associate in order to go on to do a professional. So for example, if you wanted to do Certified Solutions Architect Architect Professional, you needed to have the Certified Solutions Architect Associate certificate first. Amazon have recently just changed that, so as of November 2018, that's no longer the case. You can go ahead and just sit the professional exams. I wouldn't do that if I was you. I would practice on the Certified Solutions Architect Associate and then Certified SysOps Administrator Associate before attempting the professional exams. You could know everything there is to know about AWS in the entire world and still fail those two exams. The reason is you have on average 2 minutes and 7 seconds to read each exam question and to come up with the right answer. So if you've got really bad time management, you will just run out of time. So they are really, really challenging exams. I would practice on the Certified Solutions Architect Associate first and Certified SysOps Administrator Associate. We then have the specialty tiers. So we've got advanced networking, big data, security, and the newest one, which is machine learning. So depending on your background, you may or may not want to do one of the specialties. Security is one of the ones that I teach. It is really, really fascinating and interesting, and it's lots of fun. I would recommend going on and getting security specialty, because who doesn't want to be secure in the cloud? Machine learning is really, really tough. I actually thought that exam was written in a different language because I don't come from a machine learning background, but that is the newest one that is available. So in terms of the difficulty levels between the exams, I'm going to start from the easiest to the hardest. Now, this is just based on my own personal opinion. I have run this by other students as well. I think the majority agree with me, but it really depends on your background. So Certified Cloud Practitioner is definitely the easiest, followed by Certified Solutions Architect Associate, followed by SysOps Administrator Associate, followed by Developer Associate. We then have Security Specialty. We then have Big Data Specialty. We then have Advanced Networking Specialty. Machine Learning Specialty follows that. And then we have the two hardest, which is DevOps Pro, followed by Solutions Architect Professional. So that gives you an idea as to the easiest to the hardest, and that's just based on my own personal opinions. So AWS release new features and services every year. In 2011, we had 82. 2012, we had 159 different services. In 2013, we had 280. 2014 had 516, and it's just exponential. 2015, we had 735. 2016, we had over 1,000. In 2017, we had 1,400, and God knows how many there are for 2018. It hasn't actually been published just yet. But that gives you an idea as the rate at which AWS innovate. And this is a great graph. I'll put a link in the resources section below to this article. It's a Business Insider article, and they got this graph from Goldman Sachs. And this is a percentage of spend in terms of the total market. So in terms of total IT budgets, how much is spent on cloud. So in 2015, we're at 4.3%. When we went up to 6.1% in 2016. 2017, 7.7%, and 2018 at 9.5%. Now, Goldman Sachs are predicting that an organization is going to spend 11.3% of their budget in 2019 on cloud, and it's going to keep going up. So you can see that cloud has a long, long, long way to go. We are talking decades worth of growth. So this is a fantastic industry to get into, and it's a fantastic place to get certified. Amazon themselves are dominating the cloud. It used to be back in 2016 that other cloud providers were made up more than 52% of the market. The other cloud providers are all dropping off, and it's really the big three that are competing. So Amazon, Microsoft, and Google, and Amazon are the clear market leaders. So getting certified in AWS is a great career move. The certifications are really, really valuable. Like I said, cloud has decades worth of growth to come, and it will give you a really, it's a really secure job and industry to work in, as well as being really highly paid. So this is a photo I took. Here's Andy Jassy. He's the CEO of AWS. And this is Amazon's own figures in terms of who dominates the cloud. So Amazon think that they own around 51% of market share, Microsoft at 13.3%, and Google at 3.3%. So seriously, anyone can learn AWS. Take it from me. Like I said, I never came from a tech background. I used to be a lawyer, and I went and taught myself tech by going to night school. I really enjoy tech. I really enjoy teaching, and anyone can learn it. We have students who are 15 years old all the way up to people who are 65 and on the verge of retiring, and they want to learn cloud and cloud computing. So this course, we're going to make it really, really easy and fun to learn AWS, and by the end of it, you'll be able to sit your AWS Certified Solutions Architect Associate exam and hopefully pass on the first attempt. So hopefully that's explained why you should learn AWS. It's the fastest growing public cloud on the planet. It's got hyper growth and it's a very safe industry to be in. The pay is fantastic. It's loads of fun. It's not as complicated as you might think. It's just like learning another language, which when you understand what S3 is and EC2 and cloud formation and all these other nouns are, it's really, really easy to talk about AWS and public cloud, and it's really easy to understand what other people are talking about as well. So everything you need to know to pass your exam will be in this course. You don't need any prior experience whatsoever, and you're going to have an awful lot of fun. So congratulations, you made it through the very first lecture. In the rest of this section of the course, we're just going to look at what you need in order to do this course, and then we're going to have a look at the exam blueprint. Then we're then going to move on to section 2. In section 2, we're just going to talk briefly about the history of AWS, and then we're going to talk about all the different high-level services, and then we'll move on to section 3 and we'll start getting our hands dirty with AWS. We'll log into the console and go into identity access management and start setting up users. So if you've got the time, please join me in the next lecture. Thank you.
Okay, hello Cloud Gurus and welcome to this lecture. So this lecture is for Udemy students only, and I'm going to show you how to find the resources for individual lectures because Udemy has changed the UI and some students have been complaining that they can't find the resources. So let's go over to Udemy. Okay, so I'm in one of my courses on Udemy, the AWS Certified Solutions Architect Associate course. And if you look down here, we can see the different sections. So we've got section 1, section 2, section 3, section 4. But go to section 4, we're going to have a bootstrap script here. If we scroll down, you'll be able to see if a lecture has a resource, it's got a little folder icon. If it doesn't have a resource associated with it, then it won't have that folder icon. And then all you need to do is click in here and then you can download the resources. If there are any resources missing in, if I say it's available in the resources section, you can't see it, please let us know either via LinkedIn or via Twitter. It's probably the best way to get in contact with us, or let us know on the A Cloud Guru discussion forums. So that's it for this lecture, everyone. Let's get started learning AWS.
Okay, hello Cloud Gurus and welcome to this lecture. In this lecture, we're going to look at the exam blueprint. So we all want to pass our Certified Solutions Architect Associate exam. And before we actually get started learning about AWS, it's worth going through the exam blueprint, which will cover what it is we need to know in order to pass our exams. So the exams are 130 minutes in length. You're going to have about 60 questions. Sometimes this can change, but hopefully it will never be more than 60. And they're all going to be multiple choice. Sometimes you have to choose one answer. Sometimes you have to choose two. It'll tell you in the question how many you have to choose. And your results are always going to be between 100 to 1,000, and your pass mark is 720. So you need to get a roughly about 70% in order to pass the exam. So always aim for 70%. The qualification itself is valid for 2 years, and the exam questions are all going to be scenario-based questions. So bear that in mind as well. They're never going to ask you, what is the name of simple storage service, which is S3, which you're going to learn as we go forward. They're going to give you much more advanced scenario questions and ask you about different use cases. So let's go over and have a look at how we can book our exams on the AWS website. Okay, so here I am in Google, and I'm going to type into Google just AWS Certified Solutions Architect, and I'm going to go ahead and hit enter. Make sure you click on the top organic link. Please do not click on my own adverts because you'll cost me money, but you'll see the top organic link is going to be aws.amazon.com. So we go ahead and click on there. You'll be able to see an overview of the exam. It does say down here that you should have 1 year's hands-on experience. Don't worry about that. We assume that you know nothing in doing this course and that you never even logged into AWS before. And we're going to give you all the tools and knowledge that you need to know in order to pass your exam. So down here, we've got everything we just covered. It's multiple choice and multiple answer questions. If you do need to choose more than one answer, it will tell you. 130 minutes to complete the exam. The exam registration fee is going to be $150 and the exam's available in a whole bunch of different languages. And you see down here it says ready to get started, schedule an exam at aws.training. So we'll go ahead and click on aws.training. If it doesn't do anything, you do need to enable pop-ups. I don't know why it does that, but let's go ahead and just open up aws.training. Now in here, you need to create your AWS certification account. When you do create this, you may want to use your work email address if you're going to link this back to your organization, or if you want some more flexibility, you might want to use your own personal address. It's up to you. But what you want to do is just go ahead and click here, AWS certification account, and then you want to either sign in, and if you don't have an account, you can create one just by clicking the sign in button, and it will take you to this landing page, and you just need to either add your email in there, and if you don't have an account, go ahead and create it now. So I've gone ahead and signed into my account. You'll see it's the AWS training and certification landing page, and in here you've got the ability to schedule a new exam, and down here you'll be able to see your recent activities, and you can actually go over to and see your previous exams. You'll see how many exams I've done since teaching AWS. I've done an awful lot, and I haven't passed everything. I have failed some other ones. Sometimes they're practice exams, sometimes they were beta when they first came out. In fact, these two ones that I did fail were the beta exams, but I went on to pass them later on. So you are in really good hands. I do know what I'm doing. I've passed an awful lot of AWS exams. Once you have passed your exams, you're going to get digital badges. Digital badges are badges that you can use in your signature. The more exams you pass, the more badges you get. And you'll be able to also go in here and click on benefits, and you'll be able to order certain things from the store depending on what exams that you have passed. So let's go ahead and have a look at how we can book our exams. If we click on home, we'll go ahead to schedule new exam. This will actually open up a new web page, which is the PSI exams web page. And in here, you'll be able to go and schedule your exams. When you are scheduling your exams, make sure you read them carefully. Make sure that it is, you might get two options. Like here, I've got the DevOps Engineer Professional Beta. I don't know if it's going to let me see the other DevOps Professional because I've only recently just passed that. Sometimes it will take a little while before you can resit the same exam again. But here you can see AWS Certified Solutions Architect Professional. So this is the standard exam. This is the beta exam. So do just make sure that you choose the one that is most relevant to you. For me, it would be AWS Certified Solutions Architect Associate, and that's what you want to find in there. And then all you need to do is go ahead and schedule your exam. And that's it. It's pretty straightforward. So now that you know how to schedule your exam, you're ready to move on to the next section of the course. In the next section, we're just going to have a high-level overview of AWS. Some exam questions are simply understanding what a service is, what its use case is. So the next section of the course is going to give you a high-level overview of every single service in the AWS console. After that section of the course, we're going to start getting our hands dirty. We're going to start learning about identity access management. So if you've got the time, please join me in the next section of the course. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. This lecture is on the history of Amazon Web Services so far. So before we begin, you're never going to go into an exam and be asked what year was EC2 created or what year was S3 created. This lesson is actually just to give you sort of context of where AWS is and where it's going and why it's so important to learn AWS. So why is AWS so powerful? Well, this is Andy Jassy, and Andy Jassy is the CEO of Amazon Web Services, and he said famously that invention requires two things. One, the ability to try a lot of experiments, and two, not having to live with the collateral damage of failed experiments. Now, I'll give you a perfect example. We at A Cloud Guru are a startup. We did everything serverlessly, and we literally had no budget to build our platform. We had almost no money in the bank whatsoever, and we were able to go and use AWS and build a platform that scales automatically with demand for little to no running costs. And that's the beauty of serverless. And we'll get into what serverless means throughout the rest of this course. But it also, going back before serverless, but with the invention of Amazon Web Services itself, it meant that startups could go and try out new ideas. And then if it didn't work, or they provisioned the wrong resources, you could just go in and terminate it. You didn't have to live with the failed damage or the damage of failed experiments. So before AWS and before the cloud, what used to happen is you would go and you'd get a server, and you get it from a provider like Rackspace, for example, and you'd be locked into 3 to 5 year contracts. So if you made a mistake, that was it. You were stuck in a 3-year or 5-year contract, and you couldn't necessarily get out of it. And also, renting servers is actually quite expensive, and even purchasing servers for a startup, if you're purchasing, let's say, 2 web servers, 2 database servers, a switch, some file
firewalls and a load balancer, you're probably going to be looking at about $20,000 just to get the equipment. And that can be an awful lot of money for startups. Now, when AWS came along, they started provisioning virtual machines, and you could go in and provision them instantly. You could do it at the click of a button. And you could just run that virtual machine for a couple of minutes and then terminate it, and you would only be billed for that hour in which it ran. So it meant that you could go in and start experimenting and doing lots of different things, and you didn't have to live with the collateral damage of failed experiments. So that is why AWS is so powerful. So let's go on to a brief bit of history about AWS. And in 2003, Chris Pinkman and Benjamin Black presented a paper on what Amazon's own internal infrastructure should look like. And they suggested selling it as a service and prepared a business case. And then AWS first launched SQS, and we'll cover off what that is later on in the course. But SQS was the very first service, and this basically is a queue service or a message service and allows you to decouple your infrastructure. And that was launched in 2004. Then AWS as a business officially launched in 2006, and they were really, really clever with the way they launched, because they basically targeted a lot of Silicon Valley startups. And by 2007, over 180,000 developers were on the platform. So they went after the developers first. They weren't going after the enterprise markets. They went straight for the developers. And all these startups like Dropbox or Airbnb, etc., started on AWS. And because they didn't have to raise huge amounts of money in order to, buy physical servers, they could just use Amazon servers. It made them the massive titans of business that they are today. And by 2010, all of Amazon.com moved over to Amazon Web Services. And by 2012, Amazon had their first reInvent conference. Now, reInvent is held in Las Vegas every year. It's typically just after Thanksgiving. It certainly has been for the last few years. We are there every year. Last year we had a stand. This year we'll probably have a stand as well. And there's also a big party at the end of reInvent called Replay, which is great. It's like the biggest tech party on planet. And at reInvent, what Amazon do is they go out and they release all their big releases for the year. So they'll release all the new services. So that's what reInvent is. In 2013, Amazon released the certifications. So you could start getting certified as a solutions architect, as a developer, as a SysOps administrator, etc. And they started with the associate levels, then they brought out the professional levels, and now they've brought out the specialty levels. And as of recording to date, there are currently 10 certificates that you can get. And by 2014, AWS was committed to achieve 100% renewable energy usage for its global footprint. So Amazon's data centers are mostly powered by renewable energy, or at least they're trying to get that way. I don't know if it's at 100%. Don't know if they hit that target, but they're certainly trying. And by 2015, AWS broke out its revenue, and they were making $6 billion per annum, and it was growing close to 90% year on year. Now that growth has slowed a little bit. I think last time I checked it was about 44%, but that might have been for the last quarter. But it is growing super, super fast. By 2016, they had a run rate of $13 billion, and by 2017, reInvent released a host of artificially intelligent services. So this was things like Lex. So these were services like Polly and Lex, and these are the things that power Alexa. They released SageMaker, which is a type of machine learning, and they released a whole bunch of different AI services. And their run rate was hitting $27 billion for 2017. In 2018, AWS launched machine learning certificates, and they had a heavy focus on automating and AI and ML. So that was all at reInvent in 2018. And then this year, just at the very beginning of the year, they've released the Alexa Specialty Cert. So you can now get Alexa certified as well. And there's a total of 10 certs available right now. So that's the history of AWS so far. We're still waiting on the 2018 run rate numbers, but I would expect them to be much bigger than last year. And it really is a great thing to learn. Amazon Web Services is going to be around for decades, and the demand is just going to keep growing as more and more businesses move their infrastructure to the cloud. And of course, more and more businesses will want AWS certified people. So by doing this course, you're going to get your AWS certification, and you're going to learn an awful lot, and hopefully have an awful lot of fun. So that's it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you.
Okay, hello Cloud Gurus and welcome to this lecture. In this lecture we're going to look at the AWS platform from a 10,000 foot overview. Now this is a real photo. Most of you may or may not know this, but this is a photo that was taken in February of 2018. This is when Elon Musk sent his Tesla Roadster to Mars. It actually overshot Mars and went to the asteroid belt. And this is a Hitchhiker's Guide to the Galaxy reference here. You can see on the screen it says don't panic. So we're going to have a look at AWS. We're going to have a brief look at all the different high-level services and some lower-level services. Don't panic, because there's an awful lot of services and you do not need to know every single service to pass your exam. I would wager now that there's very few people on the planet who know every single service in a lot of depth, just because there are so many. So please do not panic. So let's go and have a look at the AWS console in 2015. And this is what it looked like. And basically, when I first started recording the A Cloud Guru lectures in 2015, I'd go and I'd talk through every single service. So what EC2 is, what Lambda is, what S3 is. And the reason I did that was because all of these services were relevant, more or less, to the Certified Solutions Architect Associate exam. Let's have a look at what it looks like in 2016. In 2016, you can see that we've got more services. So we've got things like machine learning, we've got workmail, we've got a whole bunch of new services that are being added, like Elastic Transcoder, for example. And these services actually weren't all that relevant to the exam, but I'd go through and explain what they were anyway. This is what the console looked like in 2017, so we're getting more and more and more services. And when I started to record my lectures and talk about every single one of these services, the course was getting to be about an hour and a half long just on this section. And a lot of these services are no longer relevant to the Certified Solutions Architect Associate exam. So let's have a look at what the console looks like today. So this is what the console looks like today. Don't worry, in the next lecture, we're going to look at how you can sign up to the console using free tier. So if you haven't already signed up, I'll show you how to do that in the next lecture. And if you want to see all the services, you can click up here and go services, and you can group them or you can do them from A to Z. And if we scroll down, there's an awful lot of services. And if I was to go through and explain what each individual service was, let's say for 30 or 40 seconds, the whole course is this whole section of the course is probably going to take 2.5 hours. And I'm just going to be wasting a lot of your time because a lot of these lower level services are just simply not relevant to the Certified Solutions Architect Associate exam. Things like Amazon Connect or Pinpoint or let's have a look, Media Convert, any of these media services, Deep Lens, for example. None of these are relevant to the Certified Solutions Architect Associate exam. So what I am going to do now is, in this lecture anyway, is I'm just going to go through and just talk about the high-level services, so compute, storage, databases, migration and transfer, etc. And then we're going to look at the platform from that perspective. And then I'm going to show you what is relevant to the AWS Certified Solutions Architect Associate exam. One other thing I will show you is up here, you can change what region you're in, and we're going to have a look at what the different regions are in a second and what the difference is between a region and an availability zone. For the rest of this course, I would recommend that you use the US East Northern Virginia region. The reason for that is this is the oldest region and this is where all the new services come out first. This is also the region that actually goes down the most as well. So when you're building your production workloads, maybe use US East Ohio or some of the other US West ones, because Northern Virginia tends to go down once a year. But who knows, maybe that's all in the past. So let's have a look at the AWS high-level services, and we'll start with the global infrastructures. The global infrastructure is what we've just been talking about. It's the regions around the world in which AWS is based. On top of the global infrastructure sits a whole bunch of high-level services. So we've got compute. Examples inside compute might be EC2, might be Lambda, etc. And we are going to cover those off in the course. Storage, we've got things like S3. So this is where you put files into buckets. We've got different services in there, like EFS, for example. Again, we're going to cover it off in the course. Databases, this could be relational databases such as RDS. This could be non-relational databases such as DynamoDB. Migration and transfer is a way of getting things to and from AWS. It includes things like a Snowball, which we are going to cover. Network and content delivery is basically one of the most sort of fundamental parts of AWS. So things like VPCs, virtual private clouds, as well as CloudFront, their CDN. We're going to cover that in the course. Developer tools is not really relevant for the Certified Solutions Architect Associate exam. It is covered, as you might guess, in the Developer Associate exam. Robotics, blockchain, and satellite are all new high-level services that were released at reInvent for 2018. Not covered in the course. I really hope there's a robotics specialty at some point. That would be super cool. But it is a very, very new high-level service, not relevant for the exam. Management and governance we will cover. Media services we won't. Machine learning, so this is all the sort of AI, things like SageMaker, for example. You basically just have to be highly sort of aware of the different AI and ML capabilities for the Certified Solutions Architect Associate exam. They may ask you a question about one or two services, but you don't need to know it in a lot of depth. Where it does come up is in the new machine learning specialty cert, which I did actually just a couple of weeks ago, and it is super, super tough. We've then got analytics, we've got security, identity, and compliance. Security, identity, and compliance we will cover off in the very next section of the course, where we start to log into identity access management. We're going to start creating our users, groups, and roles. We then have mobile, not really relevant. AR and VR, so AR is augmented reality, VR is virtual reality, again not really relevant. Application integration as well as AWS cost management. Cost management can be a part of the Solutions Architect Associate exam. It's a big part of the cloud practitioner. We then have customer engagement, business applications, desktop streaming, IoT, and game development. So let's go ahead and start with the fundamentals, and let's look at AWS global infrastructure. So what's the difference between a region, an availability zone, and an edge location? So we'll start with the global infrastructure. So there's currently 19 regions and 57 availability zones around the world as of December 2018. And there's going to be 5 more regions and 15 more availability zones for 2019 that are currently announced. Of course, there's going to be more. Don't worry, you're never going to be tested on the number of regions and availability zones, but it is important to understand the differences between them, and also where they are, basically. Where's your local region? So before we look at a region, let's look at this. This is a data center, and some of you may have seen data centers before, some of you may have not. And an availability zone is essentially just a data center. That's what I want you to think of an availability zone as. So an availability zone is a facility somewhere out in the country, or it could be in the city, and inside that facility is a whole bunch of computer stuff. So servers, we've got SANs, we've got switches, we've got firewalls, we've got load balancers, we've got storage. Basically anything to do with cloud sits inside our data centers. So a data center is just a building filled with servers, and an availability zone is essentially a data center. Now, an availability zone actually may be several data centers, but if they're really close together, they're going to be counted as one availability zone. So one availability zone could be 2 or 3 data centers that are all within, say, a couple of miles of each other. That way, if there is a flood, it might take out all 3 facilities, so it might take out that availability zone. But then you'll have another availability zone that will be 100 miles away, and if it floods in one area, it's not going to affect the other area. So you're going to have different availability zones in different regions. So what is a region? Or a region is just simply a geographical area. So each region consists of 2 or more availability zones. So we have the London region, we have the Northern Virginia region, we have the Oregon region, we have Sydney region, Singapore region, we have the Tokyo region, etc., etc. So regions are just distinct geographical areas, and each region will always consist of 2 or more availability zones. An availability zone is simply a data center, and a data center is simply a building that's filled with computer stuff. So pretty simple stuff. So let's have a look at today's regions. We've got North America. North America consists of a whole bunch of different regions. So we've got Northern Virginia, Oregon, US West. We've got the Central region, which is Canada. US West that I'm talking about here is actually just for GovCloud. So GovCloud, you can see there's GovCloud US West and GovCloud US East. This is for government customers only. This is not for private corporations. So do bear that in mind. We then got the US East, which is in Ohio, and we've got US West in Northern California. We then down here have a whole bunch of different edge locations, and you're always going to have more edge locations than you will have regions. You might be thinking, well, what's an edge location? Well, edge locations are endpoints for AWS, which are used for caching content. So typically this consists of CloudFront, which is Amazon's content delivery network, and we're going to have a look at that in the S3 section of the course. But it's a way, let's say you've got a big file and you've got a user who's sitting in Sydney and the server that they're trying to get the file from is in New York. Basically, what happens is that user downloads it from New York. It is then cached inside the Sydney edge location. And then if somebody else from Sydney then tries to download that file, they don't need to get that file from New York. They can actually just get it from this Sydney edge location. And again, I'll cover this off in more detail when we go and do the S3 section of the course. What's important is that you understand that an edge location is not a region. It's actually just a sort of a smaller location that AWS have, and it's used for caching content. And there's always going to be more edge locations than there are regions. Currently, there's over 150 edge locations around the world. Let's have a look at South America. We've got a region in Sao Paulo, and then we've got a whole bunch of different edge locations around Rio de Janeiro and Sao Paulo as well. We then have the EMEA region, so Europe, Middle East, and Africa. So we've got the Irish region, which is one of the oldest regions inside Europe. We've got the London region, we've got the Frankfurt region, and the Paris region. We've got a whole bunch of new regions that are coming in EMEA. So we've got regions in Cape Town, in Sweden, in Italy, that are all coming online as well. And then we have a whole bunch of different edge locations there. In APAC, we've got the Singapore region, the Tokyo region, Osaka region, Sydney region, Seoul region, Mumbai region, Beijing region, and the Ningxi region. And then we've got a whole bunch of different edge locations as well. So what is it you need to know in order to pass your Certified Solutions Architect Associate exam? So we had a look at all these different high-level services. I'm no longer going to go into each individual service and explain, what SageMaker is or what EC2 is or what Elastic Transcoder is. We will go and explain the most relevant services throughout the course that will help you pass your exam, but we're not going to cover every single service on the AWS platform because that would be an entire course all unto itself. So what is it we need to know to pass our Certified Solutions Architect exam? Well, why don't we just start with what we don't need to know? So we don't need to know developer tools. We don't need to know robotics or blockchain or satellites. We don't need to know media services. We don't need to know mobile. We don't need to know AR and VR, application integration. We don't really need to know cost management. We kind of do a little bit. That's a bit of a touchy one, so I've made it fall off. But we will cover cost control on AWS because that is an important part of being a certified solutions architect. We don't need to worry about customer engagement, business applications, and IoT or game development. So these are the high-level services that you should, focus on in order to pass your exam. And of these high-level services, there's a bunch of core services. And these are the bread and butter of passing your AWS Certified Solutions Architect Associate exam. So we've got security, identity, and compliance, which we're going to do in the very next section of the course. We have compute, we have storage, we have databases, and we have network and content delivery. Compute is mostly just around EC2 and Lambda. Storage is going to be all around S3. Databases is going to be mostly RDS, as well as some DynamoDB and some Redshift as well. And I'll explain, don't worry if all these sound like foreign languages, we are going to learn what they are throughout the course. Network and content delivery is all Route 53, which is Amazon's DNS service, as well as VPCs, which is the way, it's like virtual private cloud. It's basically like a virtual data center where you're going to build everything. And basically, if you know Route 53 and you know VPCs inside out, you stand a very, very good chance of passing this exam. And like I said, security, identity, and compliance is going to be in the very next section. And in particular, you need to know identity access management inside out to have a good chance of passing your exam. So what are my exam tips? So you've learnt an awful lot already. Just understand the difference between a region, an availability zone, and an edge location. A region is a physical location in the world which combines two or more availability zones. And so you have a London region, you have a Sydney region, a Singapore region, etc. An availability zone is one or more discrete data centers, each with redundant power, networking, and connectivity housed in separate facilities. And then an edge location is just an endpoint for AWS, which is used for caching content. Typically, this consists of CloudFront, which is Amazon's content delivery network, and we're going to learn about that in the storage section of the course. So that is it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture, where we're going to sign up to an AWS free tier account. Okay, hello Cloud Gurus and welcome to this lecture. So this is a really quick lecture. This is going to show you how to sign up to the AWS platform. If you've never been to it before, just go to aws.amazon.com. If you have never visited it before, it will say create an AWS account. If you have visited it before, it will say sign in. So go ahead and click up here. Your screen may look different. It depends on what time of year that you're viewing it. Certainly around summits, it will look completely different. I'm filming this just after reInvent 2018. So I'm going to go ahead and click create an AWS account. That will take me to this landing page. If you don't see something like that, if you see something similar to this, so it's asking you to sign in, just click here to create a new AWS account, and that will take you to the same landing page as well. So it says create an AWS account, and I want you to enter your email address in here. This email address is going to be known as your root account login or root account address, and you'll always need access to this email address, so make sure you don't enter in a false email address. In here, you just go ahead and enter your password and then go ahead and confirm it. And then down here in your AWS account name, I want you to enter something that's meaningful to you. So I'm going to call mine A Cloud Guru 2019. And once you've done that, go ahead and hit continue. Okay, it's then going to ask you for your contact information. Change your account type from professional over to personal, or just make things easy for you because we're not going to use this as a production account. And then I want you to go ahead and fill in all your details. And once you've done that, click create account and continue. It will then ask you for your payment information. Go ahead and fill in your credit card details and then hit submit. So we now need to confirm our identity. What we need to do is just enter in this captcha code, so BNDFNB. So I'm going to enter that in here. Then I'm going to go ahead and click on contact me. That's then going to give me this unique 4-digit number, and Amazon are going to call my phone. And all I need to do now is basically enter that in when Amazon call my phone, and that will then go ahead and confirm my identity. Once you've done that, you should be able to see the following screen. And here we go. So our identity has been verified successfully. Go ahead and hit on continue. We then have our support plans in here. So we've got 3 or 4 different types of support plans. We've got our basic plan, our developer plan, our business plan, and our enterprise level support. I would go ahead and click on basic. This can be a very popular exam topic, knowing the differences between the 4 different support levels. Essentially, if you ever ask for wanting a technical account manager, you're going to need enterprise level support, and you have to be spending $15,000 a month in order to get enterprise support. So go ahead and click on basic. That will then load this screen saying, welcome to AWS, and you can personalize your experience. I'm not going to go ahead and do that. I'm just going to go ahead and sign into the console. So click into sign into the console. And there you go. You are now registered with AWS, and you're able to sign into the AWS console. And you will need to be able to sign in to do the rest of this course. So go ahead and sign in, and let's move on to the next lecture. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. So this is the very last theoretical lecture before we can start getting our hands dirty in the AWS console. So this lecture is on Identity Access Management. It's often referred to as IAM. You might be wondering what those 101s mean. Basically, in Australian universities, as well as some British and American institutions, when you're learning a new topic, it's, accounting 101 or engineering 101. So Identity Access Management 101 means that this is an introductory topic to Identity Access Management. So what is IAM? Well, basically, IAM allows you to manage users and their level of access to the AWS console. And it's really important to understand IAM and how it works, both for the exam and for administrating a company's AWS account in real life. Basically, if you're going to use AWS, you need to understand IAM, because IAM allows you to set up users, groups, permissions, and roles, and basically allows you to grant access to different parts of the AWS platform. So Identity Access Management offers the following following features. It gives you centralized control of your AWS account. It gives you shared access to your AWS account. It gives you granular permissions, so you can say, okay, I want people to be able to access this service, but I don't want people to be able to access that service. It gives you identity federation. What do we mean by that? Well, it just means that you can use Active Directory or Facebook or LinkedIn with identity access management. So potentially your users could log into the AWS console using the same username and password that they use to log into their Windows PCs. So that's just using Active Directory. Or it could mean that your end users, let's say you have developed a mobile game or something and it's storing information on AWS, they can do that using their Facebook credentials or their LinkedIn credentials, etc. IAM also gives you multi-factor authentication. This means that when you're logging in to the AWS Management Console, you need a username, a password, and then a special code in order to log in. And then it also provides temporary access for users or devices and services where necessary. And a good example of that, again, is if someone's using a mobile phone app and they're storing data in your AWS account, you only want them to be able to do that when they're using the app itself. So it's temporary access. It also allows you to set up your own password rotation policy. So you may want your users to rotate their passwords every 3 months or every 3 weeks, entirely up to you. And it integrates with many different AWS services, and it supports PCI DSS compliance. So PCI DSS compliance just is basically a compliant framework that if you're taking credit card details, you need to be compliant with the framework. So IAM supports PCI DSS. So we're going to learn some key terminology for IAMs, really 4 key terms that we need to learn. So one is users, and this is just simply end users such as people, employees of an organization, etc. We then have groups. So this is a collection of users. So each user in the group will inherit the permissions of the group. So you might have a group that is able to access S3, and you might have another group that's able to access EC2. So long as that user is in that group, that user will inherit the permissions of the group. We then have policies. Policies are made up of these things called documents, policy documents, and these documents are formatted in JSON, so JavaScript Object Notation Language, and I'll show you what that looks like later on. And it basically gives you permissions as to what a user, group, or role is able to do. So policies are your permissions. And then roles are basically you create a role and you assign them to a AWS resource. A role is a way of allowing one part of AWS to do something with another part. So you might give a virtual machine inside AWS the ability to write files to S3, which is a type of storage within AWS. We're going to have a look at that in the EC2 section of the course, so that is coming up. So what is the best way to learn IAM? Well, like anything with AWS, the best way to learn is by getting your hands dirty. So that's the end of this lecture. If you've got the time, please join me in the next lecture where we're going to log into the AWS console. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus and welcome to this lecture. So it's our very first lab. We're finally going to start getting our hands dirty with AWS. And in this lecture, we're going to learn all about identity access management. As mentioned in the last lecture, this is one of the most important AWS services because this service gives you access to control permissions to all the other services and to also create users, groups, and roles. So let's go ahead and get started. Okay, so here I am in the AWS console. And if you look up here, you'll be able to see your regions. I know I did cover this off in the last section of the course. I would always suggest using US East as your main region, Northern Virginia. Like I said before, the reason for that is this is where all the new products and services are launched first. So this is always the most up-to-date region. This is also the region that goes down the most. So if we want to find identity access management, just click up on services. This will open up all the different services that are available for Amazon Web Services. I know it can be a bit overwhelming. Like I said, in the section 2, don't panic. No one person knows all of these services inside out, and only a small fraction of these services make up the Certified Solutions Architect Associate exam. Now we're looking for security. You can see it here. It's got the little shield. So security, identity, and compliance. And what we're going to go ahead and do is click on Identity Access Management. And that will take us to this splash screen. And you'll be able to see in here that this is the landing page. Now you've got a sign in link. This is the link that you can send to your users. It's simply your account number, then .signin.aws.amazon.com/console. You can actually go in here and customize it. So you could do an account alias of a cloud guru. If someone has already taken it, however, you're going to, it's a universal namespace, so you won't be able to take it. So I'm going to say a cloud guru 2019. God knows if this will actually be available. No, someone has stolen it from me. Maybe I'll take 2020. So 2020, hit create. Oh my God. All right, I'm going to do 2020 Ryan, something like that. No one would have taken that. So there we go. So this is now changed that URL, and this is actually a DNS change. So this is a publicly accessible URL that people can go into to sign into this account. Now, the very first thing we're going to do is activate multi-factor authentication, or MFA, on our root account. And you might be thinking, what is a root account? Well, a root account is just the username, is the email address that you first signed up with AWS with. And when you log in using the root account, you have what I would call God mode. You're able to do anything inside of AWS. Now, for that reason, you pretty much don't want anyone to log in using the root account. You want to create, a whole bunch of users and a whole bunch of different groups and put those users into groups. And you also want to secure this root account because it does have God mode access on it. So what you want to do is enable multi-factor authentication. So if someone steals your username and password, they will not be able to log in without multi-factor authentication. So to enable it, we just click in here and go to Manage MFA. And it says you are now accessing the security credential page for your AWS account. This is account credentials, provides unlimited access to your AWS resources. So just go ahead and hit continue. And in here, we can see the MFA, multi-factor authentication. And all you need to do is click on Activate MFA. And in here, you'll get the three different types. You've got virtual MFA, you've got a U2F, a security key, and you've got other hardware MFA device. I would just use the virtual MFA, and you can download the Google Authenticator app, and you can do that on the Google Play Store or on the Apple App Store. So just type in Google Authenticator. Once you've downloaded that, go ahead and hit continue. And I'm going to go ahead and click here, show QR code. Now, what I would do before you open that app is I'd take a photo of this QR code and store it somewhere safe. That means that if you lose your multi-factor authentication device, so if you lose your phone, for example, so long as you have access to this QR code, you can always re-enable MFA, and you don't have to worry about contacting AWS's support team. Okay, so once you've installed Google Authenticator on your phone, you'll see a screen that looks similar to this. You might not have any authentication codes in there. All you need to do in order to add one is to hit this little plus symbol and then go ahead and hit scan barcode. And there you go. You can see this is my lovely view from our London office. There's a whole bunch of Star Wars stamps, and all I need to do is then scroll this down and have a look at the QR code. And that has now added the new MFA to the bottom of my iPhone screen, which you can see here. And then all I need to do is go ahead and enter in my MFA codes in here. So I'm going to go ahead and do that now. It's 537624. And then I'm just going to wait for this MFA thing to change. And my MFA code's about to change, which is why it's gone red. And now I'm going to type in the new one, which is 770 and then 626. And then all you need to do is go ahead and hit Assign MFA. And you can see it now says you have successfully assigned virtual MFA. The virtual MFA will be required during sign-in. So go ahead and hit Close. And then you'll come back to this landing page. Notice in here you can change your password. This is to change your password for the root account. In fact, everything here is for your root account. So you probably want to come out of it. Just go ahead and click on Dashboards, and you can now see that we've got a new green tick. We've activated MFA on our root account. Before we go in and get more green ticks, I just wanted to point out up here that the region is global. So whenever you're doing anything inside identity access management, such as creating users or groups, it's on a global basis. They're not locked down to particular regions. You're not creating a user in Northern Virginia and then having to create the same user in Australia. So just bear that in mind as well. So the next thing we want to do is go in and create an individual IAM user. So let's click on that and go ahead and manage our users. I'm going to go ahead and add my user, and my username is just going to be my name, so Ryan.Krunenberg is what I'm going to put in here. And then I'm going to go ahead and select my AWS access type. Now, what we're using right now is called the Management Console, so the AWS Management Console. You can also enable programmatic access. So we're going to enable both just for this user. Now, we're going to use programmatic access in the EC2 section of the course. EC2 is just virtual machines. So that is coming up, but we won't cover it off in this section. But I do just want to show you what happens when you enable programmatic access. You're going to be creating an access key ID and secret access key, and you'll use these to interact with the AWS console. In here, we've got our password. I'm just going to do an auto-generated password. And in here, it says require a password reset. The user must create a new password at next sign-in. So not only does it auto-generate a password for that user, it's also going to make sure that they change it when they first sign in. Next, we're going to go ahead and add our permissions. We haven't created a group yet, so it's going to say add user to a group. Let's go ahead and create a group. And this group I'm going to call, in my group name, I'm going to call it developers. So developers. And my developers really need administrator access to AWS. And this is where we add our policies. And if it's got this little AWS logo here, it means it's an AWS managed policy. So we want to add administrator access. Now you can add based on different job roles. So in here you can see the type, job function, and then you've got AWS managed. Try scrolling to the bottom. I'm going to guarantee you it's going to take forever. That is how many policies there are. So we're going to do administrator access, but if I was to type in something like billing, you can see a job function is in billing in here. Or if you've got your database administrator is a job function. So there is a number of different job functions to save you time. If you want to know a list of all the job functions, just type into Google IAM job functions and it will give you the different types. So let's go ahead and create this group. We're creating the developers group and we're giving them full administrator access. That has now created our group, and now we're going to add this user to our group. And we're going to go ahead and hit next. And we're going to go ahead and create our user. That has now added our user. In here, you'll see that we've got our access key ID and our secret access key. This is for our programmatic access to AWS. You're only ever going to see this one time. So you can just click here and download a CSV file. So you see that's downloaded down there. Store that for later. We will go through and probably create an entirely new user when we get to that section of the course. And we can also email login instructions. And if you click on that link, it's going to open up your mail client and email them login instructions as well. And if you want to see your user's password, just click on the show button, which is off to the left of the send email link. So let's go ahead and hit close. We now have our user in here. So we've got Ryan.Krunenberg. He's a member of the developers group. And nothing else has been added. If we go back to our dashboard, we can see that we've created an individual IAM user, and we've also used groups to assign permissions. I just want to quickly show you a bit more into policies. So we added this administrator access policy to the group when we were creating the group. If you want to see more about the policy, just click on this little down arrow. In here, this is JavaScript object notation, or JSON, which we were talking about before. And it basically is a whole bunch of key value pairs. So this is the version of the policy. This is the statement. We've got our square brackets, and in here we've got our curly brackets, and we've got more key value pairs. So these key value pairs are under the statement. So this is what we call nesting inside JSON. So we've got effect allow. The action is a star, so a wildcard. So we're saying allow, and the action, we're allowing anything, and on which resource, well, we're allowing anything. So this is the most powerful this is the most powerful policy that you can have in AWS. You're saying allow you to do anything with any resource within AWS. So this is administrator access, or as some like to call it, God mode. So let's go back to dashboards. We've created an IAM user. We've created a group. And then the last thing we want to do is just apply an identity access management password policy. If we go ahead and click on manage password policy in here, we can now say that we want our minimum password length to be like 12 characters. We want one uppercase letter, we want one lowercase letter, we want at least one number, one alphanumeric character, etc. In here we can have password expiration, we can prevent our password reuse, and we can have that the password expiration requires an administrator reset. So you can change in here all the different password policies. I'm going to go ahead and just hit apply. And if we go and click on our dashboard, we now have 5 green ticks. So we've achieved 5 out of 5. Now, in case you're wondering where is my actual password that I need to send to my user, if you open up that CSV file, you'll be able to see in here, here's the password that's been auto-generated. Here's my access key ID. I want you to think of this as just like a username that we're going to use to programmatically access the AWS console. And here's our secret access key. Again, this is just like a password that we're going to use to programmatically access the AWS ecosystem. And then we've got our console login link. So all you need to do is send your user this console login link, their username and their password. If for some reason you lose that information or you didn't save it, click on users and then go ahead and click on the user in here. And then you can actually just click on their name and in here you'll be able to go in and change their security credentials by clicking up here. So we've got our security credentials in here. Our console password, we can go ahead and hit manage and we can actually just set it. So we can create our own custom one if we wanted. We can auto-generate a new one and we can even enable or disable the console. And likewise with our access keys, if you've lost your access keys, because I have shown you my access key ID and secret access key, straight away what I'm going to do is make inactive, because anyone who basically has access to your access key ID and secret access key could use your AWS account, so make sure you never share that. Now with your access key ID and secret access key, you can never use this to log into the console, you can only use the console password. And again, if this access key ID and secret access key doesn't make a lot of sense right now, it will make a lot of sense later on in the course when we actually go ahead and start using it. So I'm just going to make it inactive. In fact, I'm probably just going to go in and delete it for now, and we'll go ahead and provision it later. The very last thing I want to show you is roles. Roles are a way for one AWS service to go ahead and use another AWS service. So we're going to use this in the EC2 section of the course, where we're going to allow our little virtual machine to talk to S3. Let's go ahead and just create a role. So we're going to hit create role. In here, we're going to say choose the service that will use this role. So I would like to, it's going to be EC2, because that's what we're going to use in the very next section, in the 2 sections on. So I'm going to go ahead and hit next. And then in here, all I want to do is type in S3, and because we want S3 full access, we're going to use an AWS managed policy. Again, it's got the little icon there, which means it's an AWS managed policy. You can create your own policies, which are customer managed. We're not going to do that in this course. It's beyond the scope of this course, but it is definitely possible. Let's go ahead and hit next review. And the role name, just give it a unique name. I'm going to call it S3 underscore admin underscore and then access. And I'm going to go ahead and create the role. So that role has now been created. You can see it in here, and we're going to use it not in the next section, but the section after that. Okay, so what have we learnt so far? Well, we've learnt that IAM is universal. It does not apply to regions at this time. So when you create a user, you're creating that user globally. Same when you create a role or when you create a group. We learnt that the root account is simply the account created when you first set up your AWS account. It has complete administrator access, and it's always using your email address. So that's sometimes called the root account email address and the password that you configured. We also learnt that new users have no permissions when first created. We had to give our user Ryan Cronenberg permissions, and to do that we created a administrator access policy. We assigned that to the developers group. We also learnt that new users are assigned an access key ID and secret access key when first created. They use this to programmatically access the AWS ecosystem. And again, this is completely optional. You can just say, okay, I only want console access, or I want programmatic access. So those are the two different types of access. You can have one, you can have the other, or you can have both of them at the same time. So that's console access and programmatic access. We also learnt that the user access key ID and secret access key are not the same as the password. So you can't use the access key ID and secret access key to log into the console. You can only use it for programmatic access. And I'll show you what the programmatic access means and how it works later on in the course in the EC2 section of the course. And remember that you only get to view the user's password, their access key ID and secret access key once. If you lose them, you're going to have to regenerate them, so make sure you save that CSV file in a secure location. Always set up multi-factor authentication on your root account. Remember, your root account has God mode, so if someone hacks your email and they can do a password reset, you're going to be screwed. So you always want multi-factor authentication. The great thing is setting up multi-factor authentication on AWS is super simple. All you need is a smartphone, and you just need to download the Google Authenticator app, and then you can set up multi-factor authentication, which we saw right at the start of this lab. And then you can create and customize your own password rotation policies. So we went in and we made sure our passwords, had 12 characters. They had an uppercase letter, a lowercase letter, a number, and then a special character. So that is what we've learned so far in this lab. In the next lab, what we're going to do is we're going to go ahead and create a billing alarm. This will tell us if our AWS account is going to go over a certain threshold and give us an alert. So if you've got the time, please join me in the next lecture. Thank you.
Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to look at how to create a billing alarm. Now, most of the lectures in this course will be using AWS free tier. However, there are some lectures where you will not be using free tier, or we might exceed the limits of free tier. And in order to just alert us when we go over the amount, what we're going to do is go ahead and set up a billing alarm. So billing alarm is basically an amount that you set. Let's say it's going to be $10, and it will send you an alarm as soon as your AWS bill goes over that for the month. So this is a lab, and you will need to log into the AWS console. Okay, so here I am in the AWS console. I want you to just make sure that your region is set to Northern Virginia. So make sure it's in Northern Virginia. You can see all the different regions around the world here. And then what we're going to do is we're going to go over to a service called CloudWatch. Now, CloudWatch is exactly what it sounds like. It's a way of monitoring your cloud or watching your cloud. And you can find CloudWatch here under Management and Governance. And we're going to, it's the second one down, and go ahead and click on CloudWatch. And that will launch the CloudWatch console. And then what we want to do is we're going to go ahead and click on billing. And in here, we're going to create a billing alarm. So all we need to do is hit create alarm. Now, if you don't see this screen, it means that you've clicked the wrong create alarm button. So there's actually two. If you click this one up here, it's going to create a generic alarm. So go just hit cancel and then click the one down here, create alarm. And then you should see this screen. If you still don't see this screen, you can actually go back and you can select the metric, and then you just click into billing and you go total estimated charges, and then click on US dollars and hit select metric, and then you'll get this exact same screen. So hopefully everyone is at this point. I know it can seem a little bit confusing. And so what we're going to do is you can see here we've got our currency in US dollars. The period is going to be every 6 hours. It's going to be checking our account to make sure we haven't gone over that. We've got two different threshold types here. We've got static and anomaly detection. Anomaly is basically for detecting anomalies. We just want static. And we're just going to say whenever estimated charges is greater than, and then you enter in here the number 10 US dollars, then it's going to do an alarm. There's some additional configuration options in here, such as the number of data points that you want and how to treat missing data, but don't worry about that. Just go ahead and hit next. And then what we need to do is create an SNS topic. And SNS stands for Simple Notification Service. And we're going to cover that off a bit later on in the course. And what we want to do is just create a new topic. And so the topic in here, we'll just call it Billing Alarm. And in here, we enter in our email address. Oh, and it has to all be one word. And so in here, enter in your email address and make sure you enter a legitimate email address because you will have to confirm this. So I've entered in my email address. I have blurred it out because I don't want everyone emailing me. And go ahead and hit create topic. That will then create a topic, and you should get an email straight away basically telling you to subscribe to that topic. Go into your email, click on the link, and then you will be subscribed to that topic. Once you've done that, just go ahead and hit next. In here, we're going to enter our alarm name. So again, we're just going to call it billing alarm. And my alarm description, send me an email if my bill goes over $10. So there we go. Go ahead and hit next. And then this is a preview of it all. All you need to do is scroll down to the very bottom and then go ahead and hit create alarm. And so you can see here the action says pending confirmation. That means you need to go into your email and subscribe to that topic. And when you have clicked on that link in your email, you'll see something very similar to this, just saying your subscription is confirmed. Then if you go back to the console and you just hit the refresh button, you'll see that the actions are in there. At the moment, there's insufficient data. That's because we said, hey, check my account every 6 hours. So depending on your own account, it may take a little bit of time for this to turn into okay. But just wait and be patient, and that's it. You will now get an alarm every time your bill goes over $10. And so where this comes up in the exam is basically it's asking you how can you get automatic notifications if your account goes over like $1,000 or whatever. Well, the answer is you go into CloudWatch and you create a billing alarm. A billing alarm uses an SNS topic. We will cover that off later off in the course, but essentially an SNS topic is just basically a way of emailing you whenever your alarm goes over the $10 threshold. So that's where it will come up in the exam. And you can see it just went into an okay status as well. So that is it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you.
Okay, hello Cloud Gurus and welcome to this lecture. This lecture is on S3, and as I mentioned in the last lecture, S3 is one of the oldest AWS services and it makes up an awful lot of the Certified Solutions Architect Associate exam. So what is S3? Well, S3 basically stands for Simple Storage Service. So it's 3 S's, that's why it's called S3, and it provides developers and IT teams with secure, durable, highly scalable object storage. And S3 is easy to use with a simple web services interface to store and retrieve any amount of data from anywhere on the web. So what does that actually mean? Well, basically, S3 is a safe place to store your files, and that's all it means by objects. So when we say object storage, we're talking about things, flat files, basically. So Word documents, pictures, movies, etc., etc. So S3 is basically a safe place to store your files. It's object-based storage, and the data is spread across multiple devices and multiple facilities. And so the basics of S3 are as follows. It's object-based. It allows you to upload files, and your files can be anywhere from 0 bytes all the way up to 5 terabytes. There is unlimited storage, and files are stored in these things called buckets. Now, when I first heard about buckets, it sounded a bit strange, but a bucket is basically just a folder. That's all it is. So it's a folder in which to put your files. Now, the thing about buckets is that S3 is essentially a universal namespace. So buckets must be unique globally. And the reason for that is when you create a bucket, it's going to get a web address. So it's going to look exactly like this. It's going to say S3 and then hyphen, and then the region in which the bucket is, then dot amazonaws.com, and then / the bucket name, so a cloud guru. And so that's why the buckets need to be unique. Two people cannot have the same name because there's only one web address available. So you have to make sure your bucket names are unique. And when you upload a file to S3, you're going to receive a HTTP 200 code. And that's basically just saying that the upload has been successful. So that will come back to your browser. And that can be a popular exam topic as well. Moving on, I keep saying that S3 is object-based, and just to think of objects as files. And objects basically consist of the following. So we've got a key, and this is simply the name of the object, so the file name of the object. We then have the value, and this is simply the data that is made up of a sequence of bytes, so it's just the data. We then have a version ID, and this is important for versioning, and we're going to have a lab on versioning, but effectively S3 allows you to have multiple versions of your file. So you could have version 1, which says Hello Cloud Gurus, and then you could go in and upload a file with the same name and change the file so it says Hello Cloud Gurus, welcome to version 2 or something like that. And then you'll have both versions of the object in S3, and you'll be able to do version control. So you could go back to a previous version. So S3 allows you to do versioning. And like I said, we're going to have a lab on that. We also then have metadata. If you've never heard the term metadata before, it just simply means data about data. So it's data about the data that you're storing. So you may say, okay, this object belongs to the finance department. This is our payroll spreadsheet, something like that. And then it has a bunch of different sub-resources. So we have access control lists, and we also have torrents. We are going to cover off access control lists and bucket policies coming up. So now that you know what S3 is and that it's just a safe place to store your objects in the cloud, you really have to understand the data consistency model for S3 going into your exam. So how does S3 keep your data consistent? Well, basically, S3 has two things. It has read after write consistency for puts of new objects, and then it has eventual consistency for overwrite puts and deletes. Now, I know what you're thinking. What does that mean? Well, the first one, read after write consistency for puts of new objects, all that means is if you upload a file to S3, you are able to read it immediately. So you are able to read it straight after writing to it, and that's basically you're just doing a put of that object into S3. Now, if you were good to go in and basically update that object or delete that object, so overwrite that object, then it's only going to be eventual consistency. So let's say we've got version 1 of a file, and then we upload version 2, and you immediately try and read that object. Basically, what's going to happen is you might get version 1 or you might get version 2. But if you wait like a second, you're always going to get version 2. So there's an eventual consistency for overwrite puts and deletes. So only when you're overwriting a file or you're deleting a file, eventually it's going to be consistent. That's all that means. So you have read after write consistency for puts of new objects, and you have eventual consistency for overwrite puts and deletes. So in other words, if you write a new file and read it immediately afterwards, you'll be able to view that data. And if you update an existing file or delete a file and read it immediately, you may get the older version or you may not. Basically, the changes can take a little bit of time to propagate. So what are the S3 guarantees? What does Amazon guarantee from S3? Well, it's built for 99.99% availability, and Amazon will guarantee 99.9% availability. And Amazon guarantees 99.9999. I'm not going to say it, but basically this is referred to as 11 nines because there's 11 nines there. Durability for S3. So just remember 11 nines. And what does that mean? Well, that means if you put your object up in S3, it's very, very unlikely that it's going to be lost. It's only going to be lost 1 in however many nines that is. So it basically guarantees the durability of your object. And then S3 has this following features. So it's got tiered storage. So it's got different storage tiers. And this is a fundamentally important topic going into your Certified Solutions Architect exam. This is worth like 4 or 5 points. You need to know the different tiers, and we'll come on to that in the next slide. We also have lifecycle management, so you can actually go through and move your objects around 2 different storage tiers. So you could say, hey, when this file is 30 days old, move it to this tier. When it's 90 days old, archive it off to Glacier, and I'll cover what Glacier is in a second. It also allows you to do versioning, so you can have multiple versions of objects in your S3 buckets. You're able to encrypt your objects. You're allowed to encrypt them at rest, and there's different encryption mechanisms which we'll cover off in another lecture. Again, this is really important. You're able to use multi-factor authentication for deleting objects. So when you turn this on, if someone goes in to delete an object, they're going to need 2-factor authentication in which to do this. So they're going to need to use something like Google Authenticator. And then you secure your data using access control lists and bucket policies. And we're going to cover those off later on in this section of the course as well. So I talked about the different storage classes and how important they are to passing your exam. So let's cover them off now. So S3 standard, this is the one with 99.99% availability and 11 nines durability, and it's stored redundant across multiple devices in multiple facilities and is designed to sustain the loss of 2 facilities concurrently. So it is really, really highly available and highly durable. We then have S3 infrequently instantly accessed. And this is basically for data that is accessed less frequently, but requires rapid access when you need it. So you get a lower storage fee than S3, but you are charged a retrieval fee. So if you've got data that you need to be able to instantly access, but you pretty much don't use that data regularly, maybe you only need to check it at the end of every month, then you'd want S3 infrequently accessed. You then also have S3 one zone infrequently accessed, and this is when you want a really low cost option for your infrequently accessed data, and you don't even need, you don't have to worry about multiple availability zones. So it is literally just stored in one availability zone, and it's infrequently accessed, but you still need to be able to access that data instantly. And then at reInvent in 2018, Amazon released S3 intelligent tiering. This is a really cool technology. This is using machine learning. And basically what it does is it looks at how often you use your objects, and then it will move your objects around the different storage classes based on what it's learned. So it will move it from S3 standard to S3 infrequently accessed because it knows that you don't access those files. So that's S3 intelligent tiering. Those are the 4 storage classes. We then have Glacier, and Glacier comes in 2 flavors. So we've got normal S3 Glacier, and then we've got S3 Glacier Deep Archive. And so Glacier is basically for data archiving. So if you want to archive off your data, maybe you don't need it, maybe you have to hold on to it for 7 years because of some federal regulation, you would be using Glacier. Now you can store any amount of data, and it's really super cheap. And then your retrieval times are configurable from minutes to hours. Now with Glacier Deep Archive, that's the lowest storage lowest cost storage class that you can buy, but your retrieval time is going to be 12 hours. So if you want to get the data back using Deep Archive, you put in a request and it will come back 12 hours later. So those are the 6 different storage tiers. And you will need to remember those going into your exam. And so here is a table that compares the different storage tiers. The thing that you should really note is the first byte latency. That's how quickly you'll be able to access your data. So it's milliseconds for everything apart from S3 Glacier and Glacier Deep Archive. So it can be minutes or hours, or it could be up to 12 hours if you're using Deep Archive. So bear that in mind as well. So how are you going to be billed for S3? Well, you're charged in the following ways. You're charged in terms of storage. So the more you store in S3, the more you're going to be billed. You also charge on the number of requests. So if you're making a lot of requests to those objects, it's going to be more expensive. You then get charged on the storage management pricing. So this is the different tiers that are available. You then also get charged on data transfer pricing, and then you also get charged for transfer acceleration and cross-region replication. And don't worry, we're going to cover exactly what those 2 things are right now. So what is cross-region replication? Well, let's say you've got a bucket and it's in US East 1, and you want to automatically replicate your objects to another bucket that's in, let's say, in Sydney. And you want to do that for high availability as well as, disaster recovery. So what will happen is as soon as you upload an object to your bucket in US East 1 and you've got cross-region replication turned on, those objects will automatically be replicated over to your bucket in Sydney. And we're going to have a lab on that coming up. We then also have S3 transfer acceleration. This enables fast, easy, and secure transfers of files over long distances between your end users and an S3 bucket. And basically, it's taking advantage of Amazon's CloudFront's globally distributed edge locations. And then the data arrives at an edge location. It's routed to Amazon S3 over an optimized network path. And essentially what they're doing is they're using the Amazon backbone network. So let's have a look at how this works. We've got our users all around the world, and then we've got our edge locations. And essentially, if you turn on transfer acceleration, they are uploading those their files to the edge locations rather than to the S3 bucket itself. And then this goes over Amazon's backbone network, so Amazon's own network, straight back to where your bucket is located. and can really speed up your users' upload times. And we're going to have a lab on that, and we're going to see how it works from all the different locations in the world coming up in this section of the course. So you've done really, really well. We're at the end of this lecture. Let's look at my exam tips. So just remember that S3 is object-based. It allows you to upload files. Those files can be 0 bytes to 5 terabytes in size. There's unlimited storage, and your files are stored in these things called buckets. And a bucket is basically just a folder in the cloud. Now, each bucket has to have its own unique name, and that is to say that S3 is a universal namespace. So you must have a unique name for your buckets. And your link, when you create a bucket, it's going to generate a HTTPS link, and it's going to look like this. So it's going to be S3-EU West-1, so S3 and then the region, and then .amazonaws.com / and then your bucket name. Moving on, just remember that S3, because it is object-based, it's not suitable to install an operating system or a database on. So it's not, that's not that type of storage. For that, you will want block-based storage. This is object-based storage. So essentially, it's only used to store files. You're not going to install an operating system on S3, and you're not going to use it to host a database. And when you successfully upload an object to S3, you're going to get a HTTP 200 status code. Also, remember that you can protect your objects by turning on multi-factor authentication delete. That's really important to remember going into your exam. So that's how you can protect your objects so that somebody doesn't go in and accidentally delete them. They'll need to do multi-factor authentication. Remember the key fundamentals of S3. So what makes up an S3 object? Well, we have the key, and this is simply the name of the object. We then have the value, and this is simply the data and is made up of a sequence of bytes. We then have the version ID. This is important for versioning. We have metadata, which is data about the data that you're storing. We then have some sub-resources within here. So we've got access control lists and torrents. And that access control list basically is the permissions of that object. And you can lock each object down individually. So you can do it at a bucket level, and you can also do it at an object level as well. We're going to cover that off later on in the course. Now, this is really important to remember the consistency model. So it's read after write consistency for puts of new objects. So as soon as you create a new object, you'll be able to read that object immediately. But if you update an object or delete an object and you try and read it immediately, you're going to only get eventual consistency. So you might get the older object, or you might still see the deleted file. But if you wait about a second, it's going to be consistent. So you get eventual consistency. And pretty much the most important thing to remember going into your exam are the different storage classes. So we've got S3 standard. This is 99.99% availability, 11 nines durability. We then have S3 infrequently access. This is basically where you need, you're going to pay a lower fee than standard S3, but you need instant access, and you are charged a retrieval fee as well. We then have S3 one zone IA, or one zone infrequently accessed. This is where you want a lower cost option for your infrequently accessed data, but you don't require multiple availability zones. And just so you guys know, this used to be called RRS, or reduced redundancy storage. It is being phased out now, that terminology. But if you do see RRS, or reduced redundancy storage, in your exam, just think of it as S3 one zone IA. I literally just did the exam yesterday, and it was still on there, which I thought was a bit surprising. We then have S3 intelligent tiering, and this is basically using machine learning, and it will move objects around the different tiers of S3 to maximize your cost savings. We then have S3 Glacier. This is for data archival, and you can configure your retrieval times. It can be anywhere from minutes to hours. And then if you want the lowest cost storage available, then you want S3 Glacier Deep Archive. And this is Amazon's lowest cost storage class, where a retrieval time of 12 hours is acceptable. And then finally, the one thing I would say is go and read the S3 FAQs before taking the exam. S3 makes up quite a bit of the exam. It's going to come up an awful lot. So just have a read through the S3 FAQs. Now, of course, the best way to learn anything with AWS is to get our hands dirty. So in the next lecture, what we're going to do is going to go in and create an S3 bucket. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to go ahead and create our first S3 bucket. So this is a lab, and you will need to log into the AWS console. Okay, so here I am in the AWS console, and the first thing I want you to note is my region. So going forward throughout the rest of this course, I would recommend that you change your region to Northern Virginia. The reason for that is Northern Virginia is where AWS roll out all their new products first. If you select a region that's relatively new, such as Stockholm, you might not have all the products and services that are available to you. So what we want to do is we want to find S3. So S3 is a storage service, and it is under storage. So we're going to click on storage in here, and that will open up our S3, basically our console. Now you can see up here that this is already changed to global. So when you create a bucket, you do choose which region it is, but when you go and view all your buckets, you get a global view. So that's all that is. So let's go ahead and create a bucket. Now if you remember from the last lecture, I said bucket names must be unique. So if we type in test bucket, for example, and hit create, it's going to say that that bucket name already exists. So you must have a unique name. Now, someone has taken a Cloud Guru from me, unfortunately, but I'm going to do a Cloud Guru 2019. Let's try that. And in here, we can choose our region. So I'm going to do mine in US East 1, so Northern Virginia. And I don't have any existing buckets, so I'm not going to copy any settings. Let's go ahead and hit next. In here, okay, we can see that the bucket name already exists. I'm going to put my name after that. So 2019 Ryan. Oh my God, I swear this isn't my bucket. Somebody has just taken the name. So I'm going to do Ryan Kronenberg, and then I'm going to put pi in there, 3.1415, etc., etc. So there we go. Now I've got a unique bucket name. So in here, we've got all our different properties. I'm going to show you how to change this after we create a bucket. So we could turn on versioning, we could turn on server access logging, and this basically logs requests for your access to your bucket. We could start doing tags, we could do object level tagging, we could automatically enable encryption. You've got advanced options in here, so we can permanently allow objects in this bucket to be locked. I'm not going to do any of this. I'm just going to go ahead and hit next. In here, this is really important. This is quite a new screen, but basically, if you want to make any of your objects public, so if you want to be able to view them, you have to make sure all these boxes are unticked. Now, for now, we're just going to leave them all as ticked, and I'll show you how we can resolve that a little bit later. So let's go ahead and hit next, and this will just review all our settings. Let's go ahead and hit create bucket. So there we go. I've created my very first bucket. So let's go ahead and click in here. So this is a bucket. This is where we can upload our files. Why don't we go ahead and do that first? So let's click upload and let's go and add some files. Okay, so I've got two files in here. I've got a picture of me and Faye at Replay. Faye is our instructor for the Developer Associate and SysOps Administrator Associate, and I work with her in the London office. And I've also got a photo of me and my brother meeting Jeff Barr. Let's go ahead and hit upload. Now you can see here we're going to get a success, and this is basically sent back a HTTP 200 code to our browser saying that these objects have been uploaded successfully. So if we click on the first object, we'll be able to see a whole bunch of different information. So we can see in here the key, and so the key is its name. So it's called fayryanreplay.jpg. We can see the size. We can see if it's got an expiration date. We can see a whole bunch of different objects, a whole bunch of different data. And in here, you've got the object URL. So if we clicked on this and tried to access this object, it says access denied, access denied. Now, the reason this object is access is denied is because we haven't made this object public. So it's really important to understand that whenever you put stuff into S3, it takes quite a bit of work to make those things public. And I'll show you how we can make it public in a second. So I've just gone back. If I click back on my bucket up here, and if I click on here, I can go and do some actions to this object. So I can download, I can open it, I can change the storage class, I can go ahead and make it public. Let's go ahead and try and make this object public. So I clicked on make public, and you can see down here it says an error, 100% failed. Now, if you remember when we created our bucket, we had all those checkboxes. So if we go back to S3 and we click in here, we can go and edit our public access settings. And when you go and edit it, by default, these are now unchecked. So if you go ahead and hit save, it's going to ask you to confirm. So I'm going to go in and type confirm. And there you go. You can see now that objects can now be public. So the access level has been changed. So let's go back into our bucket by clicking in here. So the first thing I want to do is I want to make me and Faye's this object public. So I want to be able to view it. So I'm going to go to actions and I'm going to go down to make public. I'm going to go ahead and click on make public. You can see that has now been successful. If I click on the object and click on the link, it should load a picture of me and Faye. And there we are at reInvent for 2018. This is the big party at the end of reInvent's called Replay. And you can see we've got these shirts on that light up. So they were battery powered and basically lit up our logo. It was pretty cool. So I'm just going to go back and I'm going to go over to my bucket again. I'm going to do the same with the photo of me and Jeff. So I'm just going to go ahead and make public. And this is how you go ahead and make our objects public on an individual basis. So I click on here, we should be able to see there's me and my brother with Jeff Barr, and this was at reInvent in 2017. So let's go back to our bucket and look what else we can do on an object level basis. So we can go and click on here and we can go to the properties and we can change things like the storage class. So I could say, okay, I want this to use intelligent tiering. We can do this on an object level as well as a bucket level. So I'm going to do this on an object level. I'm going to turn on intelligent tiering. And so that has just done it for this object. If I click on here, you can see storage class intelligent tiering. Click on the one with Jeff, it's just standard. So far we're editing everything at an object level. If we wanted to change the properties at a bucket level, we would click up here. So these are the properties, permissions, and management. And I'm not going to go through every single one of these. We will cover off versioning in this course. We will cover off static website hosting, and we will cover off some parts of encryption. That's going to be the next lecture, as well as transfer acceleration. That's what you need to know. Those three are the main ones that you need to know in order to pass your Certified Solutions Architect Associate exam. If you want to learn all about S3, we do have a S3 deep dive course on the A Cloud Guru platform. In here, we control the permissions for our buckets. So this allows us to edit the public settings. We then can also do access control lists. Access control lists can go all the way down to an object, an individual object. So you could block one spreadsheet, but allow other spreadsheets to be read. Bucket policies work on an entire bucket level. So you could put a bucket policy in to make all objects in the bucket public, and we will do that when we create a serverless website at the very last section. Likewise, we'll look at cores in the very last section of the course when we create our serverless website. And in here we've got our management. This is where we set up lifecycle rules. This is where we set up replication, so cross-region replication. We are going to cover off both of these in this section of the course. So what have we learned about S3? Let's summarize. So onto my exam tips. What have we learned? We did cover off a lot of these in the last lecture, but I'm just going to remind you. So buckets are a universal namespace. You can't share the same name. When you upload an object to S3, your browser is going to get a HTTP 200 code. There's a bunch of different storage classes. You need to remember these going into your exam. So we've got S3, S3 infrequently accessed, S3 infrequently accessed one zone, and we then have Glacier. We have different flavors of Glacier depending on our retrieval times. And then finally, we learned that you can control access to your buckets either using a bucket ACL or using bucket policies. And we looked at that briefly. We will use bucket policies when we go to the serverless section of the course where we create a serverless website. So we will look at that later on in this course. So that is it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture, which is about encryption. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to learn about S3 security as well as encryption. So we learned in the last lecture that by default, all buckets when we create them are private, and that was those 4 little checkboxes. And you can set up access control to your buckets using bucket policies and access control lists. Now, bucket policies work at a bucket level, whereas access control lists go all the way down to individual objects. And S3 buckets can be configured to create access logs, which logs all the requests made to your S3 bucket. So if someone tries to access an object, that is going to be logged. And this can be be sent to another bucket or even another bucket in another account. So if you want to log who's accessing your objects in your S3 bucket, you can definitely do that. And you can store those logs in an S3 bucket in your primary AWS account, or you can actually set it up in a different AWS account. And so this is really, really important to understand the two different types of encryption, because you will be tested on this in the exam. So there's encryption in transit. Now, whenever you go and visit a website, if you're going to HTTPS, it means that the traffic is going to be encrypted in transit. So basically, between your computer and the server, that traffic is encrypted. No one who's eavesdropping on that will be able to break it and understand what you're looking at. That's why we use HTTPS. So encryption in transit is always achieved by SSL, or TLS as it's also referred to. So that's whenever you're browsing using HTTPS, that is encryption at transit. Encryption at rest is where we encrypt the data that's being stored. So let's say we have a Word document that's being stored on a hard disk drive. If there's no encryption at rest and somebody steals that hard disk drive, they will be able to access that Word document. So I'm talking about encryption at rest in terms of the way it works with S3. There's two different ways that we can do this. We can do it on the server side, or we can do it on the client side. The server side is where Amazon help you encrypt the object, and on the client side, it's where you encrypt the object and then upload it to S3. So let's look at it on the server side, and there's three different types. There's S3 managed keys. This is where Amazon manage the keys for you automatically, so you don't need to worry about the keys at all. When we talk about keys, a key is just a way of encrypting the object and then decrypting it. So it's just like you would use a key with a lock. So this is where Amazon manage all the keys. So that's S3 managed keys. It's sometimes referred to as SSE S3, which is server-side encryption S3. We then have AWS Key Management Service. This is where you and Amazon manage the keys together, and this is called Managed Keys Server-Side Encryption with KMS. And then we have server-side encryption with customer-provided keys. This is where you actually give Amazon your own keys that you manage, and you can encrypt your S3 objects doing that as well. And then, like I said, you can actually encrypt the object yourself on the client side. So you might do this on your Mac or your PC or whatever, and then you upload that object to S3. So there's four ways of really doing encryption. There's server-side encryption. So we've got SSE S3, SSE KMS, and SSE customer managed keys or customer provided keys. And then we also have encryption using client-side encryption, where you basically encrypt the object and then upload it to S3. So let's go ahead and have a look at how we can do this in the AWS console. I'm in the AWS console. If we want to go to S3, it's always under storage. So just go ahead and click in there. And we've got the bucket that we created in the last lecture. If we click in the bucket, we can go and click on our individual objects, and we can go and change the encryption by clicking in here. And here you can see we've got AES 256, or we can start using the AWS KMS service, and we can use our own custom keys, or we can use the AWS provided keys. So those are the three different types. Now, KMS is really beyond the scope of this course. We do cover it in an awful lot of detail in the Certified Security Specialty course. I highly recommend getting the Certified Security Specialty certificate. Who doesn't want to be secure in the AWS cloud? It is really, really valuable. So maybe check that out once you've passed your Solutions Architect Associate exam. So I'm going to click on AES 256, and I'm going to go ahead and hit save, and I'm going to go ahead and hit change. And that is it. It is simple. It is that easy. You can see in here it's been 100% success. Again, if I uncheck this and check on it again, you'll be able to see that it is now encrypted. So in the unlikely event that somebody was to run into or break into AWS's data center and somehow get a hard disk drive, my file was on that drive, they would not be able to decrypt this file. They can only decrypt it by using the AWS key. So that is it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to look at versioning. So before we get started, let's just see what we can do with versioning. So using versioning with S3, basically this is going to store all versions of an object, and including all writes, even if you delete the object. And we'll see that when we log into the console. So versioning is a great backup tool. And once versioning is enabled on a bucket, it cannot be disabled. It can only be suspended. So you can only suspend it. You can't go in and disable versioning. You have to delete the bucket and create a new one to completely turn it off. It also integrates with lifecycle rules. Now we're going to cover that in the next lecture as well. So we'll look at how we can use lifecycle rules and versioning to move things to Glacier. And versioning also comes with MFA delete capability. And this basically uses multi-factor authentication, which can be used to provide an additional layer of security to stop people from going in and accidentally deleting objects. So to permanently delete something, you would need multi-factor authentication to do that. So this is Lab. Let's log into the AWS console and have a look at versioning. Okay, so here I am in the AWS console. Now if I click on services, I can see S3 under storage. So let's go ahead and click on there. I'm going to create a new bucket for this lecture. I'm going to call it A Cloud Guru Versioning 2019 RJK, which is my initials. Hopefully that will be available. And I'm just going to go ahead and hit create immediately. Okay, there we go. So it's created my bucket. Notice the different levels of access. So by default, our bucket and objects are not public. If we go ahead and create a bucket, the bucket and the objects within them are not public. So we do want to change that because we're going to need to look at all the different versions of our files. So we want to just click in here and go Edit Public Access Settings. Make sure all these boxes are unticked. Go ahead and type the word confirm and go ahead and hit confirm. And that will then change your access levels so objects can now be public. So let's go into this bucket, and the very first thing we're going to do is turn on versioning. So if we go over to properties, you'll see versioning here. It's the very first box inside properties. And let's go ahead and click on here, and we can go and hit enable versioning, and we'll go ahead and hit save. Now notice that we can only enable or suspend, we can't turn it off. So we now have versioning enabled on this bucket. Now we don't have anything in this bucket, so let's go ahead and upload a file to this bucket. So I'm going to go ahead and hit upload. And I'm going to add this file, and it's just is hellocloudgurus.txt. And I'm going to go ahead and hit upload. So now that that has uploaded, let's make it public and have a look at it. So we'll just click on the object and go make public and hit make public. And then we can uncheck and then check again to get the link. And you can click on the link in here. And there you go. It says, hello, Cloud Gurus. This is version 1. So it's a very, very simple TXT file. So what I'm going to do is just go back, and I'm going to go back to my bucket, and we're going to upload a new version of this file. So I'm quickly just going to change this file. So let's change this file to say this is version 2. This is a better version, something like that. I'm going to go ahead and hit save, and I'm going to save anyway. And now I'm going to go ahead and upload this to S3. So I'm back in the console. I'm going to go and hit upload, and we're going to add this file, and let's add it again and hit upload. So that has now loaded the file. Now, the first thing I want to ask you is, what do you think has happened to the permissions on this file? Do you think this file is still public, or do you think it is changed the permissions? Well, if we click in there and we click on the actual link, you can see that the file is now is access denied. So it has, by uploading the new file, it has changed the permissions on that file. You can't access it. So you need to just go back and basically go in and enable it so that it is public. So we'll just go here, go to actions, make public, and make public. And there we go. And then I'm going to click on the link again and click on the link again. And here we go. We can see that it says, hello, Cloud Gurus. This is version 2. This is a better version. So if I go back, you want to be able to see the versions. And you'll notice that once we turn versioning on, we've got this versions sort of UI here that appears. And right now, it's not showing us the version. So if we click on show, we can now see our different versions. So we've got our version 1 here. And you can see the latest version here. And notice that they've got different version IDs. And also note the different sizes. So actually, the size of our S3 bucket now is the sum of these two different versions. So that's something to bear in mind from an architectural point of view. If you have versioning turned on in a bucket and you're making constant changes to large files, the size of your bucket is going to start going up exponentially. So do bear that in mind when you're architecting. Maybe you don't need versioning turned on, or maybe you need to enable a lifecycle policy to retire old versions quickly. We're going to look at lifecycle policies in the very next lecture. So let's go ahead and have, I'm going to go ahead and upload a third version. So we're going to have 3 versions. So I'm quickly just going to make a change to that text file. So it's in here, hello Cloud Gurus, this is version 2. Let's change this to version 3, and this is the best version. So best version. And then I might just add some random stuff in here just to make it even bigger. So I've saved that now, and what I'm going to do is go back over to S3, and let's go ahead and hit upload and hit add files, and we're going to upload this file and hit upload again. And now you will be able to see that this is now the latest version. It's 87 bytes in size. That was the previous version. And that was the previous version. Again, let's actually just test that we can access it. So if we click in here and then click on the link, you see we're going to get an access denied. So we do need to go and make that public again. So we'll click on here and go actions, make public, and go ahead and hit make public. One thing to note, if we go back to this version, the original version that we had, and we click on the link, we can see that it's version 1 and that it is still public. So when we're uploading the newest version, it's automatically going to be private, but the older versions permissions don't change as well. So let's click in here. We can see our 3 different versions. Now, if we wanted to get rid of a version or get rid of a file, let's actually just go to hide here. So we turn versioning off. If we were to click in here and go actions delete, what's going to happen is let's hit delete. So the bucket appears empty, but it's not actually empty if we go to show versions. And what we've actually done is we've just placed a delete marker over, and a delete marker is simply a new version. So we still have our 3 different versions in here, even though that we've deleted that file. And the way we would restore this file is if we go in and delete the delete marker. So let's go in here and hit delete and hit delete. And that has now restored it to the latest version, to version 3. Likewise, if we go in here and go actions delete, we can actually go in and delete this individual version. So we've actually deleted that version now. We haven't placed a delete marker over it because we've clicked on the show versions. And now this is the latest version, version 2. And if we click on that, we should be able to see version 2. So let's go to my exam tips. So what are my exam tips? Well, just remember that versioning stores all versions of an object, including any writes, and even if you delete an object, it's going to place a delete marker over that object, but the versions that existed before it will still exist. It's a fantastic backup tool, and once enabled, versioning cannot be disabled, it can only be suspended. It integrates with lifecycle rules, which we're going to look at in the very next lecture, and this is the most important for the exam. Just remember that versioning has multi-factor authentication delete capability, and this basically uses multi-factor authentication in order to delete a file. So if someone wants to delete a file, they'll have to provide MFA in order to do it, and this can be used to provide an additional layer of security. It's critical to remember that going into your exam. So now that we know about versioning, let's go ahead and have a look at lifecycle rules. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to look at lifecycle management with S3. So this is a lab, and you will need to log into the AWS console. Okay, so I'm logged into the AWS console. If you just go to S3, you'll be able to see the buckets that we created in the last couple of lectures. I'm going to go into my versioning bucket that has my objects in it, and I'm just going to go over to management. And in here, we can see our lifecycle rules. So let's go ahead and add a lifecycle rule. And it says here, you can use lifecycle rules to manage your objects. And essentially what it does is it's going to automate transitioning your objects to different tiers of storage. And then once you, when you specify it, it could expire your objects as well. So let's go ahead and hit add a lifecycle rule. I'm going to call it my lifecycle rule, something like that, rule. And I'm going to go ahead, and before I hit next, you could put in tags or prefixes in here. So if a specific object is tagged, it might be any object belonging to the finance department, for example. This lifecycle rule would then only apply to those tags. So bear that in mind as well. So let's go ahead and hit next. In here, we've got our storage class transitions. So we can have lifecycle rules enabled for just the current version or previous versions or both. Let's go ahead and do both. So we're going to do current version and previous version. And then in here, we add our transitions. So let's do a transition for our current version. So we're going to say from S3, normal S3, after the object is created, we're going to transition to standard infrequently access after 30 days. And we're then going to transition it from standard infrequently access to Glacier after 60 days. And then in here, we've got our previous versions of our objects. So we're going to add in a transition, and we'll do exactly the same. So 60 and 30 for these two different tiers. So there we go, 60 and 30. Let's go ahead and hit next. And then we can also configure expiration. So we can actually expire our objects in both current versions and previous versions. So we might want to do that 425 days from the date of which the object was created. And for previous versions, we're going to permanently delete a previous version also after 425 days. You can also click in here to say clean up incomplete multi-part uploads. This is when you're uploading a file in multiple parts and you split it up, and it will actually upload faster if you do it that way. But sometimes you can have files that just didn't get uploaded correctly. And so if you click in here, clean up incomplete multi-part uploads, it will basically go in after 7 days from the start of the upload and delete those files. So let's go ahead and hit next. We can review everything in here. So we've got our, the name is my lifecycle rule, the scope is across the whole bucket, and these are all our different transitions. And then we go ahead and hit save. And that has now created our lifecycle rule to the whole bucket. And you can see the actions for our current versions as well as for our previous versions. So that's all lifecycle rules are. You basically set up a lifecycle rule to move things around from different storage tiers and eventually archive it off to Glacier. You can also use it to permanently delete your objects as well. So what are my exam tips? So my exam tips, well, just remember what lifecycle management is. So it basically allows you to automate moving your objects between the different storage tiers. It also can be used in conjunction with versioning. So you don't need versioning turned on, but if you do have it turned on, you can use it in conjunction. So you can do it with your current objects as well as previous versions. And like I just said, it can be applied to current versions and previous versions as well. So that is it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to look at cross-region replication. So this is a lab, and you will need to log into the AWS console. Okay, so here I am in the AWS console, and if I just click on S3, I'll be able to see my buckets. Let's just create a new bucket just so I can show you. So we'll do cross-region replication, and then just some random numbers. I'm going to go ahead and hit create. Now, to enable cross-region replication, we need to go into the bucket. We need to go over to management, and we need to click on replication. And this is where we create our cross-region replication rules. So let's go ahead and add a rule. And you'll see that this bucket doesn't have versioning enabled, and cross-region replication requires versioning to be enabled on the bucket. So I can just click in here to enable versioning, but let's go back to the bucket that we created that we were doing with our versioning lab. So a Cloud Guru versioning in here. I'm going to go over to management, and I'm going to set up my replication rules. And the reason I'm doing this is I want to show you we've already got an object in the bucket. We've already got two versions of this object. And what we're going to do is we're going to enable cross-region replication. And what do you think will happen to these two objects? Do you think they'll be replicated automatically, or do you think we'll need to go in and do some changes? Well, let's go over to replication, hit add rule, and we're going to replicate the entire bucket. So I'm going to go ahead and do that. Of course, you can replicate based on prefixes or tags. So if you had a tag on an individual object, maybe the finance department, it would only replicate those objects. In here, we have no destination buckets. So you can click in here, and you could do it in buckets in an account or buckets in another AWS account. I'm just going to go ahead and hit create bucket. And in here, I'm going to create my DNS bucket. So I'm going to call it cross-region replication, and then whole bunch of random numbers, and then we need to select the region. Now, note that it will not let me select the region that I'm currently in. It has to be in a different region. Now, I'm going to replicate this to Ireland, so I'm going to pick the Irish region. So go ahead and hit, before I hit next, just note that you can change the storage class for your replicated object, so you might want it to go from S3 to S3 infrequently accessed, and you can also change ownership. I'm going to leave everything as default. In here, we need to select our IAM role. We're going to create a new role, which will automatically create a role within Identity Access Management, allowing us to do the replication. And in here, we've got to give our replication rule a name. So I'm going to call it CRR Ireland, something like that, Ireland. And I'm just going to go ahead and hit next. We can review everything, and then all we have to do is go ahead and hit save. Can take a few moments to set that up, but once it's set up, it is ready to go. So it will look like this. So you can see here our source, our destination, and our permissions, and we can edit the settings in here. If we go back over to S3, we'll be able to see our new bucket. So here it is. Note that it has automatically got the same permissions as the other one. And if we go into it, we can't see any objects. And if we even go and look at the different versions, there are no objects in there. So what this means is that when we set up cross-region replication, essentially it's not going to do the objects that are already in that bucket. So you would have to go in and upload those manually. Let's go and upload a file. So we're going to upload version 3. I'm going to go ahead and hit open and hit upload. And you can see that that's now the latest version. If we click on the file, we should be able, we're going to get the permissions error because we haven't made it public. Let's go ahead and make this object public. So go actions, make public, and make public. And so now if we go in and have a look at the file, we'll be able to see, here it is, hello Cloud Gurus, this is version 3, this is the best version. Let's go and see what has just happened with our bucket. So if we go back over here and we go over to cross-region replication, you'll be able to see it in here, and it is going to be the latest version. So as soon as we start making changes to a bucket with cross-region replication turned on, those changes will automatically be replicated. Let's go back to our bucket and go and have a look at the different versions. If we actually turn versioning off, or we'll hide versioning and go over to here and go actions delete, let's see if that is going to delete the object in the other bucket. So we can see it here. It's got a delete marker over it. We've got the 3 different versions. If we go back to S3 and go to our bucket with cross-region replication, you can see that the delete marker has not been replicated. So if you do put a delete marker in the your original bucket, it's not going to replicate that delete marker to the other bucket. And that's been done deliberately by Amazon to stop people from accidentally replicating deletes from one bucket to another. Let's try one last thing where we go in and delete the actual version. So if we go in here and we go ahead and we can delete our delete marker, so that will restore our object. And then if we actually go in and delete the latest version, let's see if that will automatically delete in the cross-region replication bucket as well. So if we go back over here and click on cross-region replication, you can see that it is still the latest version. So basically, once you turn cross-region replication on, it's not going to replicate delete markers, and it's not going to replicate when you go in and delete individual versions. So let's go over to my exam tips. So onto my exam tips. So just remember with cross-region replication that versioning must be enabled on both the source and destination bucket. Your regions have to be unique, and then files in an existing bucket are not replicated automatically. So we saw that when we turned it on, that file wasn't automatically replicated, but when we added a new file, that new file was automatically replicated to the region in Ireland. So all subsequent updated files will be replicated automatically. Also remember that delete markers are not replicated. So if you do a delete marker, it's not going to be replicated to your destination bucket, and also that deleting individual versions or delete markers will also not be replicated. So that is it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture where we look at transfer acceleration. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to look at S3 transfer acceleration. So what is S3 transfer acceleration. Well, we did talk about it in a little bit of detail in the S3 101, but essentially it utilizes the CloudFront Edge network to accelerate your uploads into S3. And instead of uploading directly to an S3 bucket, you can use a distinct URL to upload directly to an edge location, which will then transfer that file to S3. And you'll get a distinct URL to upload. So it might look something like this: acloudguru.s3-accelerate.amazonaws.com. And we're going to see that when we go over to Google. So just a reminder as to how it works. We've got a bucket, let's say it's in Ireland or in the UK. We've got our users all around the world. Our users will upload to an edge location first. That will then upload the file across Amazon's backbone network directly to our S3 bucket. And what's really cool about transfer acceleration is Amazon has built a tool that allows us to test it. So let's go over to Google and check that out. Okay, so I've typed in S3 transfer acceleration tool into Google, and you can see the link here. And it is actually hosted in an S3 bucket. So if you go ahead and click on it, it will load this page. And it's going to take about 5 or 6 minutes to actually start or to actually finish. But basically, it's going to compare your upload, doing it directly to all these different regions compared to if you turn on S3 transfer acceleration. So I'm just going to pause the video for 5 minutes and wait for this to finish. Okay, so that has now completed. So you can see if I'm based in London right now, and if I was uploading to S3 directly, that would be my speed. And if I used S3 transfer acceleration, then it would be 137% faster to Northern Virginia. It'd be 218% faster to San Francisco, 173% faster to Oregon. It's actually slower to Dublin, and this can be explained just by a sort of normal network traffic. So basically, the regions that are closest to you and where you physically are, sometimes it can be a bit slower. It really just depends. But in most cases, you can see basically everywhere it is faster. So that is S3 transfer acceleration. And in terms of my exam tips, just remember exactly what it is. So you've got your users, you've got your edge locations, and your users upload their big files to the edge locations, which then traverse Amazon's backbone network and will upload those files directly to your S3 bucket in the region that you specify. So that is it for this lecture, guys. If you have any questions, please let me know. If not, let's move on to CloudFront. Okay, hello Cloud Gurus, and welcome to this lecture. This is a theoretical lecture on CloudFront. So what is CloudFront? We have covered this off in a little bit of detail, but now we're going to deep dive on CloudFront. So CloudFront is a content delivery network, or CDN. And basically, a content delivery network is a system of distributed servers, or a network, that delivers web pages and other web content to a user based on the geographic locations of the user, the origin of the web page, and the content delivery server. So let's have a look at what a CDN looks like. So say we've got our website, which is hosted in London, and we've got our users who are all around the world. And our users, when they go to our website, they're going to go directly to London and pull that content down. So that's what happens when you do not have a CDN enabled. Basically, if you have your web servers in London and you've got all your media files, so your images, your videos, etc., every single individual has to go and essentially they're connecting into that server across the internet, and they're pulling those files down literally across oceans, and it can take time to load. So before we explore what CloudFront is and how it works, we need to understand some key terminology. I'm going to start with edge location. So I'm sure you know what an edge location is by now, but let's just explain it. So this is basically a location where content is going to be cached, and this is separate to an AWS region or availability zone. An origin is the origin of all the files that the CDN will distribute. So this could be an S3 bucket, an EC2 instance, an Elastic Load Balancer, or even Route 53. And in the next lecture, we're going to go in and we're going to use an S3 bucket as our origin. And then finally, we have our distributions. And this is the name that's given to the CDN, which consists of, essentially, it's a collection of edge locations. So we're going to create a distribution. We'll do that in the next lecture. So let's have a look at how CloudFront actually works. So now we've got our web server in London, we've got our users all over the world, and we've got our edge locations. Now, our first user will do a query to the edge location. It will say, hey, I want to watch this video. Do you have a copy of this video? If the edge location does not have a copy of that, what will happen is the edge location will download that video to the edge location and it will be cached there. And it's going to be cached for the time to live, which is always in seconds. And we're going to look at how we can configure that in the next lecture. So basically, it's going to be cached there, let's say for 48 hours or 72 hours. And what that means is if another user then queries that edge location for the same video, that video is already downloaded to the edge location, and that user will be able to download it a lot quicker because you don't have to go all the way to London to get it. It could be cached in US East 1, or it could be cached in South America or in South Africa, etc., etc., etc. So that's CloudFront, and that's how it works. It can be used to deliver your entire website, including dynamic, static, and streaming and interactive content using a global network of edge locations. And request for your content is automatically routed to the nearest edge location, so content is delivered with the best possible performance. So you get really good performance out of CloudFront. With CloudFront, you get two different types of distributions. You've got your web distributions. This is typically used for websites, and that's what we're going to do in the next lecture. And then you've also got your RTMP distributions. This is used for Adobe, and it's used for media streaming, essentially. So we will see that again in the next lecture. So what are my exam tips? Well, just remember what an edge location is. This is the location where content will be cached. This is separate to an AWS region or availability zone. Remember what an origin is. This is the origin of all the files that the CDN will distribute. This will can either be an S3 bucket, or it could be an EC2 instance, or an elastic load balancer, or Route 53. So just remember what that is. And then also remember that a distribution is the name that's given to the CDN, which is a collection of edge locations. And then a web distribution is typically used for websites, whereas RTMP is used for media streaming. And then finally, you should also remember that edge locations are not just read-only. You can write to them too, i.e. you can put objects to them. And we did that in the last lecture when we were using transfer acceleration. And objects are going to be cached for the time to live, the TTL value. And we'll look at how we can configure that in the next lecture. And then finally, you can clear cached objects. You can invalidate an object, but you are going to be charged if you do that. And that's a really important exam topic, that you can invalidate cached content. So if you've uploaded something and your users are still getting some old data and you've added new data, for example, you might have added a new video and they're still getting the old video, you can go in and clear those cached objects, but you are going to be charged. So it's called invalidating the cache. So that is it for this lecture. If you have any questions, please let me know. If not, feel free to move on to the next lecture where we're going to create our very first CloudFront distribution. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to go ahead and create our first CloudFront distribution. So this is a lab and you will need to log into the AWS console. Okay, so here I am in the AWS management console. First thing I'm going to do is just go over to S3. And if you remember from the very start of this section of the course, we created this bucket, and this had a picture of me and Faye, and then my brother and me with Jeff Barr. So those are our two images in there. We're going to use this bucket as our origin. So this is what we're going to attach our CloudFront distribution to. So to go and get CloudFront, it's not actually under storage, it's part of networking. So if we just scroll down, you'll see it in here, networking and content delivery, and you'll see CloudFront in there. So go ahead and click on CloudFront, and that will open up our CloudFront distribution. Now you can see straight away that this is a global service. So CloudFront is across the entire world. It's not done on a regional basis. And what we want to do is go ahead and create our first distribution. We have two different types of distribution. We've got a web distribution and an RTMP distribution. I'm going to go and do a web distribution. RTMP is used for media files using Adobe's Flash Media Server's RTMP protocol. That used to be an exam question. Doesn't seem to come up as much anymore, but just remember the two different types of distributions. Let's go ahead and do a web distribution. In here, we've got our origin domain name. And if you click in here, you'll be able to see all our valid origins. And so what I'm going to do is I'm going to click this one. So it was A Cloud Guru 2019. Our origin path, if you don't know what it is, you can click in there, but essentially if you have a directory inside your origin, so a specific directory inside your bucket, you can specify the path. I'm not going to go do that. Origin ID, I'm going to, it's going to set me up an origin ID. It's basically sort of, permissions to access our S3 bucket. I'm going to leave that as default. You can restrict your bucket access, so you can basically say that users will always access the S3 content using CloudFront URLs and not Amazon S3 URLs. And that can be quite useful when you're using signed URLs to restrict your content. I'm not going to do that. I'm just going to say no for now. And I'm going to leave basically everything as default. So you can scroll all the way down. Here's where you set your TTLs. You've got your minimum, your maximum, your default. So TTLs is just the time to live on for your objects in their edge locations. We can restrict viewer access, so we can say, hey, we only want people to be able to use signed URLs for our CloudFront distribution. So a good example of that is, say you're a media company, maybe you're like Netflix, and you want to make sure that only users who've paid for your content are able to access it. Just remember that going into your exam, that you can restrict access using signed URLs or signed cookies. I'm not going to do that. I'm just going to leave, like I said, everything as default. You can actually put web application firewalls in front of your CloudFront distributions. We're going to cover off what WAFs are later on in this course, but if you already know what that is, it's basically a layer 7 firewall, so you can do that to increase the security of it. Again, I'm not going to do that. I'm just going to basically leave everything as default and click create distribution. That is going to go and create and deploy my distribution. Now, this can take some time. It can take up to 15-20 minutes, sometimes up to an hour. It's also similar when you go and disable it. It takes time, and you need to disable it before you delete it. So I'm just going to pause the video, make myself some lunch, and come back when this is ready. Okay, so it's been over an hour and my distribution has now been deployed. So you can see the status down here is deployed. And we've got the ID and we've got the domain name. Now, this is the domain name that we would use to connect to our CloudFront distribution. So what I want you to do is just copy that into your clipboard. Just going to hit copy. And then we're going to go over to services, and we're going to go over to S3, and we'll be able to go into our S3 bucket. So mine one was called this. And I'm going to type the distribution's name / and then faye-ryan-replay.jpg into my browser. So I'm going to paste it in here, then /, so it was faye-ryan-replay.jpg. I'm going to hit enter, and there we go. It has loaded it, and loaded it very, very fast. So we now know that the distribution is working, and it's loading our assets from S3. Just going to go back over to the AWS console. If we go back over to CloudFront, again, it's always under networking. So here it is, CloudFront. I'm going to go back in and have a look at my distribution. Now, what you can do is you can click in here and you can go to your distribution settings and you can start editing your settings. So you can change your distribution after it's been deployed. And what I want you to really notice is this invalidation. So we can go ahead and create an invalidation, and we can invalidate individual objects or entire directories. Or entire subdirectories, etc., etc. So if you did something like / that would invalidate basically everything. So you can invalidate a distribution, and when you're invalidating it, it just means that it's no longer going to be on the edge locations. So if you get a scenario question in your exam where you're talking about, you push out some data and then you figure out something's wrong and you do an update, but it's not, showing up correctly, the way to, deal with that is to create an invalidation. So let's go ahead and delete this distribution because it's not covered in free tier. So I'm just going to go in and hit disable and hit disable. And that does actually also take some time. It can take up to 15 minutes. Once it's been disabled, then you can click in here and hit delete. So do that. Don't leave the distribution. We're not going to need it for the rest of this course. So what are my exam tips? So really, you just need to understand what CloudFront is at a high level. You need to understand what edge locations are. So it's a location where content's going to be cached, and it's very separate to an AWS region or availability zone. We have edge locations all over the world. You need to understand what an origin is, and this is basically just the source of the files that your CloudFront distribution will distribute. And this can either be an S3 bucket, can be an EC2 instance, can be an Elastic Load Balancer or Route 53, etc. etc., etc. Then we have our distributions. So this is just the name given to the CDN, which is a collection of edge locations. And our distributions can either be a web distribution, which is the one that we just set up, or an RTMP distribution, which is used for Adobe Flash Media Streaming. And then moving on, edge locations are not just read-only, so we saw that when we were looking at transfer acceleration. You can write to them too, so you can put an object on them. And objects are cached for the life of the TTL, so they're cached for the life of the time to live, and that's always in seconds. And like we just saw, you can invalidate cached objects, but you are going to be charged. So that is it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. This lecture is a theoretical lecture, and it's on Snowball. So you might be thinking, what is Snowball? Well, this is a snowball. This is what they look like. They're basically big disks. So a Snowball is a petabyte scale data transport solution that uses secure appliances to transfer large amounts of data into and out of AWS. So like I said, it's a big disk. It's a way of getting a huge amount of data into AWS, and you can also use it to export data from AWS. And using Snowball addresses common challenges with large-scale data transfers, including high network costs, long transfer times, and security concerns. Transferring data with Snowball is simple, fast, secure, and can be as little as 1/5 the cost of using high-speed internet. And Snowball basically comes in two flavors. You've got 50 terabytes or 80 terabytes. So Snowball uses multiple layers of security designed to protect your data, including tamper-resistant enclosures, 256-bit encryption, and an industry-standard Trusted Platform Module, or TPM, which is designed to ensure both security and full chain of custody of your data. And once your data transfer job has been processed and verified, AWS performs a software erasure of the Snowball appliance. And they do it in such a way that you can't just take a Snowball and restore the data from previous customers as well. It's completely wiped. So it's basically, they nuke it essentially. We also have a Snowball Edge. So Snowball Edge comes in 100 terabytes worth of data. And this is a device with an onboard storage and compute capabilities. So you can actually run like Lambda functions from Snowball Edge. And we're going to cover off what Lambda is later, but essentially this gives you compute and storage. And you can use Snowball Edge to move large amounts of data in and out of AWS as a temporary storage tier for large local data sets, or also to support local workloads in remote or offline locations. And to give you an idea, one of the major airlines, they do a lot of testing of the aircraft, and they actually have Snowball Edges in their aircraft. And this not just storing data inside the aircraft, but it's also doing compute. It's running like Lambda functions as well. So it's basically a Snowball Edge is kind of like having a mini AWS in your, at your disposal. So Snowball Edge connects to your existing applications and infrastructure using standard storage interfaces, streamlining the data transfer process and minimizing setup and integration. And Snowball Edge can cluster together to form local storage tiers and process your data on-premise, helping ensure your applications continue to run even when they are not able to access the cloud. So like I said, it's like having a sort of a portable version of AWS. So what is Snowmobile? Well, Snowmobile is just insane. It's an exabyte scale data transfer service used to move extremely large amounts of data to AWS. And you can transfer up to 100 petabytes per Snowmobile. And it's basically a 45-foot long ruggedized shipping container, which is being pulled by a semi-trailer truck. And it makes it easier to move massive volumes of data to the cloud, including video libraries, image repositories, or even a complete data center migration. And transferring data with Snowmobile is secure, fast, and cost-effective. So this is when you should use a Snowball. So basically, we're looking at different available internet connections here. So we've got a T3, which is 44.736 megabits per second. We've got 100 megabits per second, and then we've got 1,000 megabits per second. And if we were pushing 100 terabytes at those different speeds, you can see how long it's going to take. So it's going to take 269 days, or 120 days, or 12 12 days. So if you were basically going to use AWS Snowball with those three different speeds, over here is the different amounts that you should consider using Snowball. So 2 terabytes or more for this connection, 5 terabytes or more for 100 megabits per second, and then 60 terabytes or more for 1000 megabits per second. So that's all Snowball is. What are my exam tips? Well, just remember what Snowball is. Remember that Snowball can import to S3 and export from S3 as well. And that's really it. You really just need to, if you get a scenario-based question talking about moving large amounts of data into the AWS cloud, you want to use Snowball. So the next lecture is just a fun lecture. It's completely optional. It's where we actually get a Snowball and we connect it up, and then we basically copy some files to our Snowball and then send it off to AWS. That will not come up in your exam at all. So if you want to skip the next lecture, fine. But if you've got the time, please join me in the next lecture. After that, we're going to cover off Storage Gateway, and then we're going to summarize the rest of this section of the course. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. Like I said in the last lecture, this is an entirely optional lecture. This is a lab on Snowball. If you have your exam tomorrow and you're trying to cram, feel free to skip it. Likewise, if you don't really care about watching a Snowball in real life, feel free to skip this lecture and go on to the next one. So let's go over to the AWS console. Okay, so here I am in the AWS console. Now we'll find Snowball under here. It's under Migration and Transfer. And if you go ahead and click on Snowball, now I've got a couple of jobs here. The job that actually worked was called Please Send Me a Snowball. And we can see that I created the job, the appliance has been prepared, a shipment has been prepared, it's been shipped to you, and now it's been delivered. So it is actually here at this stage, so it's in my office. And by the time I send it back, we're going to put it in transit to AWS. It'll be at AWS, they'll be importing, and then it will be completed. Now, it's going to seem a little bit funny, but I'm basically just going to put a text file on this Snowball which says "Hello Cloud Gurus" and send that back to Amazon. So I don't know if they're actually going to see the data or not, but the data is only going to be in kilobytes in size, and it is a petabyte, petabyte size appliance. So they might just think I'm crazy. This was the other one that I had earlier on. This was for the Edge. And that was the one that they couldn't send me just because demand has outstripped supply, so that has been cancelled. Now you can go up here and create a job and go through all these different steps. So plan your job, we're going to import into Amazon S3. We can go ahead and keep hitting next over here. I'm not going to go through all this because you can do it yourself if you want, but you're just filling in things like your address details. You need to set up an S3 bucket for it. You need to set your encryptions, and then you're basically setting notifications, which is using SNS, which we'll cover later on in the course, but essentially it sends you automatic emails telling you that your Snowball is en route, and then you just review everything and hit complete. So what I'm going to do now, I'm just going to go back to the Snowball's landing screen, and I'm going to go here and I'm going to get the client. So I'll need the client in order to connect to my Snowball. So I am using Mac OS X currently, so I'm just going to go ahead and download that. And once it's downloaded, I'm going to go ahead and install it on my Mac. And then what we'll do is we'll look at the Snowball, see what it looks like, and how we can plug it in.
Okay, so here we are. We've got our Snowball. It has finally arrived. Like I said, this is not a Snowball Edge. It's just a standard Snowball. It is very big. It's very heavy as well, actually. I was surprised how heavy it is. I got quite out of breath just taking it upstairs. So let's have a look at what each individual component does. Okay, so this is the front of the Snowball, and you can see we've got this little thing just down here. It's like a little handle that we've got to open up. It says open this panel first. Flip it to lie on top of the case. And you can see my Snowball has been damaged by somebody else. AWS, if you're watching this, that's how it arrived. So what I'm going to do is just go ahead and open this panel and flip it back up onto the top of the case. And so all we do is we push in this little button here, push this up, and that opens up the top of the case. And then you can see in here, this is our Kindle that we're going to use in order to access our Snowball. Next thing we need to do is just turn it around. We've got to open up this panel on the back. We just click in this button, push it up, and in here we can see at the very top you've got the power cables and the Ethernet cables, etc. And so here's our power cables and our Ethernet cables. And what I'm going to do is I'm going to unwind all of this. I'm going to plug in the power, and then I'm going to plug the Ethernet cable into my router or router, whatever, however you wanted to pronounce it, whether you're Australian or American, downstairs. And then what I'm going to do is fire up the Snowball client. One thing to note is that the Snowball doesn't come with its own power lead. You do need your own adapter. It's just a standard kettle plug though, so we're just going to plug that in now. Okay, so everything's plugged in. And all we need to do now is go down here, and down just above the Kindle you can see there's a power button. So I'm just going to turn that on. And boom! It's quite noisy. So what I'm going to do now is I'm just going to go back over to my PC, and I'm going to go ahead and install the command line tools, and I'll show you how to do that.
Okay, and it actually took a little bit of time for my Snowball to be ready, but once it is ready, you'll see this ready screen. And you can see I'm using RJ45 or standard Ethernet in order to connect in, but you can also use SFP, and you can use copper or optical fiber as well. Okay, so now we've installed the Snowball command line tools, but in order to use it, we actually need to get our credentials. So we need to go into our Snowball dashboard, and then we just need to click in here and hit Get Credentials. And then you'll need these credentials to authenticate your access to the appliance. So this is my unlock code, and then this is my manifest file. So I'm going to download my manifest file, and then I'm going to copy and paste my unlock code into my clipboard, and I'm going to move that manifold file over to the same directory as my command line. Okay, so we need to start the Snowball service now. So I'm going to just type in / and then Snowball, and then what I need to do is do then it's start, and then what we need to do is the location, network location. So it's 192.168.1.116. We then need to link the manifest file. So we need to go -m, and then we need to type in the manifest file, which I think is that one. And there we go. And then what I need to do is then enter in my unlock code. And this is the unlock code for my manifest, so it's -u. And I just went back over to my browser and got it from the Snowball splash screen. And that should be it. Go ahead and hit enter. And that should start up my Snowball. There you go. So it says ready to transfer. When you're finished, run Snowball stop. So we're all ready to transfer over our appliance. So in order to do that, I'm just going to create a new file. So it's just going to be echo hello cloud gurus. I'm going to output that to a hello.txt file. So if we type in ls, we can see my hello.txt. If I nano hello.txt, you can just have a look and make sure it's in there. So there you go. I can't believe we're actually going to send this to Amazon on a Snowball. So I'm going to clear the screen. Okay, so now it's really, really easy to use. All I need to do is type in Snowball. Actually, let's just do it like this. So Snowball, and then copy. And then we need our file name, so it's hello.txt. And then we need the directory or the bucket namespace that we created for this Snowball job. Now, if you do forget it, you can come over here to your browser, go view job details, click on details, and in here you can see resources bucket. And so mine's called A Cloud Guru Snowball. So I'm just going to copy that into my clipboard, paste it in here, and then go ahead and hit enter. And there we go. It has now transferred my file over to my Snowball, and it is all ready to be sent back to Amazon. So we've created an 8-byte file. We've transferred it over to our Snowball, and now I'm going to arrange for Amazon to come and pick the Snowball up. We're going to send it back to AWS, and they're going to then transfer that text file over to my S3 bucket. So I really hope you have enjoyed this lecture, guys. Again, it's just good to know what a Snowball is at a high level and how it all works. If you ever do, go out and get one, they are lots of fun, but don't do what I did and just copy one single text file and then put it into S3. I might actually do a local backup of our A Cloud Guru directory, of our A Cloud Guru file server, and put that into S3, so I might not just send them back a text file, but we'll see. Okay, so if you've got any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to the very last theoretical lecture of this section of the course. So this is on Storage Gateway. Now, I'll be honest, I did the exam about 2 days ago, and Storage Gateway didn't come up. However, it used to be a very popular exam topic, and you should still know what it is because a lot of people do use Storage Gateway to move data into AWS. So what is Storage Gateway? Well, it comes in a bunch of different flavors, but basically it's a service that connects an on-premise software appliance with cloud-based storage to provide seamless and secure integration between an organization's on-premise IT environment and AWS's storage infrastructure. And the service enables you to securely store data to the AWS cloud for scalable and cost-effective storage. So what does that actually mean? Well, let's have a look at our data center. So we've got Storage Gateway here, and Storage Gateway is basically a virtual or physical device, and it's going to replicate your data into AWS. Now, it always used to be a virtual device, but they have released hardware appliances now, so you can actually have a physical Storage Gateway as well. So Storage Gateway's software appliance is available for you to download as a virtual machine image that you install on a host in your data center. And Storage Gateway supports either VMware's ESXi or Microsoft's Hyper-V as the hypervisor. So a hypervisor is just what you run virtual machines on. And once you've installed your gateway and associate it with your AWS account through the activation process, you can use the AWS Management Console to create the Storage Gateway option that is right for you.
So Storage Gateway comes in effectively 3 different flavors, and they are as follows. So we have our File Gateway, and this is either NFS or SMB.
We then have our Volume Gateway. This is using iSCSI. So File Gateway is basically a way of storing files in S3, whereas Volume Gateway is a way of storing basically copies of your hard disk drives or virtual hard disk drives in S3. And there's 2 different types of Volume Gateway. You've got your stored volumes, and then you've also got your cached volumes as well. And then finally we have Tape Gateway, and this is a virtual tape library. So let's go ahead and have a look at all of them. So we'll start with File Gateway. This is basically where files are stored as objects in your S3 buckets, and they're accessed through a network file system or NFS mount point. And then ownership, permissions, and timestamps are durably stored in the S3 in the user metadata of the object associated with the file. And once objects are transferred to S3, they can be managed as native S3 objects, and bucket policies such as versioning, lifecycle management, and cross-region replication can apply directly to objects stored in your bucket. So you can have all the goodness of S3. So it's basically a way of connecting your on-premise infrastructure to S3. So here's a good example. Got our application server here. It's using an NFS mount point to Storage Gateway that then connects in over the internet or over Direct Connect, which we're going to cover off later on in the networking section of the course, as well as Amazon VPC. And then it's going to store your files in S3. And this diagram is slightly out of date. It has S3 IA, doesn't have S3 with intelligent tiering, and it doesn't have the 2 different types of Glacier, but you get the point. It basically is a way of storing your application server's data into S3. So that's all File Gateway is. Volume Gateway is basically presents your applications with the iSCSI block protocol. So basically you can use virtual hard disk drives, and data written to these volumes can then be asynchronously backed up as point-in-time snapshots of your volumes and stored in the cloud as EBS snapshots. And the snapshots are incremental backups that capture only changed blocks, and all the snapshot storage is also compressed to minimize your storage charges. So Volume Gateway basically is a way of storing your virtual hard disk drives in S3, and it looks like EBS snapshots. Now, don't worry, we haven't covered off what EBS is yet. We will cover that off in EC2 in the very next section of the course. But just think of Volume Gateway as a way of storing virtual hard disk drives in the cloud. And it comes in 2 different flavors. We've got stored volumes, and this allows you to store your primary data locally. So you always have a complete copy of your data locally in your data center, and it's backing that data up to AWS. And stored volumes provide your on-premise applications with low latency access to their entire data set. So with stored volumes, it's really important to remember that it's the entire data set, and it's going to provide durable off-site backups. And you can create storage volumes and mount them on an iSCSI drive from your on-premise application servers, and then data written to your stored volumes is stored on your on-premise storage hardware, and this data is then asynchronously backed up to S3 in the form of EBS snapshots, and at the moment it's between 1 gig to 16 terabytes in size for stored volumes. If that has changed, don't worry about it. You're never going to be tested on, volume sizes in the AWS exam. It's always going to be scenario-based questions. So this is what it looks like here. We've got our users and our client. They're using the application servers. This then uses an iSCSI connection to our host. And this is our host is running our gateway virtual machines. And essentially, we're creating volumes on this host. And then what's happening is the virtual machine is then replicating these volumes up to AWS and storing it as snapshots in S3. Cache volumes is slightly different, so you do have to remember the differences between them. And cache volumes is basically, it doesn't do the entire data set locally. It is only doing the most frequently used data in your storage gateway. So cache volumes minimizes the need to scale your on-premise storage infrastructure while still providing your applications with low latency access to their frequently accessed data. So you can create storage volumes of up to 32 terabytes in size and attach them as iSCSI devices from your on-premise application servers. Now, your gateway stores the data that you write to these volumes in S3, just like the last one, and it retains recently read data in your on-premise storage servers gateway's cache and upload buffer storage. So it's between 1 gig and 32 terabytes in size for cache volumes. Again, don't worry, you'll never be tested on that. It's just important to understand that cached volumes is a way of caching the most actively used data, whereas with stored volumes, it's the entire data set. So again, here's a diagram. We've got our users, we've got our application servers. It's connecting in through iSCSI to our host, and our host is running our virtual machine gateway, a gateway VM. This is also accessing SAN, so storage attached networking, and again, that's just like basically a big disk. And then the gateway VM is replicating our information over to S3. So that's how that one works. And then finally, we have Tape Gateway. It offers durable, cost-effective solution to archive your data in the AWS cloud. So it's a way of getting rid of tapes. The virtual tape library interface it provides lets you leverage your existing tape-based backup application infrastructure to store data on virtual tape cartridges that you create on your Tape Gateway. So if you are already using tapes and different applications software that connects into tapes, you can actually replace your entire tape infrastructure and just use Tape Gateway. So it's a really great way of moving your backups to cloud. And so each tape gateway is pre-configured with a media changer and tape drives, which are available on your existing client backup applications as iSCSI devices. And you can add tape cartridges as you need to archive your data. And it's supported by really popular backup software like NetBackup, Backup Exec, Veeam, etc., etc. And this is what it looks like. So over here, we've got Data Center A, Data Center B. We've got our tape drives. This is running as a gateway virtual machine. So this is our storage gateway. And essentially, it's just replicating our virtual tapes to S3. And of course, then you can archive them off to Glacier as well to keep your costs low. So that is it for Storage Gateway. Like I said, I did the exam a couple of days ago, and it did not come up at all. It may well have just been moved over to the SysOps Administrator Associate. It is a critical subject to understand going into your SysOps Administrator Associate. That being said, it is also important to understand it if you do work as a solutions architect, especially if you're working with a company that's moving to AWS and they've got a virtual tape, they've got a tape library. It's good to know that you can actually leverage Storage Gateway to move that over to virtual tapes and replicate it over to the cloud. So what are my exam tips? Well, we've got File Gateway. This is NFS, and it's for flat files, and it's going to be stored directly on S3. We've got Volume Gateway, which is using iSCSI, and it consists of of two different volumes. So we've got stored volumes. Stored volumes is your entire data set to be stored on S3. Then we've got cached volumes, and this is where your entire data set is still stored on S3, but the most frequently accessed data is cached on site. And with stored volumes, the entire data set is stored on site. So that's the difference. Stored volumes is you've got your entire data set on site. Cached volumes is where you've only got your most frequently accessed data cached on site. And then we also have Gateway Virtual Tape Library. And I have been, like I said as well, we were talking about that these were virtual appliances or virtual machines. You can also get physical storage gateway appliances as well now. So that is it for this lecture, guys. You've done really, really well. You're at the end of the S3 and IAM section of the course. In the next lecture, we're just going to summarize everything that we've learned. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to the very last lecture in the S3 and IAM section of the course. So congratulations, you've completed your first theoretical and practical section of the course. So we're going to look at everything we learnt in this section. So we learnt that identity access management consists of the following. So it consists of users, groups, roles, and then you apply policies to these three different things. So you apply a policy to your users, groups, and roles. If you apply a policy to your group and you've got users within that group, they're going to inherit that policy automatically. Now, I know we didn't really cover off roles much in this section of the course. We are going to look at it in more detail in the next section of the course. We did create a role when we turned on cross-region replication. So if you actually go into IAM and have a look at your roles, you'll see a role there for cross-region replication. We also learnt about JSON. So this is what policies look like. So it's JavaScript object notation language. Now, IAM itself does not come up much in the Certified Solutions Architect Associate exam anymore. It's all been moved to the security specialty. That being said, you can't actually use AWS without knowing IAM. So it is really important to understand the core concepts of IAM and what users, groups, roles, and policies are. We also learned that IAM is universal. It does not apply to regions at this time. The root account is simply the account that's created when you first set up your AWS account, and it has complete administrator access. New users have no permissions when first created, and you'll find this is a theme within Amazon. It's called least privilege. So whenever you create a new user, that user is not going to have any rights or any privileges until you grant them privileges. Likewise, when we look at S3, when we create our bucket, it's locked down. It's not public, and making objects public is not that easy. You have to go through a process to do it. So that's a common theme within Amazon Web Services. New users are assigned an access key ID and secret access key when first created. These are not the same as a password. You cannot use the access key ID and secret access key to log into the console. You use it to access the AWS via the APIs and the command lines, however, and we are going to look at that in the next section of the course. And you only get to view your access key ID and secret access key once. If you lose them, you have to regenerate them, so make sure you save them in a secure location. So moving on, the final bits we learned about IAM is you always set up multi-factor authentication on your root account, and you can also create and customize your own password rotation policies. So moving away from IAM, let's look at S3. So remember that S3 is object-based. It allows you to upload files, and those files can be 0 bytes all the way up to 5 terabytes, and there is unlimited storage, and you store your files in these things called buckets, and it's basically just a folder in the cloud. Now, S3 is a universal namespace, so that means that your bucket names must be unique. You can't have test bucket because somebody already owns it. You can't have a Cloud Guru because somebody already owns it, and it's not me, sadly. And this is what the URL looks like when going to S3. So it's always S3, then the region, and then .amazonaws.com, and then / your bucket name. Now, remember that S3 is object-based storage, so it's not suitable to install an operating system on or a database or anything like that. And then when you upload objects to S3 or files to S3, your browser is always going to get a HTTP 200 status code that the upload has been successful. Now, by default, all newly created buckets are private. You set up access control to your bucket using bucket policies, and bucket policies are bucket-wide. And then you can also use access control lists, and these can go down to the individual files or objects in your bucket. Remember that S3 buckets can be configured to create access logs, which logs all requests made to the S3 bucket. And these can be sent to another bucket in the same AWS account, or even another bucket in another AWS account. And we go into that architecture a lot in the security specialty. There's certain ways you can design your AWS infrastructure to be super secure using multiple accounts. Moving on, the key fundamentals of S3. So basically S3, you've got a key, and this is simply the name of the object. You've then got a value, and this is simply the data, and it's made up as a sequence of bytes. So sometimes people refer to S3 as a key value pair. We then have the version ID, which we saw when we turned on versioning. We have metadata, so we have data about data that we're storing, and we do that through tags. And then you get some sub-resources such as access control lists and then torrents as well. Now remember the consistency model going into your exam for S3. So it's read after write consistency of puts of new objects and eventual consistency for overwrite puts and deletes. And this can take some time to propagate. And like I said, what does that mean in everyday language? Well, if you put an object into S3, you're going to be able to read it immediately. If you overwrite an object or delete an object in S3 and you read it instantly after that, you could get the old version or you could get the new version. So sometimes you will get eventually the right version, but sometimes it takes some time to propagate. Then, seriously, this is a big exam topic. It's worth at least 4 or 5 marks. You have to understand the different S3 classes of storage. So we've got S3 standard. That's what most people use. S3 infrequently access. So this is where you want the same sort of durability and availability as standard S3. But you want to pay a lower fee, but you still need instant access to S3 infrequently accessed. We then have S3 one zone infrequently accessed. This is what's only going to be in one availability zone, so you have to plan for that. But it is a much lower cost. S3 intelligent tiering uses machine learning to move your objects around depending on how often you use them. S3 Glacier is for data archival, and you can configure your retrieval time from minutes to hours. And then we have S3 Glacier Deep Archive, and this is basically Amazon's lowest cost storage class, but you will have a retrieval time of 12 hours. Moving on, let's talk about encryption. So encryption in transit is achieved by using HTTPS and TLS. So every time you go and visit, let's say google.com, if you've got a HTTPS in the browser, that means that traffic is going to be encrypted. So if someone is in the middle trying to listen to that, they won't be able to figure out what it is you're viewing on Google. So that's how we do encryption in transit. So in terms of how this relates to S3, whenever you go to aws.amazon.com and you go into the S3 console, so long as you're using HTTPS, all the traffic, all the files that you're uploading are going to be encrypted. So that's encryption in transit. Now, S3 also has encryption at rest, and this is achieved by both the server-side encryption as well as client-side encryption. On the server side, it's achieved by 3 different ways. So we've got S3 managed keys. This is where S3 just handle all our encryption for us, and we don't have to worry about it. We've got AWS Key Management Service, or KMS. This is where we can start using keys from the KMS service, and we cover this in an awful lot of detail in the Certified Security Specialty. And then we've got server-side encryption with customer-provided keys. So this is where you provide your keys and you manage the encryption and the actual maintenance of those keys. And then we also have client-side encryption. So this is where you encrypt the objects and then you upload them to S3. So that is encryption with S3 on AWS. Moving on to cross-region replication, basically you just need to understand what it is. It is definitely worth 1 or 2 marks in the exam. Versioning must be enabled on both the source and destination buckets. Regions must be unique. You can't do cross-region replication to the same region because then it's not cross-region. And then we have files in an existing bucket are not going to be replicated automatically when you turn cross-region replication on. All subsequent updated files will be replicated automatically. Delete markers are not replicated, and deleting individual versions or delete markers will not be replicated. So basically, going into your exam, it's really important to understand what cross-region replication is at a high level. and that's it really. Moving on to lifecycle policies. So what is a lifecycle policy? Well, basically, it automates moving your objects between the different storage tiers. That's all the policies are. And they can be used in conjunction with versioning, and they can be applied to current versions as well as previous versions. Moving on to S3 transfer acceleration. So we have our users, they're all around the world. We have our edge locations. Our users will upload their files to the edge locations first, and then those files will go over the AWS backbone network to S3. And we saw how mostly it can improve speed and performance. So if you do need to increase the performance of your, of your users being able to upload files to S3, look at S3 transfer acceleration. Moving on to CloudFront. So we learned what an edge location was. So this is the location where the content is going to be cached, and it's separate to an AWS region or availability zone. We learned what an origin was. This is the origin of all our files that the CDN will distribute, and this can either be an S3 bucket, an EC2 instance, an Elastic Load Balancer, or Route 53. And then we learned what a distribution was, and this is simply the name given to the CDN, which consists of a collection of edge locations. And then we have two different types of distributions. We've got our web distributions. This is typically used for websites. And then we've got RTMP. This is used for Adobe Media, and it's used for media streaming. Also with CloudFront, we learnt that edge locations are not read-only. You can write to them as well, i.e. put an object to them. So we looked at that with transfer acceleration. And then objects are cached for the time to live, or TTL, and that value is always in seconds. And then you can clear cached objects by invalidating them, but you will be charged. So do remember that. Snowball, seriously, you just need to understand what Snowball is. So basically, it's a big disk that you can use to move your data in and out of the AWS cloud. And Snowball can be imported into S3, so you can import data into S3. You can also use Snowball to move large amounts of data out of S3. Moving on to Storage Gateway. Now, I did this exam just a couple of days ago, and Storage Gateway wasn't there. That being said, it does come up actually in the Solutions Architect Professional exam. So it is just important to understand Storage Gateway, and it may well still come up in the Associates. It always used to. It did for 3 years, so I don't want to risk not teaching it. So we have the different types of Storage Gateway. We've got File Gateway. This is used for flat files that are stored directly on S3. And that's NFS. We then have Volume Gateway, that's iSCSI, and we have two different types of volume gateways. We've got our stored volumes, and this means that your entire data set is stored on site. So it's literally a 100% copy of your data being stored on site, and then it's backed up to S3. Then also have cached volumes, and this is where the entire data set is stored on S3, and only the most frequently accessed data is cached on site. And if you get those two confused, just look for the word cache. That's all you need to see, or cache, however you want to pronounce it, whether you're Australian or American. We also then have Gateway Virtual Tape Library, and this is used for backups, and it works with really popular backup applications like Net Backup, Backup Exec, Veeam, etc. And it's a great way of getting rid of your physical tapes. And then finally, I would read the S3 FAQ before going into your exam, because S3 is going to come up an awful lot in the Solutions Architect Associate exam. So that is it for this section of the course, guys. You've done really, really well. We're going to go and look at EC2, which is Amazon's virtual machine service in the next section. We're going to learn an awful lot. We're going to start using the command line. We're going to start provisioning web servers, and it is an awful lot of fun. So if you've got the time, please join me in the next section of the course. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. So this is the very last theoretical lecture before we can start getting our hands dirty in the AWS console. So this lecture is on Identity Access Management. It's often referred to as IAM. You might be wondering what those 101s mean. Basically in Australian universities, as well as some British and American institutions, when you're learning a new topic, it's, accounting 101 or engineering 101. So Identity Access Management 101 means that this is an introductory topic to Identity Access Management. So what is IAM? Well, basically, IAM allows you to manage users and their level of access to the AWS console. And it's really important to understand IAM and how it works, both for the exam and for administrating a company's AWS account in real life. Basically, if you're going to use AWS, you need to understand IAM because IAM allows you to set up users, groups, permissions, and roles, and basically allows you to grant access to different parts of the AWS platform. So Identity Access Management offers the following features. It gives you centralized control of your AWS account. It gives you shared access to your AWS account. It gives you granular permissions, so you can say, okay, I want people to be able to access this service, but I don't want people to be able to access that service. It gives you identity federation. What do we mean by that? Well, it just means that you can use Active Directory or Facebook or LinkedIn with Identity Access Management. So potentially your users could log into the AWS console using the same username and password that they use to log into their Windows PCs. So that's just using Active Directory. Or it could mean that your end users, let's say you have developed a mobile game or something and it's storing information on AWS, they can do that using their Facebook credentials or their LinkedIn credentials, etc. IAM also gives you multi-factor authentication. This means that when you're logging in to the AWS Management Console, you need a username, a password, and then a special code in order to log in. And then it also provides temporary access for users or devices and services where necessary. And a good example of that, again, is if someone's using a mobile phone app and they're storing data in your AWS account, you only want them to be able to do that when they're using the app itself. So it's temporary access. It also allows you to set up your own password rotation policy. So you may want your users to rotate their passwords every 3 months or every 3 weeks, entirely up to you. And it integrates with many different AWS services, and it supports PCI DSS compliance. So PCI DSS compliance just is basically a compliant framework that if you're taking credit card details, you need to be compliant with the framework. So IAM supports PCI DSS. So we're going to learn some key terminology for IAMs, really 4 key terms that we need to learn. So one is users, and this is just simply end users such as people, employees of an organization, etc. We then have groups. So this is a collection of users. So each user in the group will inherit the permissions of the group. So you might have a group that is able to access S3, and you might have another group that's able to access EC2. If so long as that user is in that group, that user will inherit the permissions of the group. We then have policies. Policies are made up of these things called documents, policy documents, and these documents are formatted in JSON, so Java Script Object Notation Language, and I'll show you what that looks like later on. And it basically gives you permissions as to what a user, group, or role is able to do. So policies are your permissions. And then roles are basically you create a role and you assign them to a AWS resource. A role is a way of allowing one part of AWS to do something with another part. So you might give a virtual machine inside AWS the ability to write files to S3, which is a type of storage within AWS. We're going to have a look at that in the EC2 section of the course, so that is coming up. So what is the best way to learn IAM? Well, like anything with AWS, the best way to learn is by getting your hands dirty. So that's the end of this lecture. If you've got the time, please join me in the next lecture where we're going to log into the AWS console. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you.
Okay, hello Cloud Gurus and welcome to this lecture. In this lecture, we're all going to learn about Elastic Compute Cloud or EC2. And so this will be a theoretical lecture. In the rest of this section of the course, it's extremely hands-on. We're going to be going into the AWS console. We're going to be provisioning EC2 instances. We're going to be SSHing into them, and we're going to be turning them into little web servers. So you are going to learn an awful lot. But before we do that, we should learn what EC2 is. So what is EC2? Well, basically, it's a web service that provides resizable compute capacity in the cloud, and it reduces the time that it takes to obtain and boot new server instances to minutes, allowing you to quickly scale capacity both up and down as your computing requirements change. Now, I've been in tech for quite a while, and I remember a time before AWS came along when if you placed an order for a web server, a database server, they were actually physically
physical servers. And certainly when I worked at Rackspace, that was definitely the case. And it would take anywhere from 10 days to do a deployment, sometimes up to 20 days. And at other companies I work for, it would be 6 months before we could deploy those resources. And of course, when you were paying for these, you were paying for the servers up front. Now, we could amortize the cost over a monthly basis, but you still had huge capital expenditure. And if you weren't using these web servers, you still had to pay. And then Amazon EC2 came along, and you were able to provision virtual machines in the cloud at this, seriously, the click of a button, and it would be ready within a couple of minutes. And it just changed the entire world. So how is EC2 priced? Well, if you've done the Certified Cloud Practitioner course, you'll remember in it we had a pricing section, and we looked at a particular white paper called AWS Pricing Overview. Now, don't worry, you don't actually need to read this white paper for the Certified Solutions Architect Associate, but it does have a principle that basically applies across all of AWS. And the conclusion of the white paper says, while the number and types of services offered by AWS have increased dramatically, our philosophy on pricing has not changed. You pay as you go, you pay for what you use, you pay less as you use more, and you pay even less when you reserve capacity. So EC2 has a number of different pricing models. We've got on demand, and this allows you to pay a fixed rate by the hour or even by the second with no long-term commitments. So you can literally just spin it up, have it running for a couple of hours, and then terminate the instance. And this is great for developers because you can go in, test an environment, see if it works, and then go in and shut it down. I couldn't imagine a world where that was not possible. Just 20 years ago, you would have to go in and provision big physical servers. You'd have to have the money to do it. And it means all these little startups that are operating on a shoestring budget could not have taken their product to market. So, AWS has changed the world by introducing on-demand pricing for virtual machines. We then have reserved, and this is basically provides you with a capacity reservation, and it offers a significant discount on the hourly charge for an instance. And the contract terms are 1 year or 3 years. So this is where you're going to contract with AWS to either a 1 year or 3 year term. And the more you pay up front, the more you're going to save. So we then have spot instances, and this is basically where Amazon have excess capacity, so not everyone's using EC2 at once. And what they do is they drop the prices of their EC2 instances to try and get people to use that capacity. However, when other people are provisioning on demand or other EC2 instances and they run out of capacity, they will want that capacity back. So the price moves around with spot instances. It's exactly like the stock market. It goes up and down. And basically, you set the price that you want to bid at. If it hits that price, you'll have your instances. If it goes above that price, then you're going to lose your instances within a couple of minutes. So it moves around a lot. And we'll look at the use cases for that in a couple of slides. We then have dedicated hosts. These are physical EC2 servers that are dedicated to you. And this can help you reduce costs by allowing you to use your existing server-bound software licenses. So if you've got some really strict licensing conditions with Oracle, for example, you might want to be using dedicated hosts. Again, we'll look at the use cases to that coming up. So we'll start with on-demand, and on-demand pricing is useful for users that want the low cost and flexibility of Amazon's EC2 without any upfront payment or long-term commitments. It's also good for applications with short-term, spiky, or unpredictable workloads that cannot be interrupted, and applications that are being developed or tested on for Amazon's EC2 for the first time. And we're basically going to be using on-demand for the rest of this course. So we're going to provision our EC2 instances, and then when we're finished, we're going to go in and terminate them. Moving on to reserved pricing. This is useful for applications with steady state or predictable usage, applications that require a reserved capacity, and users are able to make upfront payments to reduce their total computing costs even further. And reserved pricing comes in a number of different types. So we've got our standard reserved instances, and these offer up to 75% off on-demand instances, and the more you pay up front and the longer the contract, the greater the discount. We've got convertible reserved instances, and we're going to come to this, but basically the way EC2 works is you'll have a virtual machine, but you'll have different types of virtual machines. So you'll have ones that are very high RAM, with RAM utilization, or you'll have ones that have very, very good CPUs, and you can pick and choose, and they're called instance types. Now, with standard reserved instances, you can't convert one reserved instance to another. So if you get a T2 and you want to go over to an R4 or something like that, you can't do that with standard. With convertible, you can. So it allows you to change between your different instance types. We then have scheduled reserved instances, and these are available to launch within the time windows that you reserve. So maybe you run a school or something like that, and when everyone comes in at 9 o'clock and logs in, you need to scale, for 2 hours while you do the login. So you can actually schedule having reserved instances to a specific time window. So those are the three different types of reserve pricing. So spot pricing, like I said, this is Amazon selling off their excess capacity at a lower rate. So it's useful for applications that have flexible start and end times. So if Amazon suddenly want that capacity back and you're not willing to pay a certain price, what will happen is those EC2 instances will be terminated. So it's useful for applications that are only feasible at very, very low compute prices. And it's useful for users with urgent computing needs for large amounts of additional capacity. And then finally, we have our dedicated host pricing. And that's useful for regulatory requirements. So it might be that the government says that you cannot support multi-tenant virtualization. You have to use dedicated hosts. It's also great for licensing, which does not support multi-tenant virtualization or cloud deployment. So if you've got some really harsh Oracle licensing, for example, you might want to use dedicated hosts. And you can also be purchased on demand. So you can actually pay for your dedicated host by the hour. And they can be purchased as a reservation as well for up to 70% off of the on-demand price. So I mentioned before that we have all these different EC2 instances. So these are all the available instances today. Now, don't worry, you're never going to be tested on a particular type of instance, certainly not in the Certified Solutions Architect Associate exam. Where you will start getting this is at the professional level. They'll give you a bunch of scenario questions, and then they'll ask you what type of instance would best suit your needs. Okay, so let's run through these. We'll start with F1. So this is for field programmable gate arrays. And the use cases for this is things like genomic research, financial analytics, real-time video processing, big data, etc. If you don't know what FPGA is, go ahead and look it up. It's really interesting stuff. Effectively, it allows the chips to be reprogrammed after being manufactured, so rewired in a sense. But it's completely beyond the scope of this course, but it is interesting tech. Moving on to so we've got the i3s. These are high-speed storage, and these are used for things like NoSQL databases, data warehousing, etc. Then got G3s. These are graphics intensive, and these are used for things like video encoding, 3D application streaming, etc. We've got H1s. These are high disk throughputs, useful for things like MapReduce-based workloads, distributed file systems such as HDFS and MapRFS. We then have T3s. These are our lowest cost general purpose instances, and we're going to be using the T3s throughout the rest of this course. And typically the use case for that is web servers, small databases, etc. We've got D2s. These are dense storage. These are used for file servers, data warehousing, and Hadoop. We've got R5. These are memory optimized, and these are useful for memory intensive apps or databases. We then have M5. This is for general purpose use, and typically use this for application servers. C5, these are compute optimized, and these are going to be useful for CPU intensive applications and databases. Got our P3s, these are graphics or general purpose GPUs. These are good for things like machine learning or Bitcoin mining, etc. Then got our X1, these are memory optimized, and these are useful for things like SAP HANA, Apache Spark, etc. We then have our Z1D, these are high compute capacity and high memory footprint, and they're ideal for electronic design automation, so EDAs, and certain relational database workloads with high per core licensing costs. We then have our A1s. These are ARM-based workloads, and this is useful for scale-out workloads for things like web servers. ARM is just basically a cheaper type of CPU, so it's useful for ARM-based workloads. We then have our U6TB1, and these are used for bare metal. So don't worry, you don't need to understand what each instance is and does for the Certified Solutions Architect Associate exam. When you do go on to do DevOps Pro or SA Pro, you will have to understand this a little bit better. It is good to learn it now, though. And to help you learn it, I've just made a mnemonic. There's been so many mnemonics over the years, but this year for the 2019 mnemonic, we've got F for FPGA, I for IOPS, G for graphics, H for high disk throughput, T for general purpose, so think of a T2 or T3 micro, D for density, R for RAM, which is the main choice for your general purpose apps, C for compute, P for graphics, so think PICs, X for extreme memory, Z for extreme memory and CPU, A for ARM-based workloads, and U for bare metal. So how are you going to remember that? Well, it's Fight Dr. McPixie AU. So here is Dr. McPixie. You can tell that she's a doctor because she's got a stethoscope. She's from Scotland because she's wearing the tartan, sort of clothes. So that's Mick. She's a pixie, so you can clearly see the pixie with the wings. And then I did AU. So AU could either be Austin or it could be Australia. It's whatever you want to use to remember AU. Our offices are in both Austin, Texas, as well as in Melbourne, Australia. So maybe that's the way you remember it, the A Cloud Guru offices. So you're going to go fight this Dr. McPixie in Australia or in Austin. So that's how you can remember all the different instance types. Like I said, it's not really important for the Certified Solutions Architect Associate exam. It is important when you go on and do the professionals. And I will just say one thing, these numbers here will change throughout the year. Again, you don't need to remember the numbers or anything like that. So an F1 might become an F2 or an R5 might become an R6. But it doesn't matter. The numbers are basically just the generations. So this is the 5th generation of the memory optimized instance. So on to my exam tips. So the first one is just remember what EC2 is. It's virtual machines in the cloud. It's a web service that provides resizable compute capacity. And Amazon EC2 reduces the time required to obtain and boot new servers instances to minutes from previously from days or even months, depending on where you worked, allowing you to quickly scale capacity both up and down as your computing requirements change. So remember what EC2 is, and we're going to spin up a EC2 instance in the very next lecture. Remember the different pricing types. So we've got on demand, we've got reserved, we've got spot, and we've got dedicated host. On demand's where you pay an hourly or by second rate. Reserved is basically where you sign a 1 or 3 year contract, and the more you pay up front, the better discount you get. Spot moves around like the stock market and really just depends on Amazon's own supply and demand. And then we've got dedicated host, and this is where you get a dedicated physical machine to you, and you can also, again, pay for that on demand as well. And then just remember that if you've got a spot instance and it's being terminated by EC2, you're not going to be charged for a partial hour of usage. However, if you go in and terminate that instance yourself, you will be charged for the hour in which the instance ran. That can be a popular exam question. And like I said, you don't really need to know all the instance types for the Solutions Architect Associate. It can be helpful later on when you go and do the Pro. But the way I remember them is just fight Dr. McPixie in Australia or in Austin. So there's Dr. McPixie. We're going to go and fight her in Australia or Austin. It's silly, I know, but it really, really does help you remember all the different instance types. So that is it for this lecture, everyone. In the next lecture, we're going to go in, get our hands dirty, and provision our first EC2 instance. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to provision our very first EC2 instance. So this is part 1. We're going to keep it just under 20 minutes if we can, and we're going to provision a little EC2 instance and turn it into a web server. So this is a lab, and you will need to log into the AWS console. Okay, so here I am in the AWS console. Now up here, we can control our region. I'm going to do this rest of this course in Northern Virginia. And we're going to go over to services, and we will find EC2 as the very first service that's under compute. So go ahead and click on that. So this is the EC2 dashboard. This is actually a new dashboard. You can toggle between the old dashboard and the new dashboard just by turning this off, on and off. I'm going to use the new dashboard, and you can see here that I've got everything as zeros. So I haven't gone in and launched an EC2 instance before. So we can launch an EC2 instance just by clicking in here and going to Launch Instance, and go ahead and launch your first instance. Now, step 1 is always to choose an Amazon machine image. And an Amazon machine image is just choosing your virtual machine. So do you want to be running Amazon Linux, or do you want to be running SUSE Linux or Red Hat, or would you like to be running Windows, for example? So I'm going to go with Amazon Linux 2 AMI. We are going to use this for the rest of the course. So go ahead and click on Amazon Linux 2 AMI. In here, we've got all our different instance types. So we can actually control it up here as well. So we could have micro instances, compute optimized, general purpose, GPU, memory optimized, storage optimized, etc. And just see if you can remember that mnemonic. It was Fight Dr. McPixie AU. So that's these instances in here. Now, where you'll see free tier eligible, that means that this instance stays within free tier. So for the rest of this course, we are going to be using T2 micros. T3, you can get T3 micros now, but again, it's not going to be free tier eligible, so I'm going to run a T2 micro. Let's go ahead and configure our instance details, and this is where we really start to set everything up. So the number of instances, I'm going to launch 1. I'm not going to click launch into an auto-scaling group. We're going to cover off auto-scaling group in the high availability section of the course. Down here, we can do request spot instances, so we could set our spot price. I'm not going to do that. We're just going to go on demand. We're going to launch it into our default VPC. VPC just stands for Virtual Private Cloud. We're going to have a whole VPC section coming up. Right now, we're just using our own default VPCs that Amazon create for us. And when we go into the VPC section, of course, we'll be creating our own. Subnets in here, this is a way of choosing which availability zone you want to go into. So if you want US East 1A, 1B, 1C, etc., you can select in here. Interesting thing to note is that this is randomized. So if I was to sign up to another AWS account and I select US East 1A, basically the two accounts might be in completely different availability zones. So 1A for one account might not be 1A for another account. So it's something to note. Down here, we've got auto-assign public IP address. I'm going to do that. Placement groups, we haven't covered off. We will cover that off later, but essentially it's for high-performance computing. Capacity reservations, so this is where you can reserve capacity on your EC2 instances in a specific availability zone. Not going to do that. IAM roles we'll cover off later. And in here, we've got our shutdown behavior. So what happens if we shut down this instance? Do we want to stop it or terminate it? Here we've got enable termination protection. This is to stop us from accidentally deleting our EC2 instances. I am going to enable it for this one. Here we've got monitoring. So this is enable CloudWatch. We are going to cover off CloudWatch in this section of the course. CloudWatch by default will monitor your EC2 instances every 5 minutes. If you want it to be less than that, if you want it to be every 1 minute interval, you need to enable detailed monitoring. But if you do that, you won't be within free tier. Tenancy in here, we can say, hey, I want shared hardware. I want a dedicated instance or a dedicated host. I'm just going to use a shared hardware. Elastic interface, we won't cover off yet. And down here, we've got advanced details. And this is where we can pass bootstrap scripts. And we're going to look at that later on in this section of the course. So basically, all you need to do is go ahead and click on the protect against termination, accidental termination. And you can go ahead and leave everything else as default. Next, let's go in and add our storage. Now, we are going to cover off the different EBS volume types later on in this section of the course, but for now, we've got 3. We've got general purpose, we've got provisioned IOPS, these are both SSD, and then we have magnetic, which is standard. And if we click over here and go to add new volume, we actually get more options, and that's because this is the root device volume. And the root device volume can only launch on SSD or magnetic standard, but you can have additional volumes, and additional volumes include things like cold hard disk drive and throughput optimized hard disk drive, and these are all magnetic as well. Like I said, let's not get too bogged down in this right now. We're going to go and learn about that later on in this section of the course. I'm going to delete this off, so we're just going to launch with the root device volume. When we say root device volume or EBS, all we're talking about is a virtual disk in the cloud. This is where our operating system is going to be installed. So let's go ahead and add our tags. I am going to add some tags here. So I'm going to call this name, I'm going to call it web server 01. The department, so this is the department that owns that web server. I'm just going to call it developers, and add another tag. So we might have employee ID. This would be our employee ID who provisioned it, etc., etc. So this is a way of keeping track of our EC2 and our AWS infrastructure. Let's go ahead and configure our security group. Now, a security group is just a virtual firewall. That's all it is. It's a virtual firewall which allows communication over particular ports. We're going to cover security groups in a lot of detail in the VPC section of the course, but for now, just understand that it's a virtual firewall. This is how you enable traffic on the various different ports. So HTTP goes across port 80, SSH goes across port 22. So you're just allowing various different types of communication to your EC2 instance through your security group. We are going to create a new security group. I'm just going to call mine Web DMZ, so Demilitarized Zone. So this is the security group that all my web servers are going to go into. And I'm going to add a rule. I'm going to allow port 80, so HTTP, and we're going to do it to 0.0.0.0/O. And so this is a CIDR address range. Again, we're going to cover this off in the networking section of the course, but essentially when these are all zeros, you're opening it up to the whole world. Now you might want to lock your SSH down to your particular IP. You can just click in there and then it will lock it down to this IP address. So you can only SSH in on this IP address. The problem with that is that if your IP address changes, then you won't be able to access this EC2 instance. So I'm just going to do 0.0.0.0/O. So I'm going to copy and paste it in there. And it'll give us a little warning. So let's go ahead and hit review and launch. And we're going to go ahead and hit launch. Now we do need to create a key pair because we've never done this before. So the way I like to think of public key and private keys, this is asymmetric encryption. So it means you need two. So asymmetric. With symmetric encryption, it's just one. So with asymmetric encryption, you've got a public key, and I want you to imagine that as a padlock. And you can go and take your public key and you can go and put it everywhere. You can put it on your bike, you can put it on your front door, you can put it on your neighbor's front door. It doesn't matter if someone gets your public key. Your private key is the key that opens that padlock, and you do not want anyone else to get your private key because then they can open up all your padlocks. You can open up all your public keys. So your public key will go on your EC2 instance. The private key you will save locally on your machine, and you will use that private key to be able to SSH into your EC2 instance. So let's go ahead and create a new key pair. I'm just going to call it my NV, or my US East 1, US East 1 key pair. There we go. So my use 1 KP. I'm going to go ahead and download that. So download that to a safe location. You will need it to connect to your EC2 instance. So I've gone ahead and hit launch instance. And I'm going to go in and view my instances. So we can see now that it's launching. This is my instance ID. We can see it's inherited the name from my tag. We can see the instance type is a T2 micro. It's available in US East 1D. It's currently pending and the status checks are initializing. It's already got a DNS address. So this is a web address that we can use to go and visit our EC2 instance. And down here we can see you can move this so that it's bigger or smaller just by clicking these. And we can see all our information in here. So we can see our public IP address, for example. We can see that it's in our VPC. We can see what subnet it's in, etc., etc., etc. And this will become more and more familiar to you as you go on throughout the course and get your hands dirty with EC2. Now, I would copy this public IP address to your clipboard. Just click on this little icon. And now what we're going to do is we're going to SSH into our EC2 instance. So there's actually a few different ways that we can connect into our EC2 instances. We can use Terminal for Mac. We can use a plugin for Chrome if you're using Windows, for example. But the easiest way, which is uniform across both, is just by clicking Connect up here and using EC2 Instance Connect. And you can go ahead and just hit Connect. Your username is always going to be EC2-user, and go ahead and hit Connect. That will open up a new tab, and it will basically establish a session directly with your EC2 instance. So we can see in here, I'm already connected to it. I can do things like sudo su to elevate my privileges to root, and then I can go ahead and run yum updates, etc., etc. I am going to show you how to do this using Terminal, using for Mac users, as well as a plugin for Chrome. But just do whatever it is that you find best works for you. Throughout the rest of this course, I'm going to be using Terminal in my Mac. The reason is I've been using it for 10 years. I'm very used to it, and it's also a lot easier for you guys to see the screen because I can adjust the text, make it larger, change the fonts, etc. But the easiest way probably for you guys is just to go ahead and hit Connect and then use EC2 Instance Connect.
So Mac users, I'll quickly show you how to use Terminal to connect to your EC2 instance. Windows users, if you want to jump ahead to about 13 minutes and 30 seconds, I'll show you how to install a plugin for Google Chrome.
Okay, so if we click on Applications and we scroll all the way down, you'll be able to see Utilities, and in here we've got Terminal. So go ahead and open that up. By default, you'll be in your Downloads directory, and if you type in ls for list, you'll be able to see the files and folders in there. Now, I can see my key pair here. It's called my US East 1 key pair. So what I'm going to do is I'm just going to make a directory called SSH, and I'm going to move my US East 1 to my SSH directory. And then I'm going to go into my SSH directory, so cd SSH, and then I can see it in here. Now what I'm going to do is going to change the permissions. I'm going to type chmod and then 400 and then my US East 1 key pair, and you can hit tab, by the way, that's how it will autofill. And that has just changed the permissions to lock my key down. And then what I'm going to do is I'm just going to clear the screen, and we're going to type SSH and then ec2-user and then @ and then we need to paste our IP address in there, and then we need to do -i, and then it was called my US East 1 key pair. So basically we're connecting in as EC2 user at this address using this key pair. And it'll ask you if you want to continue connecting, hit yes, and you should be able to connect in. Now, if you are having trouble, some networks block port 22. So you need to go and do this at home under home network, or do it on your, on your phone or something like that. Because some networks, like in public libraries, for example, or at schools, or even in your office, they might be blocking port 22s. This is a common frustrating thing that some people get when they can't connect to their EC2 instance. If it's not working, it's probably because your network's blocking the port 22. You will be able to do this at home though. So I have connected in, and what I'm going to do is just elevate my privileges to root. So we do that by typing sudo su, and this will change my user. You can see here it's gone from EC2 user to root. And this basically gives me super user access. This gives me administrator access across the entire EC2 instance. But you shouldn't really do this. I know a lot of Linux admins will be looking at this saying, oh, why don't you just type sudo for everything? But for the rest of this course, I am going to do it just because it makes the commands easier, and it makes it easier for beginners to follow along. So again, I'm going to go ahead and clear the screen. Okay, so for Windows users, what you need to do is go ahead and install Google Chrome as your browser. And then we're going to add an extension in Chrome, which will basically turn our browser into an SSH client. So what I want you to do is, once you've installed Chrome, go over to Google and just type in SSH Chrome extension into Google, and go ahead and hit enter. And in here, you'll be able to see it's called the Secure Shell app, and I'll put this link in the resources section of the course. So go ahead and click on that. And then all we want to do is go ahead and download this extension. So I'm going to go ahead and hit add to Chrome. That will then add this to Chrome. Go ahead and hit add app, and that will go ahead and install this extension into Chrome. Can take a little bit of while, so just wait for it to finish installing. And there we go, it has now installed. Now to get to this extension, you just need to navigate to Chrome, / and then apps. That's how you are able to access your apps in Chrome. And then we have it here, it's the Secure Shell app. So go ahead and click on that. And then what we want to do is we want to go in and configure this in order to connect to our EC2 instance. So the first thing we need to do is go ahead and grab the IP address. So here's another EC2 instance I've just spun up. And I'm going to go ahead and click back in here. And so my username is just going to be ec2-user. So type that in, ec2-user. And then the host name in here, we'll just paste in our IP address. And then what we need to do is go and create our identity. Now, in order to do that, we need to navigate to where we installed or where we downloaded our PEM file. So now we need to navigate over to the command prompt. So just click, right-click on the Windows button, go ahead and hit run, and then just type cmd command. That will fire up the command prompt. You need to navigate to where you installed or where you downloaded your PEM file. So mine's installed on the downloads directory. So I'm just going to go to my downloads directory. So cd downloads. Then I'm just going to type dir, and that will list everything in my directory. And you can see here we've got my key pair. So this one's called mykp.pem. I'll just make this a bit bigger so you can see it. And then all we want to do is we want to type the following command. So we want to type in ssh -keygen, and then -y, and then -f.
and then we're going to type the name of our key pair. So it's mykp.pem. And then we're going to output that to mykp and then .pub. So we're basically generating our public key. So this is asymmetric encryption, which means you always have a private key and a public key. A public key is basically like a padlock. You can give anyone a copy of that public key, but they cannot open it up without the private key. And that's why you'd never hand out your private key to anyone, because then they can open up your public key. That's the way I always like to think of it. So if we type in dir now, we can see our two files. We've got mykp.pem, which is our private key, and mykp.pub, which is our public key. The last thing we need to do is just rename the mykp.pem to just mykp. So you can give it any name that you want, but you've got to lose the .pem extension. Once we've done that, let's go back over to our Google Chrome extension. So it's in here. And then we're going to go ahead and hit import. And then what you want to do is just navigate to your downloads directory and import those two files. Now, again, you must have changed that extension from .pem to just being called, basically having no extension. So go ahead and hit open. That will then change your identity to that key pair. And then you should be able to just click in here. I've lost my username and password again, but I can just regenerate it. And then we should be able to go ahead and connect. So if we just hit enter, it'll now say it's loading the plugin, it's connecting to that IP address. Just type in yes, and then it's going to add it to the list of known hosts. And there we go. We have logged in to our EC2 instance. We can elevate our privileges, and then we can go ahead and clear the screen. And now you can follow along with all the commands in Windows as well.
And then what we're going to do is we're going to apply some operating system updates. So if we just type in yum update -yes, so yum update -y will just look for operating system updates. You can see here that I do not need any updates. There's no security updates. So this is using the latest packages. And then what I want to do is I want to install Apache. So we type yum install httpd -yes. And that will go through and install Apache. And Apache basically turns our EC2 instance into a web server. Once you've done that, you can be able to go to your cd var www html directory, and anything that you put in here will be basically a website or will be accessible over port 80. So let's clear the screen, and what we're going to do is we're going to create a little file. We're going to call it nano and then index.html. Nano is just a text editor. And I'm just going to write some really quick HTML. So it'll be HTML header, not even going to bother with body and all of that. I'm just going to say hello cloud gurus. And we're going to end our header. And we're going to end our HTML. And then hit Control X and then hit yes and then hit enter. And you'll be able to see that file in there. So as soon as we turn on the Apache service or the HTTPD service, this web server will become basically a web server, and anyone will be able to go to our index.html. So to turn it on, all we need to do is type service, HTTPD, and then start. And that will start the HTTPD service. And then you might just want to type a command called checkconfig on. Checkconfig on will just basically start the HTTPD service if your EC2 instance accidentally reboots. You don't need to go in and manually go in and turn it on at the next reboot. So let's go ahead and test this by going over to a web browser. Okay, so here I am in a web browser, and all I'm going to do is paste in my IP address, hit enter, and you can see it, hello Cloud Gurus. So we've created our very first little web server. So I'm going to end this lecture here. You've done really, really well. If you've got the time, please join me in the next lecture, and we'll have a look at what else we can do with our EC2 instance before we go in and terminate it. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to part 2 of launching our first EC2 instance. Let's go back over to the AWS console. Okay, so here I am in the AWS console. I'm in EC2. Down here, we can see all the details about our EC2 instance. So we can see which key pair it's using. So it's using my US East 1 key pair. We can also scroll down and we can see that termination protection is turned on. This is a true value. We can see a whole bunch of different stuff, including our IP address, your DNS address, your public DNS address. You can use this URL, and you'll still be able to browse to the Hello Cloud Gurus webpage. In here, we've got our status checks. So this comes up a lot in the SysOps Administrator Associate. You've got a system status check. This is checking the underlying hypervisor, so it's checking the actual physical machine. And then we've got our instance status check. This is actually going and checking the EC2 instance itself. You can hold over here and have a read of it by holding your mouse over the little eye symbol. In here, we've got our monitoring. Now, we are going to do CloudWatch later on in this section of the course. We can turn detailed monitoring on for this EC2 instance. In here, we can see our CPU utilization. We can see our network. We can see different disk utilizations, status checks, etc., etc. And we are going to go in and create our own CloudWatch metrics and dashboards later on in this section of the course. And then in here, we've got our tags, and this is what we set up when we first, provision this EC2 instance. Now, I can go up here and I can do different actions. I can go in and stop my instance. I could go in and try and terminate it, but you see here, I can't click this button, and that's because termination protection is turned on. If I wanted to turn it off, I just need to go over to my instance settings. In here, we can see we can do a whole bunch of different stuff. So we can add or replace roles. We can change our termination protection. I'm going to go ahead and hit yes, disable. I'm now able to go in and go terminate. And if I click this button here, it will terminate that EC2 instance. I'm going to leave it running so that we don't have to keep provisioning EC2 instances. There is a couple more things I want to show you though. So over here, we've got different things that we can do. We've got our spot requests, we've got our reserved instances, dedicated hosts, scheduled instances, and then capacity reservations. If I click on reserved instances, I can go in and start to purchase my reserved instances. And you can go through and have a look at the different types. So you could say you want Linux, you want a standard tenancy. In here, you could say, I want a T2 micro, super large, whatever. Let's go T2 small. Term, let's go straight for the 12 to 36 months. Let's go payment option all up front. And then you could go and hit search, and that will show you these different instances. You can then go and add these to your cart. So if you're basically purchasing a T2 small for 36 months, effectively it's going to be $229, and that's pretty good rate when you think about it for a virtual machine in the cloud for 3 years. You can only pay $300 or less than $300, $229. So that's how you go and purchase reserved instances. Let's go back over to the EC2 dashboard, and before I'm just going to go ahead and hit launch instance, and I just wanted to show you some more things. So we're going to launch an Amazon Linux 2 AMI. We're going to leave it as default, and we're going to leave this as default.
So in here, this is where we add our storage, and we've got our root device volume. So that's our volume type, and our root device volume, like I said in the last lecture, simply means where our operating system is going to be installed. So where are we installing Linux, or where are we installing Windows on our C drive? So that's all a root device volume is. In here, we can see the size, so it's going to be 8 gig. In here, we've got the volume type. Now, there's only 3 different volume types in here for our root device volume. We've got general purpose 1, GP2. So this is general purpose SSD. We've got provisioned IOPS or IO1. And then we've got magnetic. So these are our 2 SSD volumes that we can have. And then we've also just got standard magnetic in here. In here, we've got our IOPS. So if we were to use provisioned IOPS, we would start at 400 IOPS. If we were to use general purpose, it's going to have a baseline of 3 IOPS per gig with a minimum of 100 IOPS and burstable up to 3000 IOPS. And if you haven't heard the term IOPS before, it just means input output per second. And essentially, it's how fast your hard disk drive is. In here, we've got delete on termination. So if we were going to delete our EC2 instance, are we going to delete the root device volume along with it? Well, yes, we are. And in here, we've got encryption. So it used to be that you couldn't encrypt a root device volume right from the get-go. You can definitely do it now. So do remember that going into your exam, you can encrypt your root device volumes. In here, we can add a new volume. So we've got our volume type. So we've got EBS volumes. In here, we can adjust the size. Note that the volume type now changes. So we've actually got 5 different volumes. We've still got our general purpose SSD, our provisioned IOPS SSD, and our magnetic standard. But we have 2 additional volumes. We've got our cold hard disk drive, and then we've got our throughput optimized hard disk drive. And this might be useful for things like data warehouses, etc. And cold hard disk drive is just our very cheapest form of storage. And we are going to cover off all the different volume types later on on in the course. So you might want throughput optimized, and you might want that at 500 gigs, and that will then tell you the throughput in megabits per second in here. So we get between basically 500 megabits per terabyte. So because we've only got 500 gigs, we're going to be looking at between 20 to 123 megabits per second. Note that delete on termination is not automatically ticked for your additional volumes. So if you went in and provisioned this EC2 instance and then terminated it, it would delete the root device volume, but it wouldn't delete any of your additionally attached volumes to that EC2 instance. And again, you can also add encryption in here. So I'm just pointing out this now. If you do hear me say in the course later on that root device volumes cannot be encrypted, that's no longer the case. They definitely can be encrypted. It is a popular exam topic now. We will look later on in the course as to how we can take a unencrypted root device volume and go ahead and encrypt it. There is a process that you have to go through, and it becomes a very popular exam topic, both for EC2 as well as RDS, and we will cover that off later on in the course. Let's go ahead and have a look at my exam tips. So my exam tips, just remember that termination protection is turned off by default, so you must turn it on. When it's turned on, then you can't go in and automatically or accidentally terminate your EC2 instances. Remember that on an EBS-backed instance, the default action is for the root EBS volume to be deleted when the instance is terminated. So if you go in and terminate your instance, it's going to delete the root device volume, but any additional volumes by default won't be deleted. So that can be a thing that comes up in the exams a lot. Also remember that EBS root volumes of your default AMIs can now be encrypted. You can also use third-party tools such as BitLocker for Windows to encrypt the root device volume, or it can be done when creating the AMIs, and we're going to show you how to do this in a lab. You can also do it using the AWS console or using the API. So we do have a lab coming up which will show you how to take an unencrypted root device volume and go through a process to encrypt that. And that again is a very popular exam topic. But like I said, just remember that your EBS root volumes for your Amazon AMIs can now be encrypted as well. And also remember that you can take additional volumes and encrypt them as well. So that is it for this lecture, everyone. You have learnt an awful lot about EC2 so far. I hope you had lots of fun logging into your first EC2 instance. In the next lecture, we're going to look at security groups, and security groups are basically just virtual firewalls that control traffic to our EC2 instances. So if you've got the time, please join me in the next lecture. Thank you.
Okay, hello Cloud Gurus and welcome to this lecture. In this lecture, we're going to look at security groups. So this is a lab and you will need to log into the AWS console. Okay, so here I am in the AWS console. We're going to go to EC2, which is under compute. And we're going to click in here and we'll be able to see our instance. Now, if we click on our instance and grab our public IP address, we can go ahead and load our web page. So I want you to navigate over to your public IP address and load your web page. Okay, so here I am in my browser. I'm just going to paste it in here, and you can see straight away it says Hello Cloud Gurus. So if I go back over to EC2, just going to maximize the screen. So the reason we're able to browse to our web page is we've enabled port 80 on our security group, and port 80 is just the HTTP port. And you can see your security groups just by scrolling down here. There's always going to be in the description. So here's my security group here. I can actually click in here and view my inbound rules. And we can see here that port 80 and port 22 are open to the world. And that my security group is called WebDMZ. So let's go over and edit our security groups. So it's here under network and security. You can see security groups. And in here, you're able to create security groups, delete security groups, edit security groups, etc. So we go over to our WebDMZ. I'll just make this a little bit bigger so we can all see. So we've got our description in here, and it's basically just the name of our security group, the ID of it, and then the description, and then which VPC it's in. And then if we click in here, we've got our inbound rules. So we've opened up HTTP on port 80, and we've done this to 0.0.0.0/0. So this is IPv4. We've also done it on IPv6, and we've also done SSH on port 22 to IPv4. So if I go ahead and delete this rule, what if I go in and edit and delete my two port 80 rules and hit save? What do you think is going to happen? How quickly do you think this is going to take effect? If I go back over to my browser, if I click in here and hit refresh,
And you can see down here it says connecting. It's going to hang for about a minute and then it's going to time out. So every time you make a rule change on a security group, that change takes effect immediately. And that can be a really popular exam question going into your exams. So that took just over 60 seconds, but you can now see that it has timed out. So by deleting that rule in the security group, the change took effect immediately and I now cannot access the website. If I go back to the AWS Management Console, I can go in here and I can go add rule. And we're going to go in and add HTTP. And we're going to do it for port 80. And by default, we're going to open it up to both IPv4 and IPv6 and hit save. And if we scroll down, we can now see that that rule has taken effect on our WebDMZ. Sorry, I'll just click in here. So you can see it in here now. I'll just full screen this so it's easier to see. So now you can see HTTP and HTTP on IPv4 and IPv6. And if I just go back over to my other browser, that is now loading immediately. So hello, Cloud Gurus. So we've learned that if you make a change to a security group, that change takes effect immediately. Let's have a look at our outbound rules. So in here, we've got an outbound rule over all traffic, protocol for everything, port for everything, destination to everything. What would happen if we go and delete this? Would that delete all our outbound traffic? Would we suddenly be able to send a request to our EC2 instance, but nothing will then come back out? Let's go ahead and test that. I'll just come out of full screen, and in here, if I hit refresh, and you can see that it loads immediately. So by deleting that rule, nothing happened. And the reason for that is security groups are stateful. So essentially, when you create an inbound rule, an outbound rule is created automatically. So if you allow HTTP in, it's automatically allowed out as well. If you allow RDP in, or if you allow SSH, or you allow MySQL in, it's automatically going to be allowed back out. Now, when we get to the VPC section of the course, you're going to learn about network access control lists, or NACLs as we like to call them, and those are stateless. So when you create an inbound rule, you also have to create an outbound rule as well. So with security groups are stateful, network access control lists are stateless, and that's something we'll learn again in the VPC section of the course. Also, I want you to have a look in here. If I go to edit and I go to add a rule, there's no way I can add rules all I want. I can allow, traffic over Oracle RDS or Redshift or, SMTPS, whatever port it is, I can allow, but I can't actually go in and block an individual port. I can't go in and say, hey, don't allow any traffic across this. There's no way of blacklisting a particular port. And likewise, there's no way of blacklisting a particular IP address. You can't do that with security groups. Where you can do that is with network access control lists. And again, we're going to look at that in the VPC section of the course. But for now, what's really important is just to remember that you can't block individual IP addresses using security groups, and you can't block an individual port. But the way security groups work, right, is when you create a security group, everything's blocked by default. You have to go in and allow something. So everything's blocked by default, but when you go in and allow HTTP or MySQL, then the traffic is allowed through. So that's another thing to take away going into your exam. So I'm just going to close this and go ahead and hit save. Next thing we're going to do is just go over to our default security group. And what I'm going to do in here is I'm going to add some inbound rules. So let's go and add MySQL, for example. So we'll scroll down, MySQL Aurora, so 3306. And let's add SQL Server, which will be 1433. So if we find a SQL Server, just right here, MS SQL. And so 1433, there you go. Go ahead and hit save. And then it's just giving me saying that I need to enter in a site or address range. So if I put o.o.o.o/o and o.o.o.o/o, and there we go. I'm going to go ahead and hit save. And that has now allowed MySQL and MS SQL through our default security group. Now, if we go back to EC2 and click on our running instances, you can see in here that we've only got one security group attached to this EC2 instance. You can attach more than one security group to an EC2 instance. The way you do that is you just click on Actions and you go over to Networking, and here you go Change Security Groups. And we can go ahead in here and click Assign Security Groups, and we now have two security groups assigned to our EC2 instance. So we've got our default one as well as our WebDMZ. If we click on View Inbound Rules, this actually looks a little bit better now because we can actually see which ports are open by which security groups. So we're saying here that WebDMZ is allowing port 80 and port 22, and our default is allowing port 1433,
as well as 3306. So it's allowing MySQL in as well. So that's how we can add and remove security groups. And of course, if you add a security group to an EC2 instance, that effect takes place immediately. So I'm just going to go in and I'm going to just clean up. I'm going to go back to my security groups and I'm going to delete I'm not going to delete my default one, but I am going to delete those rules that we just created because you really don't want MySQL and SQL Server access open to the entire world. It's not a very good security practice. And the next thing I'm going to do is just go back over to EC2 and I'm going to remove that security group. So if I go to Actions and then go over to Networking and change security groups, I'm just going to remove the default one and make sure that it's still in the web DMZ. So let's go have a look at my exam tips. So onto my exam tips. Just remember that all inbound traffic is blocked by default. So you have to go into a security group and enable it. So we went in and enabled port 80, we enabled port 22, SSH, we enabled MySQL, etc., etc. So you all inbound traffic is blocked by default, but then you can go in and enable individual ports. Remember that all outbound traffic is allowed. So even if we went in and deleted that rule, it has no effect on a security group whatsoever. And the reason for that is security groups are stateful, which we're about to come up to. Changes to security groups take effect immediately. So as soon as we deleted port 80, we could no longer access our website. As soon as we added it again, we could. You can have any number of EC2 instances within a single security group, and you can also have multiple security groups attached to EC2 instances. So there is not a one-on-one relationship at all. You can have as many EC2 instances within an individual security group as you want. And likewise, you can have multiple security groups attached to individual EC2 instances. We learned that security groups are stateful, so we don't have to change inbound and outbound ports. If you enable something on the inbound, outbound is enabled automatically for that port. And if you create an inbound rule allowing traffic in, which is exactly what I just said, that traffic is automatically allowed back out again. And you cannot block specific IP addresses using security groups. Instead, you're going to do this using network access control lists, and we're going to learn all about that in the VPC section of the course. And then finally, you can specifically allow rules, but you cannot set any deny rules in a security group. So if you see any scenario questions about setting up a deny rule on a security groups don't work like that. By default, they deny everything, but then you go in and allow. You can't put a specific deny rule on a security group, but you can do that with network access control list. And like I said, we will cover that off in the VPC section of the course. So that is it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture where we're going to look at EBS volumes. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus and welcome to this lecture. This lecture is called EBS 101. Now, we briefly touched on EBS in the EC2 101 lecture, and we've also used EBS already when we provisioned our very first EC2 instance. But in this lecture, we're going to deep dive a little bit deeper into EBS. So what is EBS? Well, EBS basically stands for Elastic Block Store, and essentially it's a virtual hard disk in the cloud. It provides persistent block storage volumes for use with Amazon EC2 instances in the AWS cloud, and each Amazon EBS volume is automatically replicated within its own availability zone to protect you from component failure, which is offering high availability and durability. So all EBS is a virtual hard disk drive in the cloud, and it comes in 5 different flavors. So we've got general purpose SSD, which is what we've been using so far. We've got provisioned IOPS, which is also SSD. So this is where you want really, really fast input outputs per second. We then have throughput optimized hard disk drive. This is actually a physical hard disk drive, so it's not SSD, it's magnetic. This is where it's going to be optimized for throughput. We then have our cold hard disk drive. Again, this is magnetic. And then we also just have magnetic. So let's look at the different use cases for each one. So let's start with general purpose SSDs. So our SSDs are broken down into general purpose and provisioned IOPS. General purpose is basically designed for SSD volumes that balance price and performance for a wide variety of transactional workloads. And essentially its use case is most workloads. Now these API names you will need to know going into your exam. It does come up. They do sometimes use the API names. They certainly do it in the Certified SysOps Administrator Association associate exam as well. So general purpose SSD is GP2, and it's suitable for workloads up to 16,000 IOPS per volume. If you start going above 16,000 IOPS, you're going to need to go over to provisioned IOPS, and provisioned IOPS SSD is the highest performance SSD volume, and it's designed for mission critical applications. So your workloads here will be databases. And the good thing about provisioned IOPS SSD is it's capable of going up to 64,000 IOPS per volume now. We then have over here all our different hard disk drive options. So we've got our throughput optimized hard disk drive, our cold hard disk drive, and then our EBS magnetic. So throughput optimize is obviously for optimized throughput. So where you would use this would be things like big data and data warehousing. It's known as ST1. And its maximum IOPS per volume is going to be 500 IOPS per volume. Your cold hard disk drive, this is the lowest cost hard disk drive of volume, and it's designed for less frequently accessed workloads. So this could be things like file servers, etc. And again, the IOPS on this is not great. It's 250. And we then have EBS magnetic. This is basically previous generation hard disk drive. It is still available, so you can still use it in the console. And this is basically for workloads where data is infrequently accessed. So it might be where you're doing a bit of data archiving, but for some reason you opt not to use Glacier. And again, the IOPS for that is between 40 to 200. So the best way to learn EBS is to go ahead and start playing with it. So in the next lecture, we're going to learn all about EBS, and we're going to look at how we can create new volumes, how we can do snapshots, how we can resize volumes on the fly, etc., etc. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to look at EBS volumes as well as snapshots. So this is a lab, and you will need to log into the AWS console. Okay, so here I am in the AWS console. I'm in the Northern Virginia region. I'm going to go over to EC2. Hopefully you remember where it is right by now, but it is under compute. And we've got this EC2 instance that's running in here. This is our little web server. If we actually go down to volumes, we'll be able to see the volume that it's running on. And you can see that this volume is in US East 1D. If we go over to our EC2 instance by going to the dashboard and clicking on running instances, you'll see that the actual virtual machine is in US East 1D. And this is a really important topic to remember for your exam. Wherever your EC2 instance is, the volume is going to be in the same availability zone. And that makes sense if you think about it. If you think about a physical computer, you always want the hard disk drive to be as close to the motherboard as possible. So when you've got a virtual machine and then a virtual hard disk drive, you want them to be in the same availability zone. You don't want them to be in different availability zones because you're going to have a huge amount of lag. So just really important to remember going into your exam that your EBS volumes will always be in the same availability zones as your EC2 instance. So another common scenario in your exams will be where you want to move your EC2 instance or your EBS volume from one availability zone to another. And we'll look at how we can do that in a little bit in this lab. But the first thing I want to show you is what happens if we terminate this instance. What is going to happen to this volume? So let's go ahead and kill off our little web server. He's served us well. So I'm going to go over here and go to instance state and click on terminate, and I'm going to go ahead and terminate that. So that is now shutting down my EC2 instance. If I go over to my volumes as well, right now it says it's in use, but I'm just going to pause the video for a couple of minutes and see what happens. Okay, so it's been a couple of minutes. I'm just going to hit the refresh button, and now you can see that it removed that EBS volume automatically from my volumes, console. So if we go back over to EC2, let's go ahead and launch a new instance. We're going to use the Amazon Linux 2 AMI. And I'm going to go in and I'm going to use a T2 micro. I'm going to leave everything else as default. I'm going to go ahead and add my storage.
So in here we can see our storage. We've got our root device volume. This is the snapshot of it. It's 8 gigs in size. It's using general purpose SSD. These are the defined IOPS. And over here we can go ahead and encrypt it. We're not going to do any encryption yet. We will cover that off later on in the course. What we're going to do is we're going to add another 3 volumes. So we're going to go in here and we're going to add cold hard disk drive. we're going to go in and add throughput optimize hard disk drive, and we're going to go through and add magnetic. So we've added 3 different volumes. We're going to do the default sizes, and what we're going to do is a bit later on is we're going to go through and promote one of these to provisioned IOPS on the fly. We're not going to do any encryption. Note that when we're adding additional volumes, delete on termination is not checked automatically. So we're just going to leave everything as default, and next go ahead and add our tags.
Let's go in and add our tags. I'm not going to add any tags. I'm going to use an existing security group. I'm going to use my web DMZ, which has HTTP and SSH open to the world. I'm going to go ahead and hit review and launch, and I'm going to go ahead and launch that EC2 instance. So that will take a couple of minutes to come up. What I'm going to do is I'm just going to pause the video while I wait for this EC2 instance to come live. Okay, so that EC2 instance is now live, and I've actually got a pretty cool IP address. I've never seen a 3 IP address before. So I'm going to go down and going to have a look at my volumes. So it's under Elastic Block Store in here. I'm going to go ahead and click on volumes, and you'll be able to see our different volumes in here. So we've got GP2. This is our root device volume. So this is where our operating system is installed. We've got ST1. This is our throughput optimized one. We've got SC1. This is our cold hard disk drive. And then we've got standard, and this is our standard magnetic volume. And remember, this is previous generation. So let's go ahead and have a look at what we can do with these volumes. So if we go to ST1, we can go to our actions, and we can go and modify our volumes. We can actually just go in and change the size. So we could increase this from 500 gigs to 1,000 gigs. And go ahead and hit modify. And that will go ahead and modify the volume. Now it says here that it may take some time for performance changes to take effect. So it will, it will impact on your performance, and it may take some time for it to take effect because it is increasing the hard disk drive of it. And you also may need to extend the operating system file system on the volume to use it. So your operating system will only see the 500 initially. What you might have to go in and do is you'll have to go in and run a command and basically repartition the drive so you'll be able to see the full 1000. And you can actually learn about how to do that by clicking on the Linux or Windows one. Again, it's beyond the scope of the Certified Solutions Architect course as to how to do this. We do cover it off in the Certified SysOps Administrator Associate course, however. So let's go ahead and modify this volume, and that is now increasing this volume from 500 gigs to 1000. Another one we'll have a look at, let's go over to GP2. So this is our root device volume. And the reason you can find that it's the root device volume is it's come from that AMI. It's come from that Amazon machine image, the Linux, Amazon Linux 2 AMI. And this is the snapshot. So we're basically using Amazon's snapshot of that AMI. And we can go over here and modify this volume. And we can change the volume type. We can actually go up to provisioned IOPS. So instead of staying at GP2, we could modify it to provisioned IOPS. And again, this will affect the performance of the EC2 instance, but notice that you don't have to go and shut it down or stop the instance or anything like that. You can do it on the fly. So it is really, really clever technology. So I'm just going to pause the video. I'm going to wait for this to upgrade to provisioned IOPS, and I'm going to wait for one of these to upgrade to 1000 gigs. So I'm just going to pause video now. Okay, so it's been a couple of minutes. I'm just going to go ahead and hit refresh. And we can see that this is now IO1, and we can see that this is now 1000 gigs. So it took a little bit of time. This is actually still just coming into use. But it only actually took a couple of minutes, which is pretty amazing when you think about it. Not only are we changing the storage medium, but we're also increasing the amount of storage available. So it is pretty cool tech. So one of the things, a very popular exam question is, let's say that you've got your EC2 instance and your EBS volume in a particular availability zone. So in US East 1B, for example, and you want to move it to US East 1C. How do you go about doing that? Well, the easiest way to do that is to go into to find your root device volume and or all your volumes, depending on the scenario question. But let's just say it's the root device volume. So you want to move this root device volume to another availability zone. Let's go ahead and see how we do that. So we go to Actions, and we're going to go and create a snapshot. And a snapshot is exactly what you would think it is. It's basically a photograph of the disk. And I'm going to call this my EC2 Snap 2019, something like that. And then I'm going to go ahead and hit Create Snapshot. And that is now creating a snapshot. And snapshots do take a little bit of time. You can find snapshots here under EBS. If you click on there, it sometimes won't even show up in here for a couple of minutes. You can see that is pending. So while that is, I'm just going to pause the video and wait for this to come back up online. Okay, so that snapshot has now been completed and you can see it in here. Now with our snaps, what we can do is we can go ahead and create an image, or we could create another volume. If we create an image, we can then use that image to be deployed into other availability zones. So let's go ahead and create our image.
Okay, so we're going to give our image a name. We're going to call it my EC2 image, something like that. And you can leave everything else as default. One thing I will point out to you though is the virtualization type. So you've got two different types of virtualization types with AWS. You have paravirtual or HVM virtualization. If you hover your mouse over, you can read this. It says when you launch an instance from an AMI, it uses either paravirtual, PV, or hardware virtual machine virtualization, HVM. And HVM virtualization uses hardware assist technology provided by the AWS platform. With HVM virtualization, the guest VM runs as if it was on native hardware platform, except that it still uses PV network and storage drivers for improved performance. Some instance types support both PV and HVM, while others support only one or the other. So essentially, if you are creating an image from an EBS snapshot, you want as many different EC2 instance types as possible, you want to make sure that this is on hardware assisted virtualization, and that is the default one now. So make sure this is hardware assisted virtualization. That will give you a lot more different EC2 instance types to launch this image from later on. So let's go ahead and hit create, and let's go ahead and hit close. And once that image has been created, we'll then be able to go and use that image to provision new EC2 instances.
We can see our images over here under AMIs. So if I go in here, we can see that image is now available, and I can go ahead and click on that and go ahead and hit launch.
And now you can see all the different EC2 instances that are available to us. So we want to choose the T2 micro, and I'm going to go over and hit next to configure our instance details. If your screen looks like this when you are trying to deploy your EC2 instance, it means that your virtualization type was set to paravirtual instead of HVM. So bear that in mind. HVM will often give you much more different EC2 instance options.
So go ahead and hit next, and then what we can do is we can launch that into a completely different subnet. So I could go and launch it into US East 1A. So completely different availability zone. And sorry, sometimes I interchange subnet and availability zone. We will cover off what they are in the VPC section of the course. But for now, just note that we can launch this into US East 1A. So I'm going to go in, I'm going to add my storage, add my tags. I'm going to not do any tags. I'm going to use an existing security group. I'm going to use my web DMZ, review and launch, and I'm going to go ahead and launch that. Now, you don't have to go ahead and do this. I'm just showing you how we can migrate data from one EBS instance or one EC2 instance in one availability zone to another. So the first thing you do is you go ahead and you create a snapshot. You then turn that snapshot into an AMI, and then you use that AMI to launch into other availability zones. The other cool thing you can do is, of course, copy the AMI into different regions. So we could go in and go here to actions, and we could go ahead and hit copy AMI, and we can now move this Amazon machine image from our destination regions, from our existing region, so from Northern Virginia, and we can go ahead and move this over to London, for example. And then we can use this image to launch our EC2 instances into the London region. So this is a way of not only moving across availability zones, but also a way of moving across regions. And the only difference here is we're copying the AMI from one region to another. Once that AMI is in a new region, we can then launch it into that region and choose any availability zone that we want. So those are popular exam questions that will come up in your exam. So let's go back over to EC2, and I'm just going to go to my running instances. We can see that we've got our two running instances. This is the new one, the one that we just launched into US East 1A, and we've got one in US East 1B. We go over to our volumes, we should be able to see our new volume as well. So we've launched this one is just on GP2 standard. Here's our original one, which is on provisioned IOPS. So we learnt right at the start of this lecture, if I go ahead and delete the EC2 instance, that the root device volume is going to be deleted as well. But what about these additional volumes? What do you think will happen if I go in and terminate those two EC2 instances? Do you think these three volumes will be terminated along with this one? Or do you think that they will persist? And that, again, this can be a very popular exam topic. So let's go over to our EC2 instances and we can test this. So I'm going to go in and click in here, go to Actions, Instant State, Terminate. So we're terminating both of them. And that will go in and terminate them. So I'm just going to pause the video and wait for this instant state to change to terminated. So these have now changed to terminated. Let's go over and have a look at our EBS volumes. And you can see that these have persisted. Their state has changed. They're now available, but they have persisted on. So when you terminate an EC2 instance, by default, the root device volume will also be terminated. However, additional volumes that are attached to that EC2 instance will continue to persist. So do bear that in mind. So the next thing we want to do is just go ahead and delete these volumes. So I'm going to go in and go delete volumes and go ahead and hit yes, delete. And that has now deleted our volumes. I'm going to go through and delete my snapshots and my AMI because I don't want to be racking up charges willy-nilly. So I'm just going to go in and delete that. Sometimes if you do delete a snapshot too quickly after terminating an EC2 instance, you will get this error. So you can just come back and do that in a little bit. And then in terms of my AMI, I'm just going to go in here and go ahead and deregister this AMI. So we've now cleaned it all up. So just remember that volumes exist on EBS, and just think of EBS as a virtual hard disk drive in the cloud. Remember that snapshots exist on S3. So when we created that snapshot, that's going to take a photo, and that photo is stored on S3. And like I said, just think of snapshots as a photograph of the disk. Remember that snapshots are point-in-time copies of volumes. So when you take that snapshot, that's how that volume existed at that particular point in time. Snapshots are also incremental, so this means that only the blocks that have changed since your last snapshot are moved to S3. So if we took a snapshot and then created a new file and on that volume, and then we took another snapshot, only the blocks, only the delta, the changes between the blocks would be basically replicated to S3. So snapshots are incremental. And remember that if it's your first snapshot, it may take some time to create. Now, to create a snapshot for EBS volumes that serve as a root device volumes, you should really stop the instance before taking the snapshot, especially if it's a production workload. And that will just guarantee that your snapshots are going to be consistent. However, you can definitely still take a snapshot while the instance is running. Remember that you can create AMIs from both volumes and snapshots as well. So that's what we did. We created an AMI from our snapshot, but you can also create an AMI directly from the volume. You don't need to have to take a snapshot first. You can do it either way. And you can change EBS volume sizes on the fly, and that includes changing the size and the storage type. And volumes will always be in the same availability zone as the EC2 instance. So you'll never have a volume in one availability zone and your EC2 instance in another. Then in terms of migration, just remember that we can migrate EC2 volumes from one availability zone to another. To do that, we simply need to take a snapshot of it, then create an AMI from the snapshot, and then use that AMI to launch the EC2 instance in the new availability zone. Likewise, we can move EC2 instances from one region to another by taking a snapshot of it, creating an AMI of the snapshot, and then copying the AMI from one region to another. And we then use the copied AMI to launch the new EC2 instance in the new region. So that is it for this lecture, guys. In the next lecture, we're going to just quickly compare the different types of EBS volume types. So we've got EBS, and then we've got instance store. So we will cover that off, and then we're going to look at encryption and how we can use encryption with EBS volumes. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to look at the two different types of AMIs that you can launch. So we've got EBS, which we covered off in the last lecture, and then we've also got instance store. And this does actually come up in the exam. I did the exam just a few days ago, and you are definitely quizzed on this. So you need to understand the difference between EBS and instance store. So So when you go and select your AMI, and we're going to do this very shortly, you can basically select your AMI based on a number of different factors. So you can select it on regions, you can select it on the operating system, you can select it on the architecture, so this could be 32-bit or 64-bit, you can select it based on launch permissions, and then finally you can also select it based on the storage for the root device, or otherwise known as the root device volume. And you get two different options here. You get instant store, which is sometimes referred to as ephemeral storage, and then you have an EBS back volume. And we've been using EBS back volumes throughout the whole of this course so far. In this lecture, what we're going to do is we're going to go and launch an AMI using instant store, as well as one using EBS back volumes, and we're going to look at the differences. Before we do that, though, I just want to let you know that all AMIs are categorized as either backed by EBS or backed by instant store, so it's one or the other. So for EBS volumes, the root device for an instance launch from the AMI is an Amazon EBS volume created from an EBS snapshot. For instant store volumes, however, the root device, so the root device volume is basically where the operating system is installed. So the root device volume is created from a template that's actually stored in S3. So they are quite different. So let's log into the AWS console and have a look. Okay, so here I am in the AWS console. If I go over to services, again, we're going to go over to EC2 compute, and we're going to launch two different instances, and we'll go through it very, very quickly. So first one, we're just going to do it as standard. So we're going to do our Amazon Linux 2 AMI. We're going to leave everything as default. Again, everything as default. I'm not going to add any tags. I'm going to use my existing security group, WebDMZ, and I'm going to go ahead and hit launch, and I'm going to acknowledge that I've got my key pair. So there we go. We've launched our Amazon Linux AMI, and that is now in a pending state to be launched. Let's go launch a second instance, but instead of going through and choosing Amazon Linux 2 AMI, let's go over to our community AMIs. And in here, we can sort by operating system, we can sort by architecture, and we can sort by the root device type, and we can select Instant Store. So I'm going to go ahead and launch an Instant Store one. I'm just going to use the default one at the top. You can pick any one that you want. Now notice that because I am launching an Instant Store, it restricts the number of instance types that I can choose, and basically the smallest one I can choose is a M3 medium. So I'm going to go in and choose that. You don't have to do this if you want to not come out of free tier. You can just watch what I do on my screen. I'm going to leave everything else as default. In here, notice the volume type is Instance Store. And if you read up here, it says your instance will be launched with the following storage device settings. You can attach additional Instance Store volumes to your instance. You can also attach additional EBS volumes after launching an instance, but not Instant Store volumes. So if we do want additional Instant Store volumes, we have to do it here. We can't go on and add additional ones later. I'm going to leave this as default. So I'm just going to leave everything here as default, and I'm going to go in and add my tags. I'm not going to do any tags. I'm going to use an existing security group. I'm going to use my WebDMZ, and I'm going to go ahead and review and launch. And I'm going to go ahead and launch that. So now we're going to have two EC2 instances, one with an instance store and then one with normal EBS backed. And the way we can tell the difference between them is the size. So my T2 Micro is EBS backed, and that's in US East 1B. My M3 Medium, that's in US East 1C, and that is going to be instance store backed. So I'm just going to pause the video and wait for this to come back up online. Okay, so that is now available. So if we go over to volumes, we'll be able to see just one volume. So we can't even see our instant store volume here. We can only see our EBS backed volume. And you'll notice if we go in here, actually, let's go back over to our instances. And if we go and click on here, we're able to go to Actions, Instance State, and hit Stop. And we can go ahead and stop this instance. And if we stop this instance, all the data on our EBS-backed volume will persist. So it's persistent storage. But if I click up here and I go over to my Actions and go to my Instance States, all I can do is reboot this instance or terminate it. I cannot stop it at all. And that's because it's instance store backed. Now you might be wondering, well, what does that mean? Well, if we go over to our status checks here, and if you remember that we have two different status checks, we've got our system status checks and our instance status checks. Let's say we've got an instance store volume, and this is sitting on top of a hypervisor, and our hypervisor starts to fail. Our system status check will start to say something like impaired. And what you would normally do with EBS is you would basically go and stop that EC2 instance, and then you would start it again. And when it starts, it will load up on another hypervisor. So you can, stop your instances from, having issues with the underlying hypervisor simply by stopping them and starting them again, and they'll start up on another hypervisor. You can't do that with an instance store volume. So if this underlying hypervisor does have any type of issue, and for some reason completely stops, that's it. You're going to lose all the data on your instance store volume. And for that reason, it's called ephemeral storage. So what I'm going to do now is I'm just going to go ahead and terminate this instance because it is costing me money. It's not within free tier. And I'm going to terminate it in there. Like I said, you can't actually see it in volumes because it's not an elastic block store or an EBS volume. It's an instant store volume. So onto my exam tips. So we learned that instant store volumes are sometimes called ephemeral storage. So the reason for that is if for some reason they're stopped, you're going to lose all of your data. Instant store volumes cannot be stopped. If the underlying host fails, then you're going to lose your data. So that's all I mean is if for some reason it stops, if for some reason the underlying host fails, you are going to lose all your data on your virtual hard disk drives. With EBS-backed instances, they can be stopped, and you're not going to lose the data on that instance if it is stopped. And you can reboot both, and you're not going to lose any of your data. It's basically only if the host fails and that EC2 instance stops and it's instant store, then you will lose your data. And then by default, both root volumes will be deleted on termination. However, with EBS volumes, you can always tell AWS to keep the root device volumes. You can't do that with Instant Store. So that is it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture where we're going to look at encryption with EBS.
Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to talk about encrypted root device volumes. So root device volume is basically just the hard disk that has your operating system on it. So it's that EBS volume that has your operating system on it. And it used to be that you couldn't actually encrypt that when you first provisioned your EC2 instance. And this was always a very popular exam topic because it would ask you how to go in and encrypt it. And what you used to have to do is basically provision your EC2 instance with an unencrypted root device volume. You then had to take a snapshot. You then had to make a copy of that snapshot. And when you were making that copy, then you could encrypt it. And then basically you provision an AMI from that snapshot, and then you could launch encrypted root device volumes. So it was a bit of a process to go through, and that's why it was quite a popular exam topic. AWS have completely changed all this now, and you can provision root device volumes immediately when creating an EC2 instance. So we're going to look at how we can do that in this lab. And we're also going to look at if you do have unencrypted volumes, how you can go in and encrypt them as well. So this is a lab and you will need to log into the AWS console. Okay, so here I am in the AWS Management Console. Let's go over to Services and we'll go over to EC2. And we'll see in here I've got no running instances. I've just terminated one. I'm going to go ahead and launch an instance. I'm going to use an Amazon Linux 2 AMI. I'm going to use a T2 Micro. I'm going to leave everything as default and go and add my storage. Now in here, this is our root device volume, and you can see that it's on general purpose SSD. And in here, our encryption, this used to never be an option. So you never used to be able to change this. Now you can change this, and you can go ahead and create an encrypted volume right from the start. So that is an important new feature of EBS. I'm not going to do that for now because I want to show you a way of encrypting your volumes if you create a volume that's unencrypted to begin with. So let's go ahead and add our tags, and we'll add a tag. We'll just give this a name as unencrypted root device volume, something like that. And yes, I did spell encrypted wrong. And so there we go. And we'll go over and add to our security group. So we're going to add this into our web DMZ security group. Go ahead and hit review and launch, and I'm going to go ahead and launch that. Now we're not going to log into this or do anything to the EC2 instance other than play with it in the console. So I'm just going to pause the video and wait for this instance to come up online. Okay, so that EC2 instance is now live. And if we go over to volumes under Elastic Block Store, we can see it in here, and you can see that this isn't encrypted. So if we did want to encrypt this, all we need to do is go over to our actions, and what we want to do is create a snapshot of this volume. I'm going to call it my unencrypted snap. And we're going to go ahead and hit create snapshot. And I'm just going to pause the video and wait for this snapshot to come live. So I'm just going to pause the video here. Okay, that is now live. And if we look under encryption here, we can see that it is not encrypted. We can click in here, and what we can do is go over to our actions and go over to copy. And then when we're copying, we can say, hey, encrypt this snapshot. And then it'll ask us what key that we want to use. So I'm just going to use my standard EBS key. And then in here is our description. So I might just change this to encrypted and then snap. And then I'm going to go ahead and hit copy. So now we're creating a copy of our snapshot, and we are changing it from being unencrypted to being encrypted in here. I'm just going to pause the video and wait for this to come back up online. We can see in here that that is now live and it is encrypted. The next thing we want to do is go ahead and create an image of this. I'm going to call it my encrypted image. And we're going to go ahead and hit create. That is then going to create an encrypted AMI, and then we can use that AMI to launch encrypted EC2 instances. So that's how you take an unencrypted root device volume and you basically create a snapshot of it. You then copy the snapshot and enable encryption. You then create a AMI from that snapshot, and then you can launch that EC2 instance as an encrypted root device volume. So that could come up in the exam if they say, hey, you've already got, you've got an unencrypted root device volume, you need to encrypt it. How do you do it? That's the process. But like I said, it used to be that you couldn't have encrypted root device volumes, and it was a very popular exam topic as to how to go and encrypt them. Now you can encrypt them just by launching an encrypted root device volume. So just be aware of that going into your exam. Just going to wait for this AMI to come live now. My apologies, it already is live. So what we could do is we could go ahead and hit launch, and we could go ahead and launch this as an EC2 instance, and you'll see that it is already encrypted by default. If you click in here and go not encrypted, you'll see it's giving you a warning message and saying, well, it needs to be encrypted as the selected snapshot is encrypted. So you can't take a snapshot that's encrypted and then launch it as an unencrypted volume either. So I'm not going to go ahead and do that. We're just going to go ahead and cancel. Feel free to go in and delete that instance, as well as going in and deleting the snapshot and the AMI. And let's go on to my exam tips. So just remember that snapshots of encrypted volumes are encrypted automatically. So if you do take a snapshot of an encrypted volume, it's going to be encrypted automatically. Volumes restored from encrypted snapshots are encrypted automatically as well. You can share snapshots, but only if they are unencrypted. And these snapshots can also be shared with other AWS accounts or made public, but they have to be unencrypted. And you can now encrypt root device volumes upon the creation of an EC2 instance. If for some reason you didn't do that and you had an unencrypted root device volume, the process for making it encrypted is to create a snapshot of the unencrypted root device volume. You then need to create a copy of the snapshot and select the encrypt option. You then need to create an AMI from the encrypted snapshot, and then you use that AMI to launch new encrypted instances. So that is it for this lecture, everyone. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you.
Okay, hello Cloud Gurus, and welcome to this lecture. So hopefully you're learning an awful lot in the course so far, and you're starting to understand how complicated AWS is. Now, Heraclitus of Ephesus was an ancient Greek philosopher, and he once famously said, "Everything changes and nothing stands still." And as you start learning AWS, you're going to realize how much it changes all of the time. There's literally thousands of new product updates and releases each year. It can be really, really hard to keep up. Now, we have a web series called AWS This Week, which is basically a weekly show discussing all the new updates to AWS for the week. It's 5 minutes or less, so it won't take a lot of your time. And we have an explain it like I'm 5 approach. So if something really complicated comes out, we'll try and break it down and help you understand understand what it is and what it means to you as either a solutions architect, a developer, a sysadmin, or a business leader, or whatever it is in whatever role that you do. So it's the best way to stay up to date with AWS and all the constant changes. The link is below. It's either on our YouTube channel or you can subscribe through the A Cloud Guru website. It is seriously the best way to stay up to AWS, and like I said, it's 5 minutes or less each week. So make sure you check it out and keep being awesome. Let's go on to the next lecture. Thank you.
Okay, hello Cloud Gurus and welcome to this lecture. This lecture is on CloudWatch. Now, so CloudWatch comes up surprisingly a lot in the Certified Solutions Architect Associate exam. Used to be more sort of geared towards the SysOps Administrator Associate, and it still does feature extremely heavily in that as well. But it does come up in the Certified Solutions Architect Associate exam, and it is definitely worth 3 or 4 marks. So let's learn what CloudWatch is. So what is AWS CloudWatch? Well, CloudWatch is a monitoring service to monitor your AWS resources as well as the applications that you run in AWS. So CloudWatch basically monitors performance. Whenever you hear the word CloudWatch, I want you to think of someone at the gym. So it's all about performance monitoring. And CloudWatch can monitor things like compute. So inside compute, it can monitor things like our EC2 instances. It can monitor auto-scaling groups, elastic load balancers, Route 53 health checks. Now, I know we haven't covered these off yet. Don't worry, we are going to cover them off in the next sections of the course. But CloudWatch can basically go through and not just monitor the EC2 instances, it can monitor a whole bunch of other things as well. It can monitor storage and content delivery, and you know all these services. So it can monitor our EBS volumes. We can monitor, how busy the volumes are. We can monitor storage gateways, and we can monitor CloudFront using CloudWatch as well. So that's all CloudWatch is. It's a monitoring tool. And like I said, I want you to think of performance monitoring. Now, CloudWatch with EC2, this is always a popular exam topic, whether in the Solutions Architect Associate exam or whether in the SysOps Administrator Associate exam. But essentially, CloudWatch can monitor at a host level metrics such as CPU. It can monitor our network. It can monitor our disk. And it can do a status check, and it can monitor things like the underlying hypervisor, whether or not that is running, and then it can also monitor the underlying EC2 instance. And we'll have a look at that in the lab coming up in the next lecture. So what Amazon like to do is they like to try and confuse you, and they like to try and confuse you with CloudTrail. And they always have these questions where you'll be asked, given a particular scenario, and then you'll be asked whether you should be using CloudWatch or CloudTrail. And so CloudTrail basically is a CCTV for your AWS environment. It increases the visibility into your users and resource activity by recording AWS Management Console actions and API calls. So every time you go in and create a S3 bucket or an EC2 instance, you're basically making an API call to AWS. And this is all recorded using CloudTrail. And you can actually go in and identify which users and accounts called AWS, the source IP address from which these calls were made, and when the calls were made. So that's what CloudTrail is. So every time you see CloudTrail, I want you to imagine a big CCTV camera. Whenever you see CloudWatch, I want you to imagine performance. So CloudWatch monitors performance, CloudTrail monitors API calls in the AWS platform. So just remember going into your exam that CloudWatch is used for monitoring performance. CloudWatch can monitor most of AWS as well as your applications that run on AWS. CloudWatch with EC2 will monitor events every 5 minutes by default, but you can also have detailed monitoring turned on, and that will give you 1 minute intervals. And we'll look at how to do that in the next lab. You can also create CloudWatch alarms, which trigger notifications. And we did that when we created a billing alarm. That was essentially creating a CloudWatch alarm for our billing. We're going to do that in the next lab as well, but we're going to create some EC2 performance alerts. And then CloudWatch is all about performance, whereas CloudTrail is about auditing. And I cannot stress that enough. If you see a scenario-based question that's asking who's provisioning what resource in AWS, such as S3 or EC2, that's always going to be CloudTrail. If it's asking you what the network throughput is or the disk I/O on your EC2 instance, that's going to be CloudWatch. So just remember, CloudWatch is about performance. Just think of going to the gym, whereas CloudTrail is all about auditing. Think of a big CCTV camera or someone with like a little little sort of detective magnifying glass. So that is it for this lecture, guys. The best way to learn anything in AWS is to get our hands dirty with it. So in the next lecture, we're going to go ahead and go in and provision an EC2 instance with CloudWatch detailed monitoring turned on. And then we're going to go in and start stressing that EC2 instance and see what happens. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus and welcome to this lecture. This lecture is on CloudWatch and this is a lab, so you will need to log into the AWS console. Okay, so here I am in the AWS console. If I go over to services, I'll be able to go to EC2. I'm going to provision a new EC2 instance. I do have some EC2 instances running from the last one that I forgot to shut down, so I'm just going to quickly go in and terminate them. You should do the same if you haven't already. It just makes it easier so that we don't get our EC2 instances confused for this lab. So that's going through and terminating now. And then what I'm going to do is I'm going to go ahead and launch a new instance. Okay, so we're going to be using an Amazon Linux 2 AMI, and we're going to use a T2 micro. And then what we want to do is we want to go down here and we want to go to monitoring and we want to enable CloudWatch detailed monitoring. So we want to monitor our EC2 instances at 1 minute intervals. Now this will take you outside of free tier, so just bear that in mind. It will cost you some money. So it's optional whether or not you do it. You can just watch me, or you could just use standard monitoring and just be a little bit more patient. But I'm going to turn detailed monitoring on. Next, I'm going to go ahead and add my storage. Just going to use the standard 8 gigs. I'm going to give this a name. I'm just going to call it CloudWatch EC2 detailed, something like that. So I know it's got detailed monitoring turned on. I'm going to go and add my security group. So I'm going to add it to an existing security group. I'm going to go ahead and hit review and launch. And I'm going to go ahead and launch my EC2 instance. So that is now launching. Go and view my instance. We can see it in here. So it's a T2 micro launching into US East 1B. I've already been provisioned a public IP address. I'm going to copy that to my clipboard. And I'm going to go in and SSH into that in a second. I'm going to pause the video and just wait for this to come up, however. Okay, so that EC2 instance is now live. And if we click on status checks, we'll be able to see our system status check and our instance status check, and both have passed. And if we click on monitoring, we'll be able to see things like basically our host level metrics, so our CPU, our disk, our network, and then also our status checks. Note here, we can't see anything else. We can't see things like RAM utilization or how much disk storage space is left. If we wanted to do something like that, we would need a custom metric, and we cover off how to do that in the Certified SysOps Administrator Associate course. But what we're going to do now is we're going to log into this EC2 instance and we're going to max out the CPU. Before we do that though, let's set up an alert so that we can get an email if our CPU utilization is going above a certain percentage. So to set up an alert, we need to go into CloudWatch, and CloudWatch is under Management and Governance. If we click in here, we'll be able to see our CloudWatch overview. And what we want to do is we want to go over to alarms, and we're going to go ahead and create an alarm. And in here, we've got to select our metric, and down here are our metrics. So we're going to go over to EC2, and then we're going to do this on a per instance metric. So click in there. Now, if hopefully you remember your instance ID, I know that mine ends in 013, so this is the one that I want. If you have got other EC2 instances that you've gone through and terminated, for example, you will see them in here. But I'm just going after my this instance ID that ends in 013. And then what I want is CPU utilization. So if I scroll down, I can see it in here. So I'm going to click in there, and I'm going to go ahead and hit select metric. And then my name in here, I'm just going to click in here, and I'm going to type CPU utilization 90%, something like that. So this is basically saying that as soon as my CPU utilization goes over 90%, it's going to send me an alarm. And so whenever CPU utilization is greater than or equal to, we'll just put 90 for 1 out of how many data points. So because this is 1 minute intervals, it's saying for 1 minute out of 1 minute. So if my CPU utilization goes greater than 90% for 1 minute out of a minute, then it will send me an alarm. You can actually edit this, so you could say for 2 minutes out of 5, or you could say for 3 minutes out of 10, or whatever. I'm just going to leave it as 1 out of 1. And then I'm going to scroll down, and it says whenever this alarm, state is alarm, send a notification to, and we can go ahead and do a new list. So click in there, and then all you want to do is enter your email address in there, which I'm going to go ahead and do now. Once you've done that, go ahead and hit create alarm, and you will have to give this a name. So just call it CPU, something like that, and go ahead and hit create alarm. And that will ask you to confirm your email address. I've gone ahead and just confirmed that. I'm going to go back to CloudWatch. That's ready to go, and we can go ahead and view our alarm. Right now, there's insufficient data because we're not using this EC2 instance. So let's go back over to EC2. I'm going to grab my public IP address, and I'm going to go ahead and SSH into this instance. Okay, so here I am in my SSH terminal. I'm just going to type in SSH EC2-user and then @ and then -i, and then the name of my key pair. And I'm going to connect in, and then I'm just going to elevate my privileges to root. I'm going to clear the screen. And then all we're going to do is we're going to type while true, do, echo, and then done. And this will basically put our EC2 instance into an infinite loop, and that's going to max out the CPU. So you won't see anything, you'll just see this little bright blue flashing thing here. But hopefully in a minute or two, you should get an email saying that your CloudWatch, that your EC2 instance is in a state of an alarm. So I'm just going to pause the video and wait. Okay, and we can see here I've got my alarm CPU utilization. So it has triggered my alarm, and it's basically sent me an email notification saying, hey, your EC2 instance has gone above 90% CPU for longer than a minute. And I'm back in the AWS console. If I just click on monitoring, I'll be able to see down here my CPU utilization has hit 100%, and that will basically flatline out if I continue to let this run. So let's go back over to CloudWatch. We can find it under Management and Governance. And I'm just going to show you a couple more things. So we set up an alarm. We can see that that alarm has now been triggered. In here, we've got our dashboards, so we can create dashboards, and we can create, a dashboard to show us either this region or another region. We could look at our entire global overview. Again, I'm not really going to go into that. That's more a SysOps Administrator Associate thing, but going into the exam, just be aware that you can create dashboards, and your dashboards can be global as well as regional. We've also got in here logs. So in our logs, this allows us to do performance logging essentially. So you can send all your logs to CloudWatch. And then in here, we've got events. So CloudWatch events basically delivers a near real-time stream of system events that describe changes in AWS resources. You can go in there and set up some events if you want. But again, that's beyond the scope of the Solutions Architect course. We do that in the Certified SysOps Administrator Associate course. So let's have a look at my exam tips. So just remember going into your exam that standard monitoring is 5 minutes, detailed monitoring is 1 minute. Remember what you can do with CloudWatch. So just like we just saw, you can create awesome dashboards and see what's happening with your AWS environment. You can also go in and create alarms, and this will give you notifications when a certain threshold is met. We can also go in and configure events, and this helps you respond to state changes in your AWS resources. And then we also have logs, and CloudWatch logs allows you to aggregate, monitor, and store your log data. Also remember, when we're dealing with CloudTrail and CloudWatch, Amazon like to try and confuse you between the two. So CloudWatch always monitors performance, whereas CloudTrail monitors API calls within the AWS platform. So again, if the question's asking you about, you want to be able to see who set up an S3 bucket or who provisioned an EC2 instance, that's going to be CloudTrail. If you want to monitor the performance of an EC2 instance, that's going to be CloudWatch. So that is it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to learn all about the AWS command line. Now, the command line is really, really powerful. It enables you to interact with the AWS platform anywhere in the world. So you can interact directly with the platform using your laptop, using the command line. So you can go in and provision things like EC2 instances or S3 buckets, etc. And it's a way of doing it without using the AWS console. So let's go ahead and go over to the AWS console. Okay, so here I am in the AWS console. I need to go over to services, and we're going to go over to identity access management. Now, you probably already have a user and group set up, but just in case you don't, I don't actually have it in this account, so I'll show you what to do. So we're going to go over to our users. I'm going to add a user. I'm going to call this user my EC2 user. And then I'm going to give them programmatic access. So we're not going to give them console access. It's programmatic access only. So we're going to use this for the AWS CLI. Next, we're going to add our permissions. So I'm going to go and create a group. I'm going to call this my admins group, something like that, admins group. And then I'm going to give them administrator access. So I'm going to apply this policy to the group. And of course, my user will inherit that permissions from the group. Next, I'm going to go ahead and just keep hitting next, and then I'm going to go ahead and hit create user. So that now gives me my access key ID and secret access key. So I want you to go ahead and download this. And once you've done that, go ahead and close it. Now, remember, you'll only ever be able to get that once. If you do lose the access key ID and secret access key, you can actually go into your user and then just go over to security credentials. And in here, you can make it inactive. You can create a new one there. So that's how you do it if you do lose the access key ID and secret access key. Now that I've got that, I'm just going to go back over to EC2, and I still have that EC2 instance that's bottlenecking at 100% CPU utilization. I'm just going to go in and delete that instance, and we'll just provision a new instance quickly. Now, annoyingly, I'm actually having an issue right now in Northern Virginia where the command line is not working for EC2. It is a regional thing. It does work in other regions, so I'm just going to switch over to another region. It should work fine for you when you watch it. But it's also a good demonstration to show you that the command line is completely global. You can use it anywhere in the world. So I'm going to switch over to the London region, and I'm going to go in and provision a new EC2 instance in here. So I'm going to go ahead and launch my instance, Amazon Linux 2 AMI. Let's use the default values of T2 Micro, default values here, add our storage, add our tags. I'm just going to give this a name. So I'm going to call it my CLI EC2. And then I'm going to go in and configure my security groups. I'm going to create a new security group because this is a new region, which I've never used before. So WebDMZ. I'm just going to leave port 22 open to the world. And then I'm going to go ahead and launch. And because I've never used this region before, I need to create an existing key pair. So I'm just going to change this up here to create a new key pair. And I'm going to call this key pair London key. I'm going to go ahead and download that, and then I'm going to go ahead and launch the instance. So that is now launching. We should be able to see it in here. I've already got the public IP address. I'm just going to go over to my command line. So I'm in the command line. I'm just going to move that key pair over to my SSH directory. I'm going to go into my SSH directory, and I'm going to chmod my key pair. So it's I'm going to change the permissions to 400 to lock it down. And then I'm going to SSH in. So SSH, EC2, then -user, and then then my public IP address, then -i, and then the key pair, which is londonkey.pem. I'm going to hit yes. And there we go. I am now in my EC2 instance. I'm going to elevate my privileges to root. And then what I'm going to do is go ahead and clear the screen. Okay, so to use the AWS command line, all we ever need to type is AWS, and then the service that we want. So we could type S3 and then LS. So this is basically just saying, hey, tell me what S3 buckets I've got. Now it says unable to locate credentials. You can configure credentials by running AWS configure. So why don't we do that? We'll run AWS configure, and now it's asking for our access key ID and secret access key. So I want you to copy and paste those in. So here's my access key ID, here's my secret access key. My default region, you could do type in US East and then -1, and then your default output, just hit enter. Okay, so what will happen now if we run AWS S3 and then LS? And there you go, you can see my 3 buckets. So I'm now able to access S3. I'm able to list all my buckets. I could type AWS S3 and then make bucket and then S3, and we could just do test bucket. Of course, that name's going to be taken, so I'll probably get an error message. But there you go, an error called, an error occurred, bucket already exists. But you, let's go ahead and try that again. So do AWS S3 and then make bucket and then S3. And then we'll just do a whole bunch of random letters and random numbers. And sorry, this should be S3 //. And there we go, it's made my bucket. So if I now type AWS S3 and then LS, I should be able to see my new bucket, and there it is there. So you can use the command line to start provisioning resources within AWS. You can provision EC2 instances. You can pretty much do almost anything in AWS using the command line. So I'm going to clear the screen and we're going to go over to our home directory. And if you type it in an ls in here, you can't see anything, but there is a hidden directory. If you go to the cd.aws, that's a hidden directory. And in here, it basically contains your config and your credentials. And if you want to have a look at your credentials, you can go ahead and you can see that the access key ID and secret access key are saved in the credentials file in the home directory in the .aws. Now, for this reason, it can be a bit of a security risk, because if someone goes in and hacks this EC2 instance, all they've got to do is go over to the home directory and go into your AWS hidden directory and just open up this credentials file, and then they've got your access key ID and secret access key. And they can use this access key ID and secret access key to access the AWS platform on other EC2 instances or on their laptop or on their PC. They can use it to access your AWS account anywhere in the world. And for that reason, Amazon always say, do not store your credentials, do not hard code them, do not put them on GitHub, for example. And it's much safer to use a thing called roles. And we're going to cover that off in the next lab. So what have we learned? So we've learned that you can interact with AWS from anywhere in the world just by using the command line, and you'll need to set up access in Identity Access Management. So we set up our user, we put our user into a group, and then we applied administrator access policies to that group, which of course the user inherits. And the commands themselves are not in the exams, but some basic commands will be useful to know for real life. So just like what we learned, AWS S3 ls or AWS S3 MB, make bucket, and then the bucket name, things like that. And there's lots and lots of documentation on the command line. So go ahead and have a look at it when you get some free time. So in the next lecture, we're going to look at how we can use roles to access the AWS environment in a much more secure fashion. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to look at identity access management, and we're going to look at how we can use roles. So roles enable us to interact with the AWS platform without having to, pass our EC2 instances, access key IDs, and secret access keys. And roles aren't just used for EC2; they're used for basically every other AWS service as well. And we're going to have a look at that in the AWS console. So this is a lab, and you will need to log into the AWS console. Okay, so here I am in the AWS console, and if I just go over to services, I'll be able to create a role under Identity Access Management, which is under Security, Identity, and Compliance. And we have actually already created a role before. If you click on roles, you'll be able to see some roles in here, and you should see a cross-region replication role. So we created that role automatically when we enabled cross-region replication for our buckets. So let's go ahead and create a new role. And in here it says, choose the service that will be using this role. So you can see here a list of services that support roles. We're obviously going to be using EC2. So click on EC2 and go ahead and hit next. And then it's going to ask us to attach a policy. So I'm going to give us administrator access for this role. And then we're just going to go ahead and hit next. And then the role name, I'm just going to call it admin access. And that's it. And I'm going to go ahead and create my role. So that has now created my role. Let's go over to EC2 and we can find it under compute. I'm sure you know that by now. And in here we've got our running instance. So at the moment, this is the EC2 instance from the last lab. I'm going to go over and SSH into it. Okay, so here I am in my EC2 instance. And if you just go over to your home directory, if you remember, if we type in ls, we can't see anything, but there is a hidden directory, which is the .aws directory. So let's go ahead and delete that. So what I'm going to do is I'm just going to type rm-rf and then .aws, and this will delete that directory. So it has now deleted it. If we go try and go into it, you can see now that there's no such file or directory. And if we type AWS S3 ls, we won't be able to access S3 anymore because we've just deleted all the credentials that allowed us to do it. We can recreate that directory just by running AWS configure and then entering in our access key ID and secret access key. I'm not going to do that, however. I'm just going to leave it, and what we're going to do now is we're going to go and attach a role to an EC2 instance. So I'm back in the AWS console. I'm going to click on my EC2 instance, and I'm going to go over to Actions, and I'm going to go to my instance settings, and in here you can see Attach Replace IAM Role. So let's go ahead and click on that. And we're going to give this role, we're going to attach our admin access role. And I'm going to go ahead and hit apply. And then I'm going to go ahead and hit closed. So that has now attached the role. You should be able to see it down here somewhere. So here we go, IAM role, administrator access. If you click on that, you'll be able to see the role itself, and you'll be able to go in and see the actual policy. You can click on the JSON, and the policy is actually quite interesting because basically it's saying effect, allow, action, wildcards. So allow any action on any resource, and that is administrator access. So that will give you full access to the AWS platform. Let's go back over to our SSH terminal. So I'm back in my SSH terminal, and now if I type AWS S3 LS, we'll be able to see our S3 buckets. So there we go. We now have full administrator access to our AWS environment. But likewise, if we try and go to the AWS hidden directory, it's not there, and there's no credentials being stored on this EC2 instance now. So if this EC2 instance got hacked, hackers would still be able to run the AWS command line, they'd still be able to do stuff, but they wouldn't be able to take our access key ID or secret access key. So this would be their only port of entry into our AWS account. So let's go ahead and delete that EC2 instance. So I'm just going to go back to the dashboard, back to EC2, and then I'm going to go into my running instance, and I'm going to terminate that instance. And there we go, that's terminated. So what are my exam tips? Well, roles are far more secure than storing your access key ID and secret access key on individual EC2 instances. Roles are much easier to manage. So imagine if you did lose your access key ID and secret access key, and you had a fleet of 1,000 EC2 instances that key was installed on. You'd have to go in and update the access key ID and secret access key on all those 1,000 EC2 instances. Whereas if you just had a role, you could actually just go in and change the role, and that change would take effect immediately. Roles can be assigned to EC2 instances after it's created, both using the console as well as the command line. Roles are universal, so you can use them in any region. So we created that role in IAM. We were able to use it in the London region. Likewise, we'd be able to use it in the Northern Virginia region or anywhere else in the world. So that is it for this lecture, guys. In the next lecture, we're going to look at bash scripting, and this is an awful lot of fun. I love bash scripting with AWS. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to learn how to use Bootstrap scripts. So Bootstrap scripts are a way of automating your AWS EC2 deployments. It's a way of running things at the command line when your AWS EC2 instance first boots, and you can run things, individual commands. So you can run updates, you can install software, you can basically do anything that you can do in the command line, and it will run as a script as that EC2 instance first boots up. So let's go over to the AWS console. Okay, so here I am in the AWS console. I am in the Irish region. I'm still having, there's some DNS outages in Northern Virginia right now, which is causing a whole bunch of weird problems for me. I can't run yum update, for example, on any EC2 instance. So I'm going to do this from the Irish region where it will work fine. So let's go over to EC2, and we're going to go in and provision a new EC2 instance. So I'm going to go ahead and launch my instance. I'm going to use the Amazon Linux 2 AMI, and I'm going to use a T2 micro. Now I am going to give this instance a IAM role, so I'm going to give it admin access. And the reason for that is I'm going to create an S3 bucket using my Bootstrap script. Now, if you see down here, we've got advanced details, and if you click on that, it will open up this little text box. And in here, we paste our Bootstrap scripts. So a Bootstrap script will always begin with the number symbol, and then followed by an exclamation mark, and this is called a shebang. And then what we do is we do /bin/bash, and this is the path to our interpreter. And our interpreter basically just takes the commands and runs them at root level when we first provision our EC2 instance, when it first boots up. So what should we do when this first boots up? Well, I think it's sensible to do a yum update. I think then what we want to do is we want to go in and install the Apache service. So we'll do yum install HTTPD. So we're turning this into a little web server. Once that service is installed, we want to start the service. So service HTTPD, and then start. And then, of course, if the EC2 instance reboots, we want to make sure the Apache service comes back up on a reboot. So to do that, we just type in check config HTTPD and then on. And then what we might want to do is we might want to go over to our var www HTML directory, and we might want to create a little web page. So we'll put in here echo HTML, and then we're going to do a header, and we'll just say, hello, cloud gurus, welcome to my web page, something like that. And then we're going to end our header, end our HTML, and then I'm going to close that out. So it's going to echo that, and we want it to write to an index.html file. So that will create an index.html file with the hello cloud gurus, welcome to my web page. And then we might just want to create a random S3 bucket. So let's do make bucket, AWS S3 make bucket. And then we'll just call it, when you copy and paste this from the resources section, make sure you change the bucket name. So I'm just going to do a whole bunch of random letters and numbers. So that will then go ahead and create my bucket. And then what I might want to do is I might want to back up my web page to my S3 bucket. So we might do AWS S3 and then copy index.html. And we want to copy that to S3. And then again, I'm going to just paste that in there. So if this works, what's going to happen is it's going to go in, it's going to do an update, it's going to install Apache, it's then going to start the Apache service, it's going to then make sure the Apache service turns on if there's a reboot, it's going to go over to my var www HTML directory, it's going to create a little web page, and then it's going to create an S3 bucket and then move the contents of my web page over to S3 as well. So it's going to do a backup. And in theory, we shouldn't even need to log into this EC2 instance. We should just be able to navigate to its public IP address, and we'll be able to see this web page. Hello, Cloud Gurus, welcome to my web page. I'm just going to copy and paste this into my clipboard so I can give it to you in the resources section. You'll be able to download this in the resources section of the course. Let's go in and add our storage. So I'm just going to use 8 gigs. And my tag, I'm just going to call this bootstrapped server. And then I'm going to go into my security groups. I'm going to use an existing security group, use my web DMZ, and I'm going to go ahead and hit review and launch. I'm going to launch this with my London key pair, and there we go. I'm going to go ahead and launch my instance. So as soon as that EC2 instance comes up, I should just be able to navigate to this IPv4 address. And once I do that, I should be able to see my web server. So I'm just going to pause the video and wait for this website to come up online. Okay, it is now up online. I'm going to go over to a new tab and I'm just going to paste it in. And there we go. Hello, Cloud Gurus. Welcome to my web page. So it is definitely working. That script has run successfully. Let's go back over here. And we'll go back over to S3 and we'll see if it's created my S3 bucket. I can see my S3 bucket in here. This is a new S3 bucket, and I can also see my index.html file, which is now in there as well. So it's backed it up to S3. So Bootstrap scripts are super powerful. As you can see, it's a way of automating your infrastructure so you don't have to go in and manually install things. So feel free to come back and delete that bucket. I'm just going to go in and hit delete. And to delete it, I need to copy this into my clipboard up here. So just copy and then paste and then hit confirm, and that will go ahead and delete my bucket. Let's go back over to EC2. So I don't want you to delete this instance just yet. We are going to use it in the next 2 labs, so make sure you have access to it and just leave it up and running. So if you've got the time, please join me in the next lecture where we're going to look at instance metadata. Okay, hello Cloud Gurus and welcome to this lecture. In this lecture, we're going to look at instance metadata. So in the last lecture, we looked at Bootstrap scripts and we passed it some user data. We can actually go into our EC2 instance and look at this user data as well as instance metadata. So what I want you to do is to SSH into your EC2 instance. Okay, so I'm in my EC2 instance. I've elevated my privileges to root. I'm just going to clear the screen so it looks clean. And then what I want to do is I'm going to run the curl command, and then I'm going to do it to this IP address. So we're going to go to 169.254.169.254, then /latest, and then /, and then we'll do user-data. And there you go. You can actually see our Bootstrap script. It's all these lines here. So this is what we passed to it when it first booted up. And you can, if you hit up again and go all the way to the end of the command, then we can output this to bootstrap.txt. And if we type now cat bootstrap.txt, we'll be able to see that we've created a file called bootstrap.txt, and we've passed our bootstrap script that was saved in our user data to bootstrap.txt, and you can actually see the file in there. So let's clear the screen. So that's a way of passing our bootstrap script to our EC2 instance, and then having our EC2 instance remember it. You can use the curl command to do that. Another thing we can use the curl command is to get data on our individual EC2 instance. So again, we're going to go to HTTP, and we're going to go to 169.254.169.254, and then /latest. And then this time, instead of saying user data, we want to see metadata, and then /. And I'll give you a whole bunch of different options. So let's say we wanted to get our IPv4. If we hit the up button again, and we go all the way to the end, and then now just type local, and then hyphen, and then IPv4. And you can see my local IP address there. So it's my 172.31.22.213. I can also do it for my public IP. So instead of saying local IP, we want public and then hyphen IPv4. And there you go, that's my public IP address. And likewise, I can output this data into a text file. So I could call it myip.txt. And if we now do ls, we can see that we've got myip.txt. If I cat that, so myip.txt, I'll be able to see the IP address in there. And what I could do is have a bootstrap script that runs this, gets the public IP, writes it to a file, then automatically copies it over to S3. That could then trigger a Lambda function. And I know we haven't covered off Lambda yet, but we'll get to that in a few sections of the course. And then you could basically store that IP address in a database, or you could write it directly to a database from your EC2 instance. So there's lots of things you can do using the curl command and lots of data that you can get. And just to see it all you need to do is just type in curl and then go curl http 169.254.169.254 / metadata, and then just hit enter, and you'll be able to see all the various different options there. So what are my exam tips? Well, just remember that metadata is used to get information about an instance, such as its public IP. And you can do that by running this command. So curl http 169.254.169.254 / latest / metadata. And then you can also get your user data, and your user data will simply contain the bootstrap script that you ran, and that's what's passed to it when it is first provisioned. And you can get that running the curl command, so 169.254.169.254 / latest / user data. So that is it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to look at EFS. So what is EFS? Well, EFS stands for Elastic File System, and it's a file storage service for Amazon's Elastic Compute Cloud, or EC2 instances. So it's similar to EBS, except where you've got EBS, you can only mount your virtual disk to one EC2 instance, and that's just the way it works. You cannot have an EC2 instance, two EC2 instances sharing an EBS volume. However, you can have them sharing an EFS volume. So EFS is an easy way to use and provide a simple interface that allows you to create and configure file systems quickly and easily. And with EFS, storage capacity is elastic, growing and shrinking automatically as you add and remove files, so your applications have the storage they need when they need it. So it is actually really cool. Basically, if you provision an EFS instance, it will just grow automatically. So you could put like a 1 terabyte file on there, and then add another terabyte. You don't need to pre-provision storage like you do with EBS. So EFS is a way, it's great for basically file servers. It's a great way to share files between different EC2 instances. So as always, the best way to learn EFS is to go in and start using it. What we're going to do is we're going to create 2 little EC2 instances. We're going to run a bootstrap script on them to install some tools as well as Apache. And then what we're going to do is we're going to go and mount this, our var www HTML directory to an EFS mount point. And then that way we only need 1 copy of our website, or our website will be stored on EFS. and when we go and update or make changes to it, we're just those changes are replicated automatically across all our EC2 instances. So if you've got the time, please join me in the AWS console.
Okay, so here I am in the AWS Management Console. I'm currently in the London region. Let's go ahead and provision our EFS cluster. So you'll find EFS under storage, and we're going to go in and provision our EFS file system. So let's go ahead and create our file system. In here, we can see the 3 different availability zones that's going to be spread across. It is going to go into our default security group within our default VPC, and you will need to remember that for a bit later. Let's go ahead and hit next. And in here we can add in our tags. We don't need to add any in there. This is quite new, enable lifecycle management. So just like how we have lifecycle policies on S3, we also have this with EFS. And essentially you've got different policies in here. So if your files haven't been accessed in the last 14 days or 30 days or 60 days or etc., it'll automatically move them over to EFS infrequently accessed storage class, which is cheaper. I'm not going to do that because we're going to delete this almost straight away. In here we've got our throughput mode. We're going to just use bursting. We don't need provision throughput. Same with performance. It's just going to be a single web page that we're putting on here. So we're going to do general purpose and not max IO. And I am going to enable encryption of my data, and I'm just going to use this KMS master key. It's going to make one for me called Elastic File System. Let's go ahead and hit next, and we'll go ahead and hit create file system. So that can take about 4 or 5 minutes to go in and create your file system. You will see it in here that it's the mount target state is creating. This will change to available in about 4 or 5 minutes. Let's go over to our EC2 instances. I'm going to go in and provision our EC2 instances. So let's go ahead and launch our instances. We're going to do an Amazon Linux 2 AMI. I'm going to do a T2 micro, and I'm going to change the number of instances in here to 2. And then I'm going to give it this bootstrap script. So this is the bootstrap script in here. Essentially all we're doing is running a yum update. We're installing Apache. We're starting the Apache service. We're making sure Apache comes back on if our EC2 instance restarts. And then we're installing the Amazon EFS utils tool. And that will allow us to mount it a bit later to our file system to our EC2 instances. So grab that, copy it into your clipboard, and then just paste it in here. And then we'll go ahead and hit next to add our storage. I'm going to leave everything else as default. I'm going to drop this into my WebDMZ security group, and then we're going to go ahead and launch it, and make sure you have access to your key pair because you will need to SSH into these EC2 instances. They're now launching. While we're waiting for those to launch, let's go over to our security group. So if you remember, we provisioned our EFS file system into our default security group, and EFS is going to, or our web servers are going to communicate to our file system using the NFS protocol. So we actually need to open this up on our inbound firewall rules. So let's go in here and hit edit, and you can see I've actually already got this one in, but we may as well just add it in manually. So you just click in here, scroll down to NFS, and then it's on port 2049. And to do that, you just type in SG and then select your WebDMZ and go ahead and hit save. And then you should be able to see that you've got your NFS firewall rule in here. So it's allowing NFS protocol into our default security group from our web servers. And if you don't do this, the lab isn't going to work. So don't forget to do this. Let's go back over to our EFS and see if it's up online to our Elastic file system. See in here that my mount target states are now all available, so it is good to go. Before we go in and mount this, let's go and open up, let's go over to EC2, and we want to grab the public IP addresses of our 2 running instances. So I'm going to select this one first. I'm going to copy this into my clipboard. I'm going to type SSH EC2 and then -user and then @ and then paste my public IP in there, and then it's called my London key pair. And I'm going to hit yes, and then I'm going to elevate my privileges to root. I'm going to clear the screen. Let's go over to our var www HTML directory and just make sure it exists. If it exists, that means that Apache has been installed, so we're all good to go. Then you just need to go back a directory, so go back to your www directory and go ahead and clear the screen. Let's grab our second IP address. So the second one is this one here, and we're going to do exactly the same steps. So just copy this into our clipboard, go back over, and then need to go back over to my other tab. And then in here, I'm going to type in SSH EC2 and then -user, and then @ and then enter in my public IP address, -i, and then it's my London key pair. Again, I'm going to type yes, elevate your privileges to root, so sudo su, just clear the screen just to make it easier to see. Then we're going to go over to our cd var www and then HTML directory. Make sure Apache is installed, which it is. And then go back a directory. It's very important that you always go back a directory to our www. So we've got our two tabs open, both in our www, and we've got separate internal IP addresses. Let's go back over to our browser, and we're going to go back over to EFS, and we're going to mount our Elastic file system to our EC2 instances. Amazon make this very easy for us. All we need to do is scroll down to here and click on the mount instructions from a local VPC. That will then give us the command. We've already ran this command in the Bootstrap script, so that has already been done. And then what we need to do is go down here. There's two different commands here using the mount helper. This one will do it, and it means that there will be no encryption in transit. We don't want that. We want to make sure our files are encrypted in transit because we've also got encryption at rest turned on. So we want to use the TLS command in here. You won't need sudo because we're already at root. So just copy that into your clipboard. Go back over to your browser and click on one of the tabs. I'm going to paste it in here, but we don't want it to go to the EFS directory. We want it to go to our var www and then HTML directory. So HTML. And then when you hit enter, it can take like a few seconds. If it hangs for more than a minute, it means your security groups aren't working. That's typically what it is. Again, I'm going to paste the same tab or the same command into the other tab, and we're going to change it to my var www and then HTML directory. And then in here, I'm going to type ls. So you can see my HTML directory. If I go into it and then type ls, there's nothing in there. So let's create a file. So we're going to do echo. I'm going to make a little web page. So HTML, and then do our body, and we'll do our header, and we'll say hello EFS gurus. And then I'm going to end my header, end the body, and then we're going to end the HTML. So end HTML. Close out our quotations, and then we're going to output this to our index, then .html. And then if we type in ls, that's created the file. If we type cat index.html, you can see the contents of the file in there. We go back over to our other tab, type in ls, we can see our HTML directory. We go into the HTML directory and type ls, we can see index.html. If we cat it index.html, you can see the contents of the file. Now we can go in on this EC2 instance and we could change the file. So we could go nano index.html, and then instead of saying hello EFS gurus, we end it, keep being awesome cloud gurus. And then I'm just going to hit Control X, yes, and then hit enter. I'm going to change my tab over to my other EC2 instance, and if I do cat index.html, you can see that they're all reading from the same file, so it's all on the same file system. So you make a change on one, that change is automatically replicated out to our other web servers. You can go and visit the website we just created by going to the public IP address, and you can check it out there. I'm not going to. What we are going to do is, it can take a while to delete your file systems in EFS, so I'm going to go in and just terminate the EC2 instances first. So we just do that by going up here, Actions, Instance State, and then we'll go over and hit Terminate, and hit Yes, Terminate, and then we'll go over to EFS, and then we're going to go into this EFS Elastic file system. Going to delete the file system, and you just grab the name of the file system in here, copy it into your clipboard, and then paste it in here, and it says it's a destructive action that cannot be undone. So let's be destructive in our AWS environment. So that is it. It's really, really simple. EFS is a way of having common file systems or storage using NFS between your different EC2 instances. Very easy to set up and get going, and then you don't need to worry about syncing files between your EC2 instances because they're all on the same file system. So let's go and have a look at my exam tips.
So what are my exam tips? Well, EFS supports a Network File System version 4 or NFS v4 protocol. With EFS, you only pay for the storage that you use. There's no pre-provisioning required. It's not like EBS where we have to, say, hey, I want an 8 gig EBS volume. We basically just pay as we go. It can scale up to the petabytes, and it can support thousands of concurrent NFS connections. And then data is stored across multiple availability zones within a region. And in terms of the consistency model, it's always read after write consistency.
So you're almost at the end of this section of the course. We're going to have a very quick lecture looking at placement groups in the next lecture, and then we're going to summarize everything that you've learned. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to talk about EC2 placement groups. So congratulations, you're almost at the end of the EC2 section of the course. You've done really, really well. Hopefully you've learned an awful lot and had an awful lot of fun. In this one, it's just a pure theoretical lecture. EC2 placement groups do come up on the exam. There used to be only one type of placement group, and it used to be a very popular exam topic. Now there's 3 different types of placement groups, and you will need to understand what they are going into your exam and the differences between the 3. So what is a placement group or an EC2 placement group? Well, it's pretty obvious from the name actually. It's just a way of placing your EC2 instances, and there's 3 different types of placement groups. So we have our clustered placement groups, our spread placement groups, and then our partitioned placement groups. And we'll go through each one individually. We'll start off with the easiest. So clustered placement groups is basically a grouping of instances within a single availability zone. Placement groups are recommended for applications that need low network latency, high network throughput, or both. So essentially, it's a way of putting your EC2 instances very, very close to each other so that you have very low network latency, and you can also have very, very high network throughput. So that's all it is. It's a way of grouping your EC2 instances very, very close together within a single availability zone. And only certain instances can be launched into a clustered placement group. We then have our spread placement group, and this is basically the opposite idea. So it's a group of instances that are each placed on distinct underlying hardware. So these will be on separate racks with separate network inputs as well as separate power requirements. So if you have one rack that fails, it's only going to affect that one EC2 instance. So spread placement groups are recommended for applications that have small number of critical instances that should be kept separate from each other. And you can have spread placement groups inside different availability zones within one region. And with a spread placement group, I want you to think of individual instances. So this individual EC2 instance is on this individual piece of hardware, and it's completely isolated from this individual EC2 instance and this one, etc. So if a rack does go through and fail, it's only going to affect the one instance. So that's all a spread placement group is. It's the sort of opposite of a clustered placement group in that, clustered placement group puts all your EC2 instances very, very close together, so you get really high performing network throughput as well as low latency, whereas spread placement groups are designed to protect your EC2 instances from hardware failure, but it's individual instances put on individual racks inside either the same availability zone or different availability zones depending on how you configure it. We then have partition placement groups, which are very, very similar to spread placement groups, except you can have multiple EC2 instances within a partition. So when using partition placement groups, Amazon EC2 divides each group into logical segments called partitions. And Amazon EC2 ensures that each partition within a placement group is on its own set of racks, and each rack has its own network and power source, and no 2 partitions within the placement group share the same racks, allowing you to isolate the impact of hardware failure within your application. So if you go through and read the documentation, it does take a little while to get your head around the difference between a spread placement group and a partition placement group. And basically the difference is you can have multiple instances in a partitioned placement group. So you can have multiple instances on this rack, and you can have multiple instances on this rack, and this rack is completely separate to this rack. So EC2 instances are basically sitting on partition 1, and then you've got a whole bunch of EC2 instances sitting on partition 2. That's a partitioned placement group. But if you're dealing with individual EC2 instances, then that's a spread placement group. So a spread placement group is for a single instance, partition placement groups are for multiple instances, and then your clustered placement groups are just a way of putting everything as close together as possible. So on to my exam tips. Just remember the 3 different types of placement groups. So we've got our clustered placement groups, our spread placement groups, and our partition placement groups. So what is the use case for a clustered placement group? Well, it's for low network latency and high network throughput. So you want your EC2 instances to be as close to each other as possible. they'll always be in the same availability zone in the same region. Our spread placement group is where we've got individual critical EC2 instances, and we need them to be on separate pieces of hardware. So if one piece of hardware fails, it's going to isolate that EC2 instance. It's not going to knock out two EC2 instances at once. It's only going to be that one EC2 instance. So that's all a spread placement group is. And then partitioned is for multiple EC2 instances. So use cases for this could be HDFS, HBase, and Cassandra clusters. So partitioned is basically just multiple EC2 instances, whereas spread is individual critical EC2 instances. A clustered placement group can't span multiple availability zones, whereas a spread placement and partitioned placement group can, but they still have to be within the same region. The name that you specify for a placement group must be unique within your AWS account. Only certain types of instances can be launched in placement groups. So these are things like compute optimized, GPU, memory optimized, and storage optimized as well. AWS recommend homogeneous instances within clustered placement groups. So if you are doing a clustered placement group, you want to have the same EC2 instance types inside that clustered placement group, or at least that's Amazon's recommendation. You can't merge placement groups, and you can't move an existing instance into a placement group. What you can do is create an AMI from your existing instance and then launch that instance from the AMI into a placement group. So that is it for this lecture, everyone. If you have any questions, please let me know. Congratulations for getting it to the very end of the EC2 section of the course. In the next lecture, we're just going to summarize everything that we've learned in this section of the course, and then we'll be able to move on to the next section. So if you've got the time, please join me in the next lecture. Thank you.
Okay, hello Cloud Gurus, and welcome to the EC2 summary. So congratulations, you're at the end of another section of the course. Hopefully you've learnt an awful lot. The first thing we learnt about was what EC2 is. It's basically just a resizable compute capacity in the cloud, or it's a way of provisioning virtual machines in the cloud. And it reduces the time required to obtain and boot new servers instances to minutes rather than hours or days or weeks or months, depending on where you work. And it allows you to quickly scale capacity both up and down as your computing requirements change. So we have 4 different pricing models for EC2. We've got on demand, and this is where you pay a fixed rate by the hour or by the second with no long-term commitments. We then have reserved. This is where you have a capacity reservation. Contract terms are 1 year or 3 years. The more you pay up front and the longer the contract term, the more discounts you get. We then have spot. This enables you to bid whatever price you want for instance capacity, and it basically moves around like the stock market. And we then have dedicated hosts, and this is physical EC2 servers that are dedicated for you. And this can be useful where you've got existing server-bound software licenses, or perhaps regulations saying that you cannot use multi-tenant virtualization. Do remember going into your exam that if a spot instance is terminated by EC2 because the price has changed, you're not going to be charged for that partial hour of usage. However, if you terminate the instance yourself, you are going to be charged for any hour in which the instance ran. We then looked at our different EC2 instance types, and we came up with the mnemonic Fight Dr. McPixie AU. So in Austin or in Australia, depending on what you want. So there's Dr. McPixie. She's clearly a pixie because she's got wings. She's clearly Scottish because she's wearing tartan. She wants to fight. You can see there's a stethoscope around her. So fight Dr. McPixie. And like I said earlier, you don't really need to understand every single EC2 instance type going into this exam. Where it does become more useful is if you go on to do the professional level exams. They will test you as to whether or not it's a valid instance type or not. Moving on to EBS, we learned that EBS is basically a virtual hard disk drive in the cloud.
Just remember that termination protection is turned off by default, so you must turn it on. So if you do want to go ahead and protect your EC2 instances from being accidentally deleted by your developers or system administrators, make sure that termination protection is turned on. On an EBS-backed instance, the default action is for the root EBS volume to be deleted when the instance is terminated. So if you do go in and terminate your EC2 instances, you are going to delete that root device volume automatically. But if you add a additional attached volumes to that EC2 instance, those additionally attached volumes won't be deleted automatically unless you go in and check that checkbox. Also remember that EBS root volumes of your default AMIs can be encrypted. You can also use third-party tools such as BitLocker for Windows, for example, to encrypt the root device volume. It can also be done when creating AMIs, so we will cover that off in a few more slides. Just remember the lab that we did on it. And you can also do it through the AWS console or using the API. And also remember that additional volumes can also be encrypted.
Moving on to security groups, all inbound traffic is always blocked by default. All outbound traffic is allowed. Changes to security groups take effect immediately. So as soon as you open up port 80, that takes effect immediately. And then you can also have any number of EC2 instances within a security group, and you can have multiple security groups attached to EC2 instances. And we did that when we went into the EFS lab. We attached our default security group as well as our web DMZ security group as well. Moving on to, again, staying on security groups. So security groups are stateful. That means that when you open up a port, so if you open up port 80, it's going to be open for both inbound and outbound traffic. Network ACLs are stateless. When you go and do a network ACL, you're going to have to open up port 80, both inbound and then also outbound. So we're going to cover that off in the VPC section of the course. If you create an inbound rule allowing traffic in, that traffic is automatically allowed back out again, and you cannot block specific IP addresses using security groups. Instead, you're going to be using network access control lists. And again, we will see that in the VPC section of the course. And you can always specify allow rules with security group, but not deny rules. Then we looked at EBS. These are the different EBS types. So we've got general purpose SSD or GP2. We've got provisioned IOPS SSD, which is IO1. So those are our two different flavors of SSD. And essentially, if you want your IOPS to go above 16,000, you want to move from general purpose over to provisioned IOPS. We then have hard disk drives. So we've got three different types. We've got throughput optimized hard disk drives or ST1. We've got cold hard disk drives or SC1. And then we've got EBS magnetic, and this is sometimes referred to just as standard as its API name, and that's typically is previous generation, so you might not see that in the exam. With the throughput optimize and cold hard disk drive, basically if you need to optimize throughput, choose throughput optimize. If you just want the lowest cost storage available, use cold hard disk drive. So staying on EBS, volumes exist on EBS, so just think of EBS as a virtual hard disk drive in the cloud. Snapshots exist on S3, and I want you to think of snapshots as a photograph of the disk, and snapshots are actually point-in-time copies of the volumes, and snapshots are incremental, so this means that only the blocks that have changed since your last snapshot are moved to S3. And if you take your snapshot for the first time, it may take some time to create. That's because it's doing its very first one, but then it will only replicate. If you take a second snapshot, it's only going to replicate the deltas, so it's only going to replicate the changes. To create a snapshot for Amazon's EBS volumes that serve as root device volumes, you should always try and stop the instance before taking the snapshot. That will give you a consistent snapshot, but that is optional. You can take snapshots on running instances as well. And you can create AMIs from both volumes and snapshots. And you can actually change EBS volume sizes on the fly, including changing the size and the storage type. And volumes will always be in the same availability zone as the EC2 instance. You cannot have an EC2 instance in one availability zone and then an EBS volume in another. Bear that in mind as well. In terms of migrating EBS, so to move an EC2 volume from one availability zone to another, you just take a snapshot of it. You then create an AMI from the snapshot, and then you use the AMI to launch that EC2 instance in a new availability zone. And likewise, if you want to move EC2 volumes from one region to another, take a snapshot of it, create an AMI from the snapshot, and then copy the AMI from one region to another. And then you use the copied AMI to launch the new EC2 EC2 instance in the new region. Encryption. Snapshots of encrypted volumes are encrypted automatically. Volumes restored from encrypted snapshots are encrypted automatically as well. And you can share snapshots, but only if they are unencrypted. And you can share snapshots with other AWS accounts, or you can actually make them public as well.
Moving on to unencrypted root device volumes. So root device volumes can now be encrypted when you provision your EC2 instance. You don't need to worry about it. But if you do have an unencrypted root device volume that needs to be encrypted, you need to do the following. So you go ahead and create a snap of the unencrypted root device volume. You then create a copy of the snapshot and then select the encrypt option. And then you create an AMI from the encrypted snapshot, and then you use that AMI to launch the encrypted instances. So just like we did in the lab earlier on.
EBS versus instant store. So instant store volumes are sometimes referred to as ephemeral storage. Instant store volumes cannot be stopped. If the underlying host or hypervisor fails, you're going to lose your data. And EBS-backed instances can be stopped, however, and you won't lose the data on this instance if it's stopped. And you can reboot both and not lose your data. And by default, both root volumes will be deleted on termination. However, with EBS volumes, you can actually tell AWS to keep the root device volume from being deleted. So you can basically stop it from automatically being deleted. In terms of encrypting root device volumes, how do we do it? Well, we created a snapshot of the unencrypted root device volume. We then created a copy of the snapshot, and when we did that, we selected the encrypt option. We then created an AMI from the encrypted snapshot, and then we used that AMI to launch the new encrypted instances. So that's how we basically encrypt our root device volumes using the AWS console. Don't forget, you can also do it using just software like BitLocker, etc., etc. Moving on to CloudWatch. Remember that CloudWatch is used for monitoring performance. CloudWatch can monitor most of AWS as well as your applications that run on AWS. CloudWatch with EC2 will monitor events every 5 minutes by default. However, you can have 1 minute intervals by turning on detailed monitoring. And you can create CloudWatch alarms, which then go ahead and trigger notifications. And CloudWatch is all about performance. CloudTrail is all about auditing. We're going to have another slide of that coming up. So what can you do with CloudWatch? Well, you can create dashboards, and this will allow you to see what's happening within your AWS environment all around the world. You can create alarms, and this allows you to set alarms that notify you when a particular threshold is hit, like 80% or 90% CPU utilization. We can monitor events. So CloudWatch events helps us to respond to state changes in our AWS resources. And you can also use logs, CloudWatch logs, to help you aggregate, monitor, and store your logging data. And like I said, CloudTrail versus CloudWatch. CloudWatch monitors performance. So think of someone at the gym. CloudTrail monitors API calls in the AWS platform. So CloudTrail will tell you who provisioned an EC2 instance or who set up an S3 bucket, etc., etc. We then learned about the command line, so you can interact with AWS from anywhere in the world using the CLI. You are going to need to set up access in IAM. This gives you an access key ID and secret access key. The commands themselves are not in the exams, but some basic commands will be useful to know for real life. We then looked at roles, because we looked at on our EC2 instance what happens if somebody goes into our secret directory, our .aws directory, which is in our home directory, and then opens up our configuration details. They'll be able to get our access key ID and secret access key. So roles are a much more secure way than storing your access key ID and secret access key on individual EC2 instances. Roles are much easier to manage, and roles can be assigned to an EC2 instance after it's been created using both the console and the command line. And roles are universal. You can use them in any region in the world. We then went on to Bootstrap scripts. Bootstrap scripts run when an EC2 instance first boots and can be a powerful way of automating software installs and updates. So we've used it a little bit in this course so far. We're going to use it a lot, certainly in the next section. We're going to create a Bootstrap script that installs WordPress, and we're going to use that to connect to our RDS instances. So Bootstrap scripts are incredibly useful as well. well. We then learnt about instance metadata and user data. So it's used to get information about an instance such as a public IP. And to do it, you just run a curl and then 169.254.169.254/latest/metadata. If you want to get your user data is literally your bootstrap script that is passed to your EC2 instance when it first boots up. And again, you just run a curl 169.254.169.254/latest/ and then user data. Moving on to EFS, that was the very last lab. So we learned that it supports the Network File System version 4 or NFS v4 protocol. You only pay for the storage that you use. You don't need to pre-provision, so you don't need to go in and spin up an 8 gig instance or something like that. It basically grows as you put more files on it and can scale all the way up to petabytes, and it can support thousands of concurrent NFS connections. And remember, if you need shared storage, you can't share EBS with multiple EC2 instances. It doesn't work like that, but you can create an NFS EFS mount, and then you can store your files in there, and multiple EC2 instances will be able to access it. And with EFS, data is stored across multiple availability zones within a region, and in terms of the consistency model, you get read after write consistency.
Moving on to EC2 placement groups. A placement group is simply how you place your EC2 instances. There's 3 different types of placement groups. The first one is a clustered placement group. We then have spread placement groups, followed by partition placement groups. A clustered placement group is where you want low network latency, high network throughput. This will be where all your EC2 instances are in the same availability zone and as close together as possible, so that you don't have any sort of latency. Spread placement group, these are for individual critical EC2 instances, so you want to make sure that they are, basically in different availability zones and on different pieces of hardware. So if a rack does fail, it's only going to affect the one EC2 instance. It's not going to take 2 or 3 out at a time. And partitioned placement groups are effectively for multiple EC2 instances. So this will be for things like HDFS, HBase, and Cassandra clusters. And this is where you have multiple EC2 instances into a partition, and each partition is always going to be on separate hardware or separate racks from the other partitions. So those are the 3 different types of placement groups. Just remember, the clustered placement group doesn't span multiple availability zones, whereas a spread placement and partitioned placement group can span availability zones. Remember that the name that you specify for a placement group must be unique within your own AWS account. Only certain types of instances can be launched into placement groups, so these will be things like compute optimized, GPU, memory optimized, storage optimized, etc. And then also remember that AWS recommend homogeneous instances within the clustered placement groups. So this is where you have the same instance type. You can't merge placement groups, and you can't move an existing instance into a placement group. What you can do, though, is create an AMI from your existing instance and then launch the new instance from the AMI into a placement group.
So that is it. You are at the end of the EC2 section of the course. I hope you had lots of fun. In the next section of the course, we're going to look at relational database services, or RDS. We're going to be using WordPress, which will be using a backend MySQL instance. And again, you're going to get a lot more hands-on fun with AWS. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this section of the course. In this section of the course, we're going to look at all the different databases available to us on AWS, and it does come up an awful lot in your exams. I think it's helpful just to start with what a database is. I'm sure you all know, but just in case you don't. And if we think of relational databases, let's start there. So relational databases are what most of us are all used to. They've been around since the 1970s. I want you to think of a traditional spreadsheet. So if you use Excel, Excel is saved in a file. It might be your cost.xls or something like that. So that's essentially the database itself. And then if you go into that file, you've got different worksheets, and those are different tables. And inside your tables, you've got rows and you've got columns or fields. So that's all a database is. And here's a good example of one. Let's say this is a student database. You want a list of all your students in a particular class. You've got your student ID off to the left, and this could be a unique number. And then we've got our first name, our surnames, and then what gender the students are. So that's all a relational database is. Very, very simple. And databases on AWS come in 6 different flavors. So we've got Microsoft SQL Server, we have Oracle, we have MySQL Server, we have PostgreSQL, we have Aurora, which is Amazon's own proprietary database, and we also have MariaDB. So these are the 6 different relational databases on AWS. Now the one that we'll be using in this course will be MySQL, and the reason for that is we're going to be using WordPress to do an installation, and we'll look at doing that in the very next lecture. So the main thing you need to understand about RDS, or Relational Database Services, is it has 2 key features. We've got multi-AZ, which is for disaster recovery, and then we've got read replicas, which is for performance. So multi-AZ, disaster recovery, read replicas, performance. And you will get all these different scenario questions, and it will be asking you if you should be turning on multi-AZ, or whether you should be using read replicas. And really, it's all about whether or not you just want to spread your databases across multiple availability zones, then you want multi-AZ. Whereas if you're trying to boost the database's performance, you're going to go for read replicas. And the way it works is we've got a diagram here. So we've got our EC2 instance up the top, and it connects into our databases using a connection string. And we'll have a look at those in the next lab. But essentially, it's using an address. It's a DNS address. So this is an example. So we've got my example DB, and then this is the address, uswest2.rds.amazon.com. So it's connecting to that. Amazon hosts this DNS record, and they point it at a database, a primary database. They point it at its internal IP address. Now, if for some reason we lost our primary, Amazon would detect that, and they'd automatically update the DNS to point to the secondary. So you don't need to go in and change IP addresses or anything like that on the fly. All you're doing is pointing it to this DNS address, and Amazon will go in and update that DNS address with the new IP address. So failover is automatic with multi-AZ. Now with read replicas, it's slightly different. We've got our EC2 instances, and they're pointing off to our primary instance using this connection string. And what happens is that every time you do a write to that database, that write is going to be replicated to another database. It's a perfect copy of the other database, but it's a replica. Now, if you were to lose your primary database for whatever reason, there's no automatic failover from one to the other. What you would have to do is you'd have to go in and essentially create a new URL. And then you'd have to update your EC2 instances to point to the read replica. So where it is useful, however, is if you've got these EC2 instances, let's say you're running a very popular WordPress blog, and most of WordPress is read because people are reading your blog, right? And let's say that your primary database is getting way too many reads because you're getting, let's say a blog goes viral and you start getting 1 million requests per hour. The way you can scale your database is to have a perfect copy of it, a read replica, and you can point half of your EC2 instances to read from the read replica, and then the other half to read from the primary database, and you can scale out that way. So that's what read replicas are, and you can actually have 5 copies of read replicas. Now we are going to cover this in a lot more detail in some lectures and labs coming up, so we'll move on from there. Non-relational databases is probably something you may or may not be familiar with. I certainly wasn't familiar with it until around 2008, 2009. But they basically consist of a collection, and a collection is just a table. And inside the collection, you have documents, and your documents is simply a row. And then you have key value pairs, and these are basically your fields or columns. So let's have a look at what a non-relational database would look like. So something like this. This is just JavaScript object notation language. So in here, we've got our ID as a key value pair, our first name, our surname, our age. Then we've got our address, and we can actually nest key value pairs inside this address. And what's really cool about this is I could go in and say this is record 1. I could go in and then add a new field in here. I could actually go in and add, let's say, gender, for example. So do something like this. So we go from one record which doesn't have someone's gender and the other record which does. Now, if I was to do this in a relational database, let's have a look at my relational database here. If I was to add a new field, the problem problem I have is that new field is added across all my records. So I've added a new column in, and suddenly I'm missing data for Ryan, I'm missing data for John, I'm missing data for Danielle, but I've got data for Julia. So that's the difference between non-relational and relational databases. You can have as many different columns as you want for any given row within a non-relational database. But for relational databases, you basically have to keep some kind of consistency across all the records. Moving on to data warehousing. So what is data warehousing? Well, basically it's used for business intelligence. So tools like Cognos, Jaspersoft, SQL Server reporting services, Oracle Hyperion, SAP NetWeaver, etc., etc. And it's used to pull in very large and complex data sets, and usually used by management to do queries on data such as current performance versus targets, etc. So before we look at Amazon's solution to data warehousing, I just want to compare online transaction processing versus online analytics processing. So online transaction processing differs from online analytics processing in terms of the types of queries that you run. So let's look at an online transaction processing example, or OLTP example. So say I want to find a specific order. Say it's 2120121. So I basically run a query saying, hey, select order number 2120121. And this is going to pull up a row of data. And this might have things like my name, my date, my address to deliver to, the delivery status, etc. Online analytics processing is going to be much more complicated. So say I'm a manager and I want to understand the net profit for EMEA, so Europe, Middle East, and Africa, and Pacific for the digital radio product. And so this is going to pull in a huge number of records. It's going to do a huge number of queries. So it's basically going to add up the sum of all radios sold in EMEA. It's going to add up all the sums of radios sold in the Pacific. It's going to figure out the unit cost of the radio in each region. And then it's going to take the sales price of each radio. And then it's also going to need to figure out the difference between the sales price and the unit cost. And essentially, it's going to run a whole bunch of queries onto my database. And you really want to start splitting out your, a database that you're going to be using for just normal transactions for your website. And you want a different database for ones that you're going to run queries on, where it's, online analytics processing, where you're running all these very complicated queries. So data warehousing databases use different types of architecture, both from a database perspective and from an infrastructure layer. And so Amazon have a specific product for this called Redshift. So Redshift is Amazon's data warehousing solution. It's Amazon's answer to doing online analytics processing. Moving on to Elasticache. Elasticache is a web service that makes it easy to deploy, operate, and scale an in-memory caching service in the cloud. And this basically improves the performance of your web applications by allowing you to retrieve information from fast managed in-memory caches instead of relying entirely on slower disk-based databases. So what does that mean? Well, again, we're going to do a deep dive lecture on this, but essentially imagine you own Amazon.com. Wouldn't we all like to own Amazon.com? When people visit Amazon.com, they might have a particular store or the most top 10 purchased items. Now, of course, if 1,000 people are visiting that every minute, the top 10 is not really going to change all that much. And there's no point pulling that information from a database, right? Because the top 10 doesn't change all that frequently, yet you're always, when somebody's visiting the website, they're always making that query to the database. Hey, what are the top 10 products that are being sold? So what you can do is you can cache that, and that's what Elasticache does. It's a way of caching your most common web queries. So when your web servers are getting a request, they'll go to Elasticache first and get that information from Elasticache, and it takes a huge load off of your databases. And you're going to get a whole bunch of scenario questions in your Solutions Architect Associate exam where your database is overloaded, and it's going to ask you what is an option to help with this. And of course, using Elasticache is one option. You could also use read replicas. And again, we're going to cover this in more detail in this section of the course. Elasticache consists of two different engines. So we've got Memcached, and then we've got Redis. And we will learn about the differences later on in this course. So what are my exam tips? Just remember that RDS consists of online transaction processing, comes in 6 different flavors, so SQL Server, MySQL, PostgreSQL, Oracle, Aurora, and MariaDB. DynamoDB is Amazon's NoSQL solution. Redshift is Amazon's data warehousing solution. This is done for online analytics processing. You then got Elasticache, which comes in two different flavors, so Memcached and Redis, and this is Amazon's caching solution. And just remember that Redshift is used for business intelligence or for data warehousing, and Elasticache is used to speed up the performance of existing databases. So it's a way of caching frequently identical queries. So as always, the best way to learn something about AWS is to go in and get our hands dirty. So in the next lecture, we're going to go in and create our very first RDS database, and we're going to install WordPress to it. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. So in this lecture, we're going to create our very first RDS instance. So this is a lab, and you will need to log into the AWS console. Okay, so here I am in the AWS console, and of course, you're going to find RDS under databases. So in here. So let's go ahead and click on that. And then what we're going to do is we're going to go in and provision our very first RDS instance.
Okay, so here I am in the AWS console. I'm going to go over to RDS, which is under databases. You can note all the different databases in here. The ones that are going to feature in the Certified Solutions Architect Associate exam are mostly RDS, DynamoDB, Elasticache, and Redshift. That's pretty much it for now. Who knows when they're going to update the exams. Let's go over to RDS, and what we're going to do is we're going to go in and provision a database, and we're going to call the database a Cloud Guru. If you haven't gone in before, you're just going to get this splash screen, so go ahead and hit Create Database. The UI has now changed, so I'm just going to close this up here. And what we're going to do is we're going to select our engine option type. So you'll notice that Aurora is by default the preferred database for RDS. Amazon are always going to push out their own product, and to be fair to Amazon, Aurora is an absolutely amazing product. But for the purposes of this lab, we're going to go ahead and do MySQL, and we're going to scroll down, and you can see you can change your different versions in here. I'm going to leave it at 5.7.22. You can do whatever version you like. In here, we've got our different templates. So production templates. Essentially, this is going to give you high availability and fast, consistent performance. So this will give you multi-AZ. It'll also give you a high-performing disk. And we don't really want this. We're probably just going to go ahead and start off with free tier. In here, we've got our DB instance identifier. So this will be the name of our instance of our RDS instance. It's not our database name per se. It's the name of the RDS instance. I'm just going to call it a Cloud Guru, and I'm going to copy that into my clipboard. In here, we set up our credentials. So we've got our master username. I'm going to do it a Cloud Guru, master password a Cloud Guru, and then we confirm our password in here. Now, because we did do the free tier, all of this is grayed out, and we're just going to do a DB T2 micro. So it's 1 vCPU and 1 gig of RAM, and it's not EBS optimized. In here, we're just going to do a normal 20 gigs of storage. We do have the ability to do storage auto scaling, so this means that you can, add storage on the fly as you run out of space. And in here, you can specify the maximum storage threshold. Just going to leave it all as default. We're not going to do multi-AZ yet. We're going to do that in another lab. In connectivity, we've got our default VPC. You can click in here for additional connectivity configurations. So do you want this to be publicly accessible? I'm going to say no. In here, we've got our VPC security groups. I'm just going to leave it as the default VPC security group. You could go in and create a new one. I am actually going to do that, so I'm going to call it RDS and then launch and then wizard, and we'll look at how we can configure that later. You can select a preferred availability zone, so across the 6 different availability zones in US East 1, I'm just going to say no preference. And you can even change the database port, but I'm going to leave it on the MySQL port of 3306. In here, we've got our additional configuration options. Now, if you do not specify an initial database name, Amazon RDS does not create the database for you, so you'd need to go in and use something like PHP-MyAdmin or some way of provisioning or using SQL queries to create a database. You definitely want a database to begin with, so let's type in a Cloud Guru into there. And then in here, we've got enable automatic backups. I'm actually going to drop this down to 0 days, and we'll see why, because we don't really want automated backups turned on. Interestingly, if you uncheck this box, but you leave that as like 7 days, it does turn it on automatically. It's a bit weird. So I'm just going to change this to 0 days, and the backup window you can just do as no preference. And then I'm going to scroll all the way down. Here you've got termination protection, so you can basically stop people from going in and deleting it accidentally. And you can even select your maintenance window, so you could say, hey, I just want to do my maintenance at 1 a.m. Every day for half an hour. Sorry, 1 a.m. on Sunday for half an hour. So you can specify when your business finds it acceptable to have some downtime. In here, you're going to see your estimated monthly costs. So let's go ahead and hit Create Database. Now, databases can take a little bit of time to provision. They are a bit slower than using RDS. Than using EC2. EC2 can come up in a couple of minutes, whereas RDS instances tend to take about 5 minutes or 10 minutes to come live. While we're waiting for that to happen, let's go over to EC2. And we're going to go in and provision an EC2 instance. If you still have any instances left over from the last section of the course, feel free to go in and delete them. I'm going to use an Amazon Linux AMI. I'm going to use a T2 Micro. I'm just going to leave everything as standard. However, the one thing I am going to do is going to go down to my advanced details, and I'm going to pass it a bootstrap script. And this bootstrap script is available in the resources section of the course. All it's doing is it's installing PHP, PHP MySQL, as well as Apache. It's then going over to the var www.html directory. It's downloading the latest copy of WordPress, and it's unzipping it. It's then essentially going through and installing WordPress and changing the permissions on the directory so we can write to that directory. So I'm just going to copy this into my clipboard, and in here I'm just going to paste it in here. Next, I'm going to add my storage. 8 gigs is fine. Tags. Let's add a tag, and we'll just call it name. This is WordPress server, something like that. Next, I'm going to go and configure my security groups. I'm going to use my WebDMZ security group. I'm going to hit review and launch. And then I'm going to go ahead and launch it. And I've just got to acknowledge that I have access to the key pair. Now, if you had eagle eyes, you would have seen in our security groups that we actually had a couple of different security groups. We had this RDS launch wizard. So it's launched using RDS. It's launched our RDS instance into this security group. Now, our web server is in this security group, and the problem is our web servers will need to talk to our RDS instances using the MySQL port. So in order to do that, we need to allow RDS, our security group here, to be open to our WebDMZ security group. And to do that, all we need to do is go in here, and we need to go to Edit, and we can go in and add a rule, and we can do it on MySQL. So if we go down to MySQL, so down here, so it's going to open up port 3306, and in here I can actually just type my security group. So I can type in security group, and it's going to hopefully be the top one. I'm getting a frustrating UI issue where it's just hiding behind. So let me just do this. So security group 06, and there we go. So I'm going to go ahead and hit save. And so that now allows MySQL in from this security group. So it's allowing our web servers to talk to our RDS instance over the MySQL port. So that is now done. If we go back over to EC2, we should hopefully be able to see that instance is now up and running. Let's go back over to RDS and see if it's up online yet. So if I just click on my DB instances, I'll be able to see it in here, and we can see that the status is creating. So I'm just going to pause the video and wait for this RDS instance to come up online. Okay, so that is now available, and if we click in here and click on the name of the database, you'll be able to see all the different connectivity information, as well as monitoring, logs and events, configuration, maintenance and backups, and tags. Monitoring is obviously going to be tied into CloudWatch, so you'll be able to see some CloudWatch metrics in here. We go over to connectivity. This endpoint is our DNS endpoint to connect to our RDS instance, and this is what we're going to need in order to install WordPress. So let's go over to our EC2 instance, which should now be happily up online. And then what I'm going to do is I'm going to go to grab the public IP address and navigate it to it in my browser. So I'm just going to paste my IP address in here and hit enter, and straight away I can see the WordPress screen, and it is basically asking me for a bunch of information. So it wants to know my database name, my username, my password, the host, and then table prefix. So let's go ahead and hit let's go.
My database name was A Cloud Guru, so everything was the same, so A Cloud Guru. So I'm just going to paste this into the different fields. So A Cloud Guru and then A Cloud Guru. Now the database host, this is saying local host, so it's expecting it's expecting MySQL to be installed on our EC2 instance. Now of course it isn't, it's installed on an RDS instance. So what we need to do is put in our RDS connection address in here. So all we need to do is go back over to EC2, go over to RDS and grab our database endpoint, and we just need to paste it in there. So if we click on databases and click on our database in here, I'll be able to grab the endpoint. So we're just grabbing this URL here. So copy that into your clipboard and then paste it into here over localhost and go ahead and hit submit. Now, right now it's saying it can't write the wp-config file. So all we need to do is copy this again into our clipboard, and let's go over to SSH. Let's SSH into our EC2 instance and just write this to the file. So here I am in my terminal window. I'm just going to go over to my EC2 instance, and then I'm going to elevate my privileges to root, so sudo su, and then I'm going to clear the screen. We're just going to go to our cd var www html directory, and in here what we want to do is type nano, and then it's wp-config.php, and then all we want to do is paste it in here. If you get this thing, just hit paste, and then that will paste in our wp-config. Then hit Control X and then hit yes and then hit enter. Now go back over to your browser. So I'm back in my browser and I'm going to hit run the installation. And we'll know that this has worked if you see this page. So let's call our site Hello Cloud Gurus. And my username I'm going to use is A Cloud Guru. My password I'm going to use is A Cloud Guru, which is a terribly weak password. And then in here, just enter an email address if you want, and then go ahead and hit install. Make sure you check this box as well, otherwise you won't be able to install anything if you do use a very weak password. So I'm going to go ahead and hit install WordPress, and it's asking me for an email address. I'm going to enter that in, and then I'm going to go ahead and hit install. And there we go. It says it's been successfully installed. So we've been able to write to our MySQL database. So our WordPress installation has basically gone in and installed the software onto our EC2 instance, and it's now able to write data to our RDS instance. So we will come back and start playing with that EC2 instance. We're going to add read replicas. I'm going to make it multi-AZ. But just remember going into your exam the following point when it comes to RDS. So RDS runs on virtual machines. It runs on virtual machines, but you don't have any access to those virtual machines. So you can't SSH into your RDS instance. And that's really, really important to remember because it comes up in terms of security questions and also patching and maintenance. You can't go in and patch the operating system of your RDS instance. That's not your responsibility. That's Amazon's responsibility. You can do it for EC2, and that is your responsibility, but Amazon's responsible for the patching of both the databases as well as the operating systems that run on them. So patching of the RDS operating system and database is Amazon's responsibility. RDS is not serverless, and you will be tested on this later on in the exam. They will ask you whether or not it's a serverless technology. Now, before everyone jumps up and down and screams at me saying the Aurora has, there's serverless Aurora, yes, that's the exception to the rule. But overall, RDS is not serverless. It does run on virtual machines, and even though you can't access them, Amazon can. So RDS is not serverless with the exception of Aurora, and we'll cover that off in the Aurora lecture. And so Aurora serverless is serverless, but everything else inside RDS is not serverless. So that is it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to look at backups, multi-AZ, and read replicas with RDS. So this is going to be a theoretical lecture, and the next lecture we're going to go into a lab, and we're going to look at how we can set up multi-AZ, read replicas, and backups. So let's start with backups, and there's two different types of backups for RDS. We have our automated backups, and then we have our database snapshots. And our automated backups allow you to recover your database to any point in time within a retention retention period, and the retention period can be between 1 and 35 days. Now, automated backups will take a full daily snapshot and will also store transaction logs throughout the day. And when you do a recovery, AWS will first choose the most recent daily backup and then apply the transaction logs relevant to that day. And so what this allows you to do is a point-in-time recovery down to a second within the retention period. So automated backups are enabled by default, and the backup data is stored in S3, and you get free storage space equal to the size of your database. So if you have an RDS instance of 10 gigs, you're going to get 10 gigs worth of storage. And backups are taken within a defined window. So during the backup window, storage I/O may be suspended while your data is being backed up, and you may experience a little bit of elevated latency. Database snapshots are done manually. So think of someone taking a photo on a beach using a Polaroid camera, for example. So they are user initiated, and they are stored even after you delete the original RDS instance, unlike automated backups. And when you go in to delete your RDS instance, often it will ask you if you want to take a final snapshot of that instance before you delete it. In terms of restoring your backups, whenever you restore either an automatic backup or a manual snapshot, the restored version of the database is going to be a new RDS instance with a new DNS endpoint. So bear that in mind as well. As soon as you do a restore, it's not going to restore to the same RDS instance. It's going to actually restore to a brand new RDS instance, and that's going to have a different endpoint. Moving on to encryption. So encryption at rest is supported for MySQL, Oracle, SQL Server, PostgreSQL, MariaDB, and Aurora. And encryption is done using the AWS KMS service. And once your RDS instance is encrypted, the data stored at rest in the underlying storage is encrypted, as are automated backups, read replicas, and snapshots. So as soon as you've turned encryption on, basically anything that you're doing, such as backups, read replicas, and snapshots, are also going to be encrypted as well. So moving on to multi-AZ, and we covered this in Databases 101, but just in case you forgot, let's say we've got an elastic load balancer and we've got our EC2 instances behind it. They then connect into our RDS database, and this is in US East 1A. It then synchronously replicates all changes or all updates to that database to US East 1B. So you've got two copies of your database. Now, if you were to lose US East 1A as an availability zone, what's going to happen is Amazon are going to update the DNS settings, and the RDS endpoint is automatically going to fail over to the RDS instance in US East 1B. So multi-AZ allows you to have an exact copy of your production database in another availability zone, and it's done synchronously through synchronous replication. And AWS handles the replication for you. So when your production database is written to, this write will automatically be synchronized to the standby database. And so in the event of a planned database maintenance or DB instance failure or an availability zone failure, Amazon RDS will automatically fail over to the standby so that the database operations can resume quickly without any administrative intervention. So you don't need to go in and change your connection strings or anything like that. You're still using the same DNS endpoint. Amazon's basically just updating the IP address to point from one RDS instance to another. They do all that. You don't have to worry about it, and it will fail over automatically to another availability zone. So just remember that multi-AZ is for disaster recovery only. It's not primarily used for providing or improving performance. For performance improvements, you're going to need read replicas. Now, multi-AZ is available for the following databases. It's available for SQL Server, Oracle, MySQL Server, PostgreSQL, and MariaDB. Aurora, by its own architecture, is completely fault tolerant. We're going to have a whole dedicated lecture to Aurora and how that works coming up. So what's a read replica? Here we have our EC2 instances behind an elastic load balancer. They are then connecting in to our production database. Our production database is then asynchronously replicating out to multiple copies in this example. Now, how this can really improve performance is, in this current example, basically all our EC2 instances are reading from the primary database as well as doing writes. But you can actually architect it so that your EC2 instances read from different read replicas, and then they only write to a single database. And of course, those writes will then be replicated out. And you can even have read replicas of read replicas. So you can have multiple copies of your production database as read replicas, and you can have read replicas as read replicas. The cool thing about it as well is you can promote read replicas to be their own standalone database. So you can also do that as well. So read replica allows you to have a read-only copy of your production database, and this is achieved using asynchronous replication from the primary RDS instance to the read replica. And you can use read replicas primarily for very read-heavy database workloads. And where you're going to see this come up in the exam is it will talk about how you can improve performance for a database. And there's two ways really you can do that. Is you can go in and add read replicas, and you can also go in and start using Elasticache. And we're going to have an Elasticache lecture coming up as well. But that's where you're going to see read replicas come up in your exams. And read replicas are available for the following databases. So we have MySQL, we have PostgreSQL, we have MariaDB, Oracle, and Aurora. And the things to know about read replicas is they're used for scaling. They're not used for DR. And they must have automatic backups turned on in order to deploy a read replica. And we'll see that in the lab coming up. And you can have 5 copies or 5 and you can have up to 5 read replica copies of any database, and you can have read replicas of read replicas. But when you do that, you do have to start watching out for replication latency. Other things to know about read replicas is each read replica will have its own DNS endpoint, and you can now have read replicas that also have multi-AZ turned on, and you can create read replicas of multi-AZ source databases as well. And read replicas can be promoted to their own databases, and this breaks the replication. So if you do promote a read replica to be its own independent database, the replication will no longer work. And you can also have a read replica in a second region. So you can have a read replica in a completely separate region to where your primary database is. So bear that in mind as well. So as always, the best way to learn about RDS is to go ahead and get our hands dirty. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to look at backups, multi-AZ, and read replicas, and we're going to do this in a lab environment, so you will need to look into the AWS console. Okay, so here I am in the AWS console, and of course we can find RDS under databases, and I click in here and we have our database that we provisioned earlier on, and I've called it A Cloud Guru. And if you click on the name of the database, you'll be able to see things like connectivity, monitoring, logs and events, configuration, maintenance and backups, tags, etc., etc. And what we can do is we can do 2 things. We can go in and modify the database, or we can take some actions. So we could stop this database, reboot it, we could delete the RDS instance, we could go ahead and create Aurora read replicas, and this is actually a good way of migrating your MySQL databases over to Aurora. You can actually just create a read replica of your MySQL database. We can go in and take a snapshot, and then we can migrate snapshots. So if we click on take a snapshot, that will take a snapshot, and it will create if we were then to restore from that snapshot, it is going to create an entire new RDS instance. So if I just click up onto modify, what we're going to do first of all is we're going to turn on multi-AZ. So let's go ahead and hit yes. And this will basically go ahead and give us multi-availability zones for this database. So that's the only change I'm going to go in and make. And I'm going to go ahead and hit continue. And it says you may experience significant performance impact when converting this database instance to multi-AZ configuration. This impact will be more noticeable on database instances with large amounts of storage and write-intensive workloads. So you may want to do this if you are going to do this on a production database. You would hope that your production databases are already multi-AZ, but if you are going to do this, you might want to do it basically in a scheduled maintenance window. So you could say apply during the next scheduled maintenance window, or you obviously want to do it after hours. I'm going to apply this immediately. It does give me a warning that there's going to be some potential downtime, but let's go ahead and hit modify. And that's going through and modifying my database. And if we click on databases in here, we'll be able to see the status currently says available. But if I hit refresh, you can see it's now changed to modifying. So I'm just going to pause the video and wait for this to become a multi-AZ database. Okay, so my RDS instance is now available. If I go ahead and click on it, I'll be able to see in here, if we go to configuration, If we scroll down, you can see that multi-AZ has now changed to yes. So this is a multi-AZ database. And what we can actually do is if we go into actions and do a reboot, we can actually reboot with failover, and this is a way of forcing our availability zones to change. So you can change from one availability zone to another by just rebooting and rebooting with failure. I'm not going to do that. What I am going to do is I'm going to go back to this database. I'm going to go ahead and modify it again. And what I'm going to try and do is turn on read replicas. Now, read replicas won't actually work. And the reason for that is because I do not have my backups turned on just yet. And you need to have your backups turned on in order to do a read replica. And you won't actually find an option to turn read replicas on in here. What you actually need to do is go back to your databases page. And then in here, if you click on actions, you can see here, create read replica. But right now we can't do that. And the only reason for that is because we do not have backups turned on. So let's go ahead and turn on backups. So I'm just going to click in here, go ahead to modify. We're going to turn on our backups by going all the way down to the bottom. I'm going to do my retention period. Your retention period can be up to 35 days. So I'm going to turn mine on for 35 days. And then I'm going to go ahead and hit continue. And then that's going to modify this database and I'm going to apply it immediately. This can cause some downtime, so it is going to give you a warning. And we can now see that that is now changing my database. And if I click in databases and I refresh the status, it is now modifying. So again, I'm going to pause the video and wait for my backups to be turned on. And then we're going to go ahead and create a read replica. Okay, so that was a lot quicker than creating a multi-AZ. It was only offline for a couple of minutes. And if I click on actions now, I can now select create read replicas. If yours is still grayed out, just do a hard refresh of the screen. So Command R or Control F5, and then you should be able to see the create read replica. So I'm going to go ahead and create a read replica. Note that you can change the destination region, so I could have my read replica anywhere in the world. And what I might do, I think I'll just keep it in this region just to make it simple. Do we want our read replicas to be publicly accessible? I'm going to say no. Do you want your read replica to be encrypted? Do you want to enable encryption on it? I'm just going to leave it as a no. Do you want your read replica to have multi-AZ deployment? I don't really care about that. I'm just basically going to leave everything as the default options, and I'm going to go ahead and hit create read replica. You will have to give it a name, so a DB instance identifier. I'm going to call it a Cloud Guru read replica, so I know that it's a read replica. And then I'm going to go ahead and hit create. So that is now creating my read replica. It's modifying this and then creating a new database instance down here, which will have its own DNS endpoint. And notice the role here. You can see that we've got our master and then we've got our replica. So I'm going to pause the video and just wait for that to come back up online. Okay, so my read replica is now available. I can see it in here. And if we click on it and go ahead to our actions, we can actually see that we can now promote our read replica. So we can make this our primary, another primary database, and then we could add read replicas to it as well. So feel free to go ahead and delete that read replica. We're not going to be using it later on, and you need to just type in delete me in order to do that. So I'm going to go ahead and delete that. Please keep your RDS instance, however, because we are going to turn that into an Aurora instance. We're going to look at how we can migrate from MySQL to Aurora. That is a popular exam scenario. So we're going to do that later on in this section of the course. But first, let's go ahead and have a look at my exam tips. So just remember, going into your exam, there's two different types of backups for RDS. So we have our automated backups, and they're going to be done in a scheduled maintenance window. And then we also have our database snapshots, and they're taken manually. And we saw how to do that earlier on in this lab.
Moving on to read replicas, these can be multiple availability zones, and they're used to increase performance. In order to have a read replica, you must have backups turned on. Read replicas can be in the same region or in different regions, and they can be MySQL, PostgreSQL, MariaDB, Oracle, and Aurora. The only one you can't have a read replica for currently is SQL Server. And they can be promoted to masters. And when you do this, it's going to break the read replications. So please do bear that in mind as well.
With multiple availability zone RDS instances, just remember that this is primarily, well, it's only used for disaster recovery. And you can force a failover from one availability zone to another by rebooting the RDS instance. And then then finally, just remember that encryption is supported for MySQL, Oracle, SQL Server, PostgreSQL, MariaDB, and Aurora. So it's encrypted for all 6 of the engines. Encryption is done using the AWS KMS service, and once your RDS instance is encrypted, the data stored at rest in the underlying storage is encrypted, as are automated backups, read replicas, and snapshots. So we've learned an awful lot about relational databases. In the next lecture, we're going to look at DynamoDB, which is Amazon's non-relational database. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. This lecture is on DynamoDB. So DynamoDB is Amazon's NoSQL database solution. So it's the opposite of RDS. So what is DynamoDB? Well, it's a fast and flexible NoSQL database service for all applications that need consistent single-digit millisecond latency at any scale. It's a fully managed database service, and it supports both document and key value data models. Its flexible data model and reliable performance make it a great fit for mobile, web, gaming, ad tech, IoT, and many other applications. So definitely a lot of mobile developers do use DynamoDB. In this section of the course, we're not going to go in and create a DynamoDB table, but we are going to do it in the serverless section. We're basically going to use our DynamoDB table to store some notes that we want to convert into MP3 files. So please do take notes throughout this course. Put them in just plain text, and what we will do is we're going to convert those to an MP3 file using the Poly service, and we're even going to build an Alexa skill to read out our notes to us. We're going to do that in the serverless section of the course. So the basics of DynamoDB are as follows. It's stored on SSD storage, so that's why it is so fast. It's spread across 3 different geographically distinct data centers, so you're going to always have redundancy. And that's got 2 different types of read models. So we've got eventually consistent reads, which is what you're going to get by default. And then we also have strongly consistent reads. So what's the difference between eventual consistent reads and strongly consistent reads? Well, it comes down to the 1 second rule. So with eventually consistent reads, consistency across all copies of your data is usually reached within 1 second. Repeating a read after a short time should return the updated data. So if you've got an application and it's writing to a DynamoDB table, and then you want to read that data that's been written to that table, a couple of seconds later, then that's fine. You want eventually consistent reads, and this will give you the best read performance, and this is enabled by default. However, if you have an application that writes to a DynamoDB table and it needs to read that data within or less than 1 second, then you want strongly consistent reads. And this will basically return a result that reflects all writes that received a successful response prior to the read. So again, the 1 second rule. So long as your application is happy that it doesn't need to read the data that's been written within 1 second, then you want eventually consistent reads. However, if you've got an application that needs to, as soon as an update's been done to a DynamoDB table, and that application needs to read that update in 1 second or less, then you're going to want strongly consistent reads. So just remember the 1 second rule for DynamoDB. So really, that's all you need to know for DynamoDB in the Certified Solutions Architect Associate exam. Like I said, we are going to cover it off in the serverless section of the course, where we'll go in and provision it in a lab. But before we learn about DynamoDB, we really need to understand a whole bunch of different other serverless services. So we're going to go through things like Lambda, etc. And then what we're going to do is we're going to build out a lab that does use DynamoDB. So going into your exam, just remember it's stored on SSD storage. It's spread across 3 geographically distinct data centers. You probably want eventually consistent reads. You get this by default, so long as your application writes to the table and then your application won't read that data within the first second, then you want eventually consistent reads. If it is going to read that data within 1 second of it being written to the table, then you want strongly consistent reads. So that is it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to look at Redshift. So what is Redshift? Well, you probably remember from the Databases 101 section that Redshift is a way of doing business intelligence or data warehousing in the cloud. So Amazon Redshift is a fast and powerful, fully managed petabyte scale data warehouse service in the cloud. And customers can start small for just 25 cents per hour with no commitments or upfront upfront costs, and you can scale up to petabytes or more for $1,000 per terabyte per year, less than 1/10 the cost of most other data warehousing solutions. So if you need a data warehouse, Redshift is the one to use, and certainly in terms of the AWS world. So we learnt in the Databases 101 the difference between online transaction processing versus online analytics processing. And online transaction processing is if you take a store, you could go in and look up a particular order, and you'd look it up using an order number. It's a single row of data. Whereas online analytics processing is where you're running queries against your database. And it might be that you want the net profit for EMEA and for the Pacific for a digital radio product. And this is going to pull in a huge number of records. It's going to add up the sum of all radios sold in EMEA, so Europe, Middle East, and Africa. It's going to add up the sum of radios sold in the Pacific. It's going to grab the unit cost of the radios in each region. It's going to take the sales price of each radio in each region, and then it's going to calculate the sales price minus the unit cost. And you can imagine the sort of queries that it's going to be running to do this. It's going to pull in data from a lot of different areas, and it can put a big stress on your database. And that's why it makes sense to move your production database and to have a separate data warehouse where you're running these queries on. So data warehousing databases actually use a different architecture, both from a database perspective as well as an infrastructure layer. And Amazon's data warehouse solution is called Redshift. So Redshift can be configured as follows. You can have a single node, and this is 160 gigs in size, or you can have multi-node. And a multi-node will consist of a leader node, and this basically manages the client connections and receives queries. And then you have all your compute nodes, and these store data and they perform queries and computations. And you can have up to 128 different compute nodes behind a leader node. So Redshift uses really advanced compression, and instead of going in and compressing individual rows inside a table, what it actually does is it compresses individual columns. And because the columns contain the same data, so one column might be a date, for example, or another column might be text, or it might be an integer, or it might be a Boolean value, or whatever. When you use compression based on columns, you get a lot more, it's a lot easier to compress because all the data is the same. So Amazon Redshift employs multiple compression techniques and can often achieve a significant compression relative to traditional relational database stores. So in addition, Redshift doesn't require indexes or materialized views, and so it uses less space than traditional relational database systems. And when you're loading data into an empty table, Amazon Redshift automatically samples your data and selects the most appropriate compression scheme. Redshift also comes with massive parallel processing, so it automatically distributes data and query loads across all your nodes. And Redshift makes it easy to add nodes to your data warehouse and enable you to maintain fast query performance as your data warehouse grows. So you can actually scale out with Redshift by adding more and more nodes behind your leader node. In terms of backups, Redshift comes with backups enabled by default, and they'll have a 1-day retention period. Again, just like with RDS, your maximum retention period is 35 days, and Redshift will always attempt to maintain at least 3 copies of your data. So this is the original data and a replica on the compute nodes, as well as a backup in S3. And Redshift can also asynchronously replicate your snapshots to S3 in another region for disaster recovery. Redshift, the way it's priced, is basically on the compute node hours. So this is the total number of hours you run across all your compute nodes for the billing period, and you're going to be billed for 1 unit per node per hour. So a 3-node data warehouse cluster running persistently for an entire month would incur 2,160 instance hours. And you're not going to be charged for leader node hours, you're only going to be charged for your compute node hours. So bear that in mind as well. And then you're also going to be charged for your backups, and you're going to be charged for your data transfer. And this is only within a VPC, not outside alongside it. In terms of security considerations, when you're communicating with Redshift, it's always going to be encrypted in transit using SSL. It's also encrypted at rest using AES 256 encryption. And by default, Redshift takes care of the key management. So you don't have to worry about managing keys with Redshift, but you can manage your own keys through a hardware security module, also using the AWS Key Management Service. And we do cover off Cloud HSM as well as AWS KMS in an awful lot of detail in the Certified Security Specialty course. In terms of availability, Redshift is currently only available in one availability zone, so you cannot have Redshift with multi-AZ turned on just yet. Who knows if that will change. You can restore snapshots to a new availability zone in the event of an outage. And then just on to my exam tips, just remember that Redshift is used for business intelligence. It's only available in one AZ. And in terms of backups, it's enabled by default with a 1-day retention period, and your maximum retention period is 35 days. And then Redshift will always attempt to maintain at least 3 copies of your data, the original and the replica on the compute nodes, as well as a backup in Amazon S3. And Redshift can also asynchronously replicate your snapshots to S3 in another region for disaster recovery. So that is it for this lecture, guys. If you have any questions, please let me know. If not, feel free to move on to the next lecture where we're going to cover off Amazon's Aurora. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to look at Amazon's Aurora. So what is Aurora? Well, basically, it's a MySQL compatible relational database engine that combines the speed and availability of high-end commercial databases with the simplicity and cost effectiveness of open source databases. And Amazon Aurora provides up to 5 times better performance than a MySQL database at a price point 1/10 of that of a commercial database, while delivering similar performance and availability. So Amazon actually built Aurora from scratch themselves. It's completely compatible with MySQL as well as PostgreSQL, and it is pretty impressive technology. So the things to know about Aurora is you can start with a 10 gig instance, and it scales in 10 gig increments all the way up to 64 terabytes in size. And your compute resources can also be scaled up to 32 vCPUs as well as 244 gigs of memory. Now, the really cool thing about Aurora is that it always maintains 2 copies of your data in each availability zone with a minimum of 3 availability zones. So you're always going to have 6 copies of your data spread across 3 availability zones. So Aurora is only going to be available in regions that have 3 availability zones. So do bear that in mind. It's not available in every region just yet. And in terms of scaling Aurora, it's designed to transparently handle the loss of up to 2 copies of your data without affecting the database write availability, and up to 3 copies without affecting read availability. So it is extremely highly available. And at the time of recording, I've not yet heard of an Aurora database going down, certainly not the Aurora service itself. So it has got a really, really good track record. Aurora's storage is also self-healing, and the data blocks and disks continuously are scanned for errors, and they're repaired automatically. And then with Aurora, you get read replicas as well, and you get 2 different types. You get the Aurora replicas, and there's currently 15 available. And then you can also have MySQL read replicas of your Aurora database, and there's currently 5. And this is a table that compares the 2. So we've got our Amazon Aurora read replicas, and we've got our MySQL database read replicas. And just notice the automated failover. You can automate a failover from one Aurora database to an Amazon Aurora read replica, and that is automated. Whereas if you have a MySQL database as your read replica, you cannot automate a failover for that. In terms of backups with Auroras, automated backups are always enabled on Amazon Aurora DB instances. Backups do not impact database performance, and you can also take snapshots with Aurora, and this also does not impact performance. And you can actually share your Aurora snapshots with other AWS accounts. So what I'm going to do now is I'm just quickly going to pop over to the console, and we're going to create an Aurora read replica of our RDS instance. Okay, so here I am in the AWS console. You can see that my RDS instance, my read replica, has been deleted successfully. And what I'm going to do now is I'm going to go in here and I'm going to go to Actions, and I'm going to go ahead and create an Aurora read replica of my RDS instance. And this is going to take my MySQL database and it's going to make it an Aurora read replica. And you can create the replica in a different availability zone if you want. I am going to do that. I'm just going to call my DB instance identifier a Cloud Guru Aurora. And then I'm going to scroll down. I'm going to leave basically everything else as default. I'm not going to turn on encryption. I'm going to leave backups on for 1 day. And I'm going to go ahead and create my read replica. And so that is now creating an Aurora read replica. And you can see it in here. So we've got a Cloud Guru Aurora cluster, and it's going ahead and creating my read replicas, which are a read replica of this. So that is going to take some time. So I'm just going to pause the video and wait for this to come back up online. Okay, so that has now finished, and you can see here we've got our Aurora cluster, and inside our cluster we've got 2 nodes. We've got a writer node, and then we've got a reader node. And you'll notice that they're in separate availability zones. And if we click on the writer node and actually click inside it, we'll be able to see the DNS endpoint. The writer node has a different DNS endpoint to the reader node. So they are definitely separate databases in separate availability zones with separate DNS endpoints. Now what you can do is you can go over to your writer node and you can go to Actions, and then you can go and promote this read replica. So you can go ahead and you can do this to the reader node as well. I am going to promote this read replica. I'm just going to go ahead and do that now. That again is going to take a little bit of time, but once that's done, essentially what's happened is that we have migrated our database from a MySQL database to an Aurora database simply by creating a read replica and then promoting that database to its own standalone database. Another thing we can do is we can go in and take a snapshot of our Aurora database, and then we can restore a new Aurora database from that snapshot. So there's a few ways in which you can migrate your MySQL workloads to Aurora, but the great thing is it doesn't involve any, you don't have to go in and copy from one database to another. Amazon take care of it all for you. You can do it all through the management console. So feel free to go back to your databases section if you don't want to wait for that instance to be promoted to a primary instance, and feel free to go through and start deleting your clusters as well as your MySQL database. We don't need them anymore. So I'm going to go ahead and stop and hit stop, and then I'm going to go through and delete that as well. Also, don't forget to go over to EC2 and to delete your EC2 instance as well. So on to my exam tips. So going into your exam, just remember what Aurora is at a high level. It's Amazon's own proprietary database that's compatible with MySQL as well as PostgreSQL, and 2 copies of your data is contained in each availability zone with a minimum of 3 availability zones. So you'll always have 6 copies of your data. Remember that you can share Aurora snapshots with other AWS accounts. And remember that there's 2 types of replicas available. We've got Aurora replicas and MySQL replicas, and automated failover is only available with Aurora replicas. We also learned that you can do migrations from MySQL to Aurora simply by creating read replica and promoting it, or you can do it by creating a snapshot and then restoring from that snapshot as well. And then Aurora has automated backups turned on by default, and you can also take snapshots with Aurora, and you can share these snapshots with other AWS accounts. So that's it for this lecture, guys. In the next lecture, we're going to go ahead and look at Elasticache, and then we're almost finished this section of the course. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. This lecture is on Elasticache, and this is the last database service we need to cover in this section of the course before we move on to our summary, and then we can move on and learn all about Route 53 and networking. So what is Elasticache? And we did cover this off in the Database 101 lecture, but basically it's a web service that makes it easy to deploy, operate, and scale in-memory caching in the cloud. And the service improves the performance of web applications by allowing you to retrieve information from fast managed in-memory caches instead of relying on slower disk-based databases. So what does that actually mean? Well, essentially, if you go to, let's say, Amazon.com, and you've got, you go into, I don't know, the technology department, and you see the 10 topmost, purchased items. What essentially is happening there is the EC2 instances, they aren't making those queries back to an Aurora database. What they're actually doing is they're making those queries back to Elasticache, and Elasticache is storing those queries in there, and it helps take off some of the performance impact because you're not constantly querying your main production database for the same queries. So you're going to cache your most queried information in Elasticache. And Elasticache supports two open source caching engines. So we've got Memcached and we've got Redis. So what is the difference between Memcached and Redis, and when should you use one over the other? Well, if you just want a really simple cache to offload your database, then you definitely want to use Memcached. It's able to scale horizontally and you get multi-threaded performance. If, however, you're going to need things like advanced data types, if you're going to need ranking and sorting data, if you're going to need pub/sub, so publishing and subscribing capabilities, if you need multiple availability zones or persistence, or you need the ability to do backup and restores, then you're going to use Redis. So if you want multi-AZ backups and restores, and it's more sort of advanced data types, then you're going to use Redis. If you just want something simple and easy to get started with, then you want Memcached. So go on to my exam tips. Just remember the main thing you need to really understand going into the Certified Solutions Architect Associate exam is the use case for Elasticache. So it's used to increase your database and web application performance. And common exam scenarios will be, hey, your database is overloaded. What 2 steps could you take to make this database perform better? One is to add a read replica and then point your reads to your read replicas. And then the other is to use Elasticache. At the Certified Solutions Architect Associate level, you're not really required to know the difference between Memcached and Redis, but you definitely need to know it going into the Certified Solutions Architect Professional exam. Just remember that Redis is multi-AZ,
and you can do backups and restores of Redis. So that is it for this lecture, everyone. If you have any questions, please let me know. If not, feel free to move on to the next lecture where we're going to summarize everything we've learnt in the databases section, and then that is it for databases. So if you've got the time, please join me in the next lecture. Thank you.
Okay, hello Cloud Gurus, and welcome to this lecture. So congratulations, you're at the end of the databases section of the course. In this lecture, we're just going to summarize everything we've learnt about our databases. So we learned about RDS. This is used for online transaction processing. Comes in 6 different flavors. We've got SQL Server, MySQL, PostgreSQL, Oracle, Aurora, and MariaDB. We then have Amazon's DynamoDB service. This is a NoSQL database service available to us. We are going to create our own DynamoDB table in the serverless section of the course. We'll get more hands-on with that. We then learnt about Redshift, Amazon's data warehousing solution, and this is used for online analytics processing. We then also learnt about Elasticache. This comes in 2 different flavors, Memcached and Redis. Memcached is used if we want something very, very simple, whereas Redis is used for more advanced data types and if we need multiple availability zones or if we need to be able to do backups. In terms of relational databases, just remember the following points. RDS runs on virtual machines and you cannot SSH into these operating systems. You cannot log in, so you can't RDP using Windows and you can't SSH to your Linux operating systems. And that is a really important point to remember for your exams. Patching of the RDS operating system and database itself is always going to be Amazon's responsibility because you do not get operating system level access. Remember that RDS is not serverless. However, there's an exception to the rule. There's Aurora serverless, and that is serverless. So almost everything in RDS is not serverless, with the exception of Aurora serverless. DynamoDB is serverless, however. Remember, there's 2 different types of backups for RDS. We've got automated backups, and then we've got our database snapshots.
So moving on to read replicas. Read replicas can be multi-AZ, and they are primarily used to increase performance. And this is a very common exam scenario. Basically, you've got a struggling database. It's got very heavy read traffic. Maybe it's a WordPress blog or something like that. How do you increase the performance performance on that database. And one of the answers is, of course, to add read replicas and to point your EC2 instances to those read replicas. Just remember to enable read replicas. You must have backups turned on. And read replicas can be in different regions as well as the same region. So you can have read replicas around different regions in the world. And read replicas can be MySQL, PostgreSQL, MariaDB, Oracle, and Aurora. The only database engine or RDS engine that doesn't support read replicas at this time is SQL Server. And remember that read replicas can be promoted to a master, but when you do this, it's going to break the read replica. So it's going to break the replication.
Remember that multi-AZ is used for DR only. It is not used for performance, and you can force a failover from one availability zone to another by rebooting the RDS instance. Remember that encryption is supported for MySQL, Oracle, SQL Server, PostgreSQL, MariaDB, and Aurora. Encryption is done using the AWS KMS service or key management service. And once your RDS instance is encrypted, the data stored at rest in the underlying storage is going to be encrypted, as well as when you do automated backups, read replicas, and snapshots, they're also all going to be encrypted as well. DynamoDB, serverless, like I said, it's stored on SSD storage. It's spread across 3 geographically distinct data centers. You have 2 different types of consistency. Remember the 1 second rule. So you've got eventual consistency. So if your application doesn't need to read your updated data within 1 second, then you want eventual consistency, and this is what you get by default. If, however, your application needs that data to be updated, it always has to have a perfect copy of the data, and certainly within less than 1 second, then you probably want strongly consistent reads. Moving on to Redshift. Redshift is used for business intelligence. It's only available in 1 availability zone right now. When you're doing backups, Redshift has backups enabled by default with a 1-day retention period. Just like with RDS, you can extend this retention period to 35 days. Redshift will always attempt to maintain at least 3 copies of your data, the original and replica on the compute nodes, as well as a backup in Amazon S3. Remember that Redshift can also asynchronously replicate your snapshots to S3 in another region for disaster recovery. Moving on to Aurora. Aurora is seriously cool. It's always going to have 2 copies of your data contained in each availability zone with a minimum of 3 availability zones. So you're always going to have 6 copies of your data. And you can store, you can actually go ahead and take a snapshot of your Aurora database, and you can actually share that with other AWS accounts. Remember that 2 different types of read replicas are available. So you've got Aurora replicas and you've got MySQL replicas, and automated failover is only going to be available with your Aurora replicas. And Aurora has automated backups turned on by default. You can also take snapshots with Aurora, and you can share these snapshots with other AWS accounts, which is what I said earlier. Elasticache. So remember that you use Elasticache to increase database and web application performance. It does this by caching. If you need multi-AZ, then you're going to be using Redis. If you need backups, then you're going to be using Redis. So that is it for this section of the course, guys. If you have any questions, please let me know. If not, feel free to move on to the next section. Thank you.
Okay, hello Cloud Gurus and welcome to this lecture. So hopefully you're enjoying the course so far. You are a fair way into it by now, and you are learning an awful lot about AWS. Hopefully you're enjoying it as well. I wanted to tell you about a competition we run every single week. It's called Guru of the Week. What we do is we post a professional level question, so a really, really hard question each week to our Facebook page. And what you can do is click through and go and answer that question on our discussion forums. Each week what we do is we choose one answer that's correct and also that has the best explanation as well. And what we do is we then send an exclusive t-shirt. So this is the t-shirt here. Seriously, I don't even own one of these. It's only for winners of Guru of the Week. You get a sticker and you get a hand-signed card by me. And you also go into the draw to win a free ticket to reInvent for 2018. This will give you lots of practice for answering professional level questions. So if you do want to go on and do your professional certifications, this is a great way to practice as well. And it's completely free to enter, and like I said, you can win really awesome prizes and a free ticket to reInvent 2018. So make sure you check it out. We announce the winner every single week on our weekly TV show AWS This Week. So that's it from me, guys. Keep being awesome. I'll see you in the next lecture.
Okay, hello Cloud Gurus and welcome to this section of the course. So this lecture is called DNS 101 and we're going to be looking at Amazon's DNS service, which is called Route 53 throughout the rest of this section of the course. Now, first of all, you might be wondering, where did they get the name Route 53 from? Well, if you know a little bit about US history, the very first interstate was Route 66. It was the very first road that went from one side of the country to the other. And with DNS is actually on the port 53. So that's where Route 53 gets its name. And that is actually a popular interview question at AWS. So if you are going to try and get a job at AWS as a solutions architect or as a technical account manager, that's where Route 53 comes from.
So Route 53 will probably come up 4 or 5 times in your exam. The exam questions are random, so it really depends, which questions you get, but it is definitely a heavily tested topic. And to be honest, if you want to work as a solutions architect in real life, you're going to need to understand DNS back to front. Now in this lab, we are going to go out of free tier because we're going to set up 3 EC2 instances.
This section of the course could cost you money if you follow along, or you can just watch me do it myself. So let's start with DNS. What is DNS? And I want you to think of a phone book, and that's the easiest way to remember what DNS is. I know we don't really have phone books anymore, but if hopefully you can still remember them, or maybe I'm just getting old. So if you've used the internet, you've used DNS. DNS is used to convert human-friendly domain names, such as a Cloud Guru, into an IP4 or IP6 address, such as HTTP 82.124.53.1. So IP addresses are used by computers to identify each other on a network, and IP addresses come in 2 different forms, IPv4 and IPv6. And this one, the 82.124.53.1 is an IPv4. So that's all DNS is. It's a way of looking up a domain name and getting an IP address. Just like when you used to look into the yellow pages, you'd look up someone's name and you'd get their telephone number. So let's talk about IPv4 versus IPv6. And IP4 addresses have been running out. They've been running out for ages. That's why we invented IPv6. So IPv4 is a 32-bit field which has over 4 billion different addresses. And essentially it has a finite number of addresses. And this worked really well in the early days of the internet because we just didn't have that many devices online. Nowadays, everyone's mobile phone, everyone's computer, everyone's fridge, everyone's Alexa, they all have unique independent IP addresses, and we've just run out of space. And to help you visualize this, I want you to imagine that each IPv4 address is a single grain of sand. If you were to take all the IPv4 addresses and add them up together, they would be enough to fill a dump truck. So that's how many IPv4 addresses there are. We created IPv6 to solve this problem of running out of IPv4 addresses. And IPv6 has an address space of 128 bits. And in theory, this is basically 340 undecillion addresses. So if you then turn this analogy on its head and you take a single grain of sand for 340 undecillion addresses, it's enough to fill up the sun. That's how many IPv6 addresses that there are. Now, a big problem is a lot of ISPs are just not switching over to IPv6. So we're in this sort of weird world right now where we're using both IPv4 and IPv6. But I'm sure that is going to change in the next decade or so. So now that you know what IPv4 is versus IPv6, we're going to talk about top-level domains. And if we look at common domain names such as google.com or bbc.co.uk or acloud.guru, you'll notice a string of characters separated by dots or periods. And the last word in a domain name represents the top-level domain. The second word in a domain name is known as a second-level domain name. And this is optional though, and it depends on the domain name. So we've got .com, that is the top-level domain. .edu is a top-level domain. .gov is a top-level domain. In the UK, we have a lot of .co.uk. So .uk is a top-level domain name, and then the .co is known as the second-level domain name. So that's the difference between a second-level domain name and a top-level domain name. Similarly, in Australia, we've got .com.au. So top-level is .au, and then the .com is the second-level domain name. So these domain names are controlled by the Internet Assigned Numbers Authority, or IANA. And this is in a root zone database, which essentially is a database of all available top-level domains. And you can go and view this database just by visiting iana.org /domains/root/db, and that will give you all the top level domains that are available. Now, because all the names in a given domain have to be unique, there needs to be a way of organizing this all so that all domain names aren't duplicated. And this is where domain registrars come in. And a registrar is an authority that can assign domain names directly under one or more top level domains. And these domains are registered with Internet, which is a service of ICANN. And ICANN basically enforces the uniqueness of domain names across the internet. And each domain name must be registered in a central database known as a WHOIS database. And popular domain registrars include Amazon themselves. It's relatively recent that Amazon have become a domain registrar, but it makes our lives so much easier. When I first started recording the courses, we had to go and buy the domains from GoDaddy and then transfer them over to Amazon. GoDaddy.com is a very famous one. 123reg in the UK is also very famous, etc. So these are places where you can go and buy domain names. Now, when you've bought a domain, every DNS address begins with a start of authority record, or an SOA. And the SOA record stores information about the name of the server that supplied the data for the zone, who the administrator of the zone is, so this could be your system administrator, the current version of the data file, and then the default number of seconds for the time to live file on resource records. And we'll come to what a TTL is in a second. We did kind of cover it off in the Cloud Front lecture. Now, if all this sounds a bit too technical for you, don't worry, it's going to get simpler. So we know what a start of authority record is. It's where our DNS is going to start. We now need to understand what an NS record is. And an NS just stands for name server records. And they're used by top-level domain servers to direct traffic to the content DNS server. And the content DNS server contains the authoritative DNS records. So let's look at an example to make this all make sense. So we've got our user, and they type into their browser, hellocloudgurus2019.com. And their browser doesn't know the IP address for that domain. So what their browser does is it goes to the top level domain server, and essentially it's querying it for the authoritative DNS records. It's saying, hey, I've got this domain called hellocloudgurus2019.com. I need to know the IP address for it. Now, the top level domain doesn't contain the IP address. It's going to contain something similar to this. So it's going to have the the top level domain. It's going to have the top level domain, and then it's basically going to have the name server. So it's going to give it a name server record, and it's going to point to ns.aws.dns.com, and that's the name server record. We then go and query the NS records, and the NS records are going to give us the start of authority. So it's going to give us the start of authority, and inside the start of authority, that's where we're going to have all our DNS records. And our DNS records consist of different things. So we've got our A record, and this is the most fundamental type of DNS record. The A in A record stands for address, and the A record is used by a computer to translate the name of the domain to an IP address. So for example, www.acloud.guru might point to http 123.10.10.80. So that's all an A record is. It's just like the phone example, the phone book example that we were talking about earlier. It's going to take a name and give us an IP address. Now, we have sort of touched on TTLs before. We touched on them in CloudFront. A TTL is basically the length that a DNS record is cached on either the resolving server or on the user's own local PC, and it's equal to the time to live in seconds. So TTL just stands for time to live. And the lower the time to live, the faster there is changes to DNS. And the lower the time to live, the faster changes to DNS records take to propagate through the internet. Now, with most providers, the default time to live is 48 hours. And that can be quite frustrating because if you do make a DNS change, that DNS change can take 48 hours to propagate throughout the entire internet. If someone has just visited your website, they're going to cache that DNS address. So it might be an IPv4 address, and it will be cached for the time to live. And if that's 48 hours, it means if you go in and change that IP address, that could take 48 hours to take effect. And this is my Twitter. Go ahead and follow me. I don't have actually all that many followers compared to how many students I've got. But this is one of my favorite tweets. I tweeted this the 6th of December. And this is a haiku. And it says, "It's not DNS. There's no way it's DNS. it was DNS. And if you're a system administrator, I'm sure you'll find that funny. The reason this is funny is because of the time to live. It can just take 48 hours to do a change, and you're ripping your hair out. You're trying to figure out what the hell is going on, and it's a DNS issue. It's a time to live issue. You have to wait those full 2 days before that change goes in and takes effect. So we've covered off A records. What's a CNAME? Well, a CNAME stands for a canonical name, and it can be used to resolve one domain name to another. For example, you might have a mobile website with the domain name m.acloud.guru, and that's used for when your users browse to a domain name on their mobile devices. You may also want the name mobile.acloud.guru to resolve to the same address, and instead of having two separate IP addresses, you just map one to the other. And if you've been looking at this Yellow Pages one, you can see Batman in here, and then it goes C West Adam. So it does not giving us an IPv4, or it's not giving us a telephone number. Actually, it's just giving us another reference that we can then go up and look, and then that will give us our IPv4 address. That's all a CNAME is. And alias records are used to map resource records in your hosted zone to elastic load balancers, CloudFront distributions, or S3 buckets that are configured as websites. And alias records are effectively just the same as a CNAME record, and it allows you to map your DNS to another target name. There is a crucial difference, however. A CNAME can't be used for naked domain names. So our naked domain name is sometimes called a zone apex record. Basically, it's the entire domain without a www in front of it, or without a mobile dot, whatever your domain name is, etc., etc. So that's all a naked domain name is. So a CNAME can't be used for naked domain names. You can't have a CNAME for acloud.guru. It has to either be an A record or an alias. And again, we're going to have a look at this in the labs. We're going to go in and set up our very first alias, and that will point to our little EC2 web servers that we're going to provision around the world. And I know sometimes this can sound really complicated, and like I always say, the best way to learn AWS is to get your hands dirty with it. So don't worry if none of this is making sense just yet. It will after we've finished the labs. So onto my exam tips, and I appreciate we have not yet covered elastic load balancers in any detail. The reason for that is we're going to cover it in the high availability section of the course. Elastic load balancers are crucial to understand in order to pass your Certified Solutions Architect Associate exam. You're going to have at least 10 questions on there. But really we need to understand DNS, and we really need to understand VPCs before we can look at elastic load balancers in any kind of detail. So we're going to do those two things first. That being said, what you do need to know going into your exam for Route 53 is that elastic load balancers never have a predefined IP4 address. You always resolve to them using a DNS name. So just remember that. You're never going to get an IPv4 address for an elastic load balancer. You really need to understand the difference between an alias record and a CNAME. So just remember, when we're doing our zone apex record or our naked domain name, and we're trying to point that towards an EC2 instance, for example, we're going to be using an alias record. We're not going to be using a CNAME. So if you're in the exam and you're given a choice between an alias record and a CNAME, always choose an alias record. And then just remember some common DNS types. So we've got our start of authority record, we've got our NS record, then we've got our A records, our CNAMEs, our MX records, which are used for mail, and then a PTR record is essentially it's the reverse of an A record. So it's a way of looking up a name against an IP address. So now that we've had a crash course on DNS, what we're going to go ahead and do is we're going to go in and register a domain name, and we're going to start provisioning 3 little EC2 instances around the world as little web servers, and then we're going to be ready to start on the Route 53 section of the course. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. In this lecture, we're going to go ahead and register a domain name. The easiest way to learn anything with AWS is to start using it. So we're going to register a domain name, and then we're going to go in and start looking at all the different Route 53 routing policies. And what we're going to do is we're going to use this domain name to try out the different routing policies. So in this lab, we're going to go ahead and register a domain name, and then we're going to go in and set up 3 EC2 instances, each one one is going to be in a different area in the world. And then we'll be ready to start learning about the different Route 53 routing policies, and then we'll actually be able to go in and start testing them. So this is a lab, and you will need to log into the AWS console. Okay, so here I am in the AWS console. I'm going to go over to services. Now you'll find Route 53 under networking. So if you just scroll down, here it is, networking and content delivery, and you go ahead and click on Route 53. So the very first thing we're going to do before we get started with the Route 53 is we're going to go in and we're going to register a domain name. So we're going to go down here and hit domain registration. Now, domain registration is not free, so do bear that in mind. I'm going to go ahead here and hit register domain. And then you just have to pick a domain name that you want. So I'm going to go ahead and register a domain, something like Hello Cloud Gurus 2019. Let's see if that is available. I'm going to go ahead and check, and it is available. So hellocloudgurus2019.com is available. So I'm going to go ahead and add that to my cart. And then what I'm going to do is I'm going to scroll down and hit continue. Now you have to go in and fill out the registrant contact, because that does contain quite a lot of personal information, including my phone number. I'm going to go ahead and fill it all out, and then I'm going to go ahead and hit continue. So I'm just going to pause the video here. Once you've done that, you'll see this screen, and all you need to do is accept the terms and conditions and go ahead and complete your purchase. And that has now been registered. Sometimes domain names can take up to 3 days to complete, so do bear that in mind. But it's normally a lot quicker. It will usually take 1 or 2 hours. And you'll be able to see your domain in here. So we can see hellocloudgurus2019.com. The domain registration is in progress. And if we click on registered domains, we can't yet see it in here. But once that is registered, it will appear here. So I'm just going to pause the video for a couple of hours, and I'm going to wait for this to register. Okay, so I'm just going to go ahead and refresh the page, and we can now see that the domain registration has been successful, and I can see it in my hosted zone. So if I go in here, this is my hosted zones, and this is where we go in and configure Route 53. We basically go in and add things like A records and C names, etc. So we are going to do this in the next lab, but first what we need to do is we need to go over and provision our EC2 instances. So let's go over to EC2. So right now I'm in the Irish region, and I'm going to go ahead and launch an instance. Now I want you to think about where it is you are. So physically I'm based in London, and I want to use a region that's very close to me, because we're going to be looking at latency and then geographical routing as well. So I'm going to pick Ireland. I also want a region that's very far away from me. So Sydney is basically the opposite side of the world. So I'm going to pick Sydney. And then I want somewhere sort of in between. So I'm going to go ahead and pick Ohio. So I'm going to launch into the Ohio region, the Sydney region, and into the Irish region. Now, if you haven't used one of these regions before, you will have to set up a security group, and you will have to get your key pair. We're going to use a Bootstrap script, so scroll all the way down. This Bootstrap script is available in the resources section of the course. All it's doing is it's doing a yum update, it's installing Apache, it's making sure Apache restarts if the EC2 instance goes down. It's then starting the Apache service, it's going over to our var www.html directory, and then it's basically making a little web page. And it says, hello Cloud Gurus, this is X web server. And then it's going to output that to index.html. So you will need to change the X to whichever region that you're in. So I'm just going to copy this into my clipboard, going to paste it in here, and I'm going to go ahead and change it. So this is the, and then Irish web server. And then I'm going to go ahead and add my storage. And if you don't want to watch me go through all this, feel free to skip ahead. I know it can be quite a little bit boring. Just jump ahead to about 6 minutes 30, and that's where we'll cover off my exam tips. So I'm going to add my web DMZ security group, go ahead and hit review and launch, and then I do have access to this key pair. And then the next place I'm going over is to the Sydney region. I'm going to do exactly the same thing. I don't think I've ever used the Sydney region in this account, so I will need to create my own security group and download my key pair. So I'm just going to go over to Sydney. I'm going to go ahead and launch my EC2 instance. I'm going to leave everything as default. Again, I'm going to go to my advanced details. I'm going to paste this in here, and I'm going to change this to the Sydney web server. I'm going to add my storage, leave that as default. I don't need any tags. I'm going to create a new security group, call it web DMZ, and I'm going to open up port 80 to the world, and there we go. And then I'm going to go ahead and launch that, and I need to create a new key pair. I'll call it my Sydney key. I'm going to download that. And now I'm going to go ahead and launch my instance. So that's launched my instance in Sydney. And then finally, I'm going to go over to the Ohio region. So Ohio. And then I'm going to go ahead and launch my instance in there. So again, I'm going to use Amazon Linux AMI. I don't think I've ever used the Ohio region